Python is the hottest programming language in the industry right now. And that is why people skilled in Python get an average salary of $100,000. And the best part about Python is it is extremely versatile. So if you're skilled in Python, you'd be able to get a job as a full stack developer or a game developer or even a machine learning engineer. To understand the importance of Python, we have come up with this Python tutorial.
Before we get started, I want to introduce you to Great Learning Academy, a free initiative by Great Learning. You can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion. Check out the link in the description of the video below. If you haven't yet subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you do not miss out on any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I'll respond to your comments.
Now let's have a quick glance at the agenda. We'll start off with a quick intro to Python and then also look at some of the Python IDEs. Then we will look at some of the data structures in Python, which would be tuple, list, set, and dictionary. Going ahead, we will understand the importance of flow control statements and functions and also be implementing them in Python. After which we will understand what exactly is object-oriented programming and also implement the concepts of OOPs. Then we will know about Numpy. Then we have this library called as Pandas, with the help of which we can perform data manipulation. After that, we'll see how to do data visualization with Matplotlib and Seaborn libraries. And finally, we'll be looking at 3 to 4 Python projects, which would cover whatever we have learned in this entire tutorial. So let's get started. We'll start off this session by installing Python into our systems. And to install Python, we'd have to go to this particular site over here, Python org downloads. Let me just go ahead and click on this link. So as you see, since Python is platform independent, whether you have a Windows system or a Linux system or even a Mac, you can download Python for either of these operating systems. And since I'm using a Windows system, all I have to do is click on this particular link and Python would be downloaded. Now, after downloading Python, we would need an IDE. So what exactly is an IDE? IDE stands for Integrated Development Environment. Now, if you just download Python, we would also need some environment which would make our coding much more easier. So if you have worked with other programming languages such as C, C++ or Java, then you would know that you would have used an IDE for these languages as well. So if you have worked with Java, then you would have used an IDE called as Eclipse. Similarly, if you have worked with C or C++, then you would have worked with IDEs such as Turbo C++ or Dev C++. So similarly, we've got a lot of IDEs for Python. So one such IDE for Python is Pycharm, and we can download Pycharm from this particular link, jetbrains.com/Pycharm. I'll just click on this over here. Then I'd have to click on this download button. And as you see, we've got the professional version and the community version. And if we want it for just single user development, we can just go ahead and download this community version over here. And similarly, as you see over here, we've got, if you use a Windows system, then you can download Pycharm for Windows. If you have a Mac, then you can download Pycharm for Mac. Similarly, if you have a Linux, then you can download Python for Linux. Since I have a Windows system, I'll select this and I'll go ahead and download the community version of this. Then we have something called as Anaconda, which is actually a Python and R distribution. So if you want to perform any sort of machine learning task or data science task, then Anaconda is a complete toolkit. So this provides you with a lot of tools involving Python. So it will provide you an IDE called as Jupyter Notebook, and not just the IDE. Along with the IDE, it will also provide you with a lots of libraries such as Matplotlib, Seaborn, Pandas, and Numpy. So you don't have to manually install these libraries. So once you go ahead and install Anaconda, so you can install Anaconda from this particular site over here. Over here, you see the products tab. Click on the individual edition, which is the open source one. Then just go ahead and scroll down. So you have the download button over here again. And since I have a Windows system, I'll just go ahead and download the 64-bit graphical installer. And since this is a lot of MB, which is 466 MB, and since I don't want to use up my data pack, I'll just go ahead and cancel this because I already have Anaconda installed into my system. Now, once we have installed Anaconda, as I've told you guys, Anaconda comes up with an IDE called as Jupyter Notebook. So what is Jupyter? It is a browser-based interpreter that allows us to interactively work with Python. So all of our Python code will be implementing in this Jupyter Notebook. And if you have to open Jupyter Notebook, I'll just show you how to do it. So here on your search bar, go ahead and type in Anaconda. So you'd have to select this over here, Anaconda prompt. Now in Anaconda prompt, you would have to type Jupyter Notebook, and let's just wait for the browser-based interpreter to open up. So this, what you see, is called as the Jupyter Notebook, which is a browser-based Python interpreter and will be writing all of our Python code over here. Now, if we want to open up a new Python notebook, click on this tab and select Python 3. Now, once this is done, we have opened up our new Python notebook. So you have a lot of tabs over here. So similarly, if you want to create a new notebook, select File. Then you have this new notebook option. Again, you can go ahead and select Python 3. And as you see over here, this is our new notebook. I'll just close this up over here. Then let's say if you want to download the code file which you've written, you have this download as option. And over here, normally, whenever we want to download the Jupyter Notebook, we download it as .ipynb file, which basically stands for Python Notebook, IPython Notebook. You can also download it as other formats. If you want to just save it as a simple Python file, you can just select .py over here. You can also go ahead and save this file as a HTML doc or maybe a LaTeX doc. And if you want to save, you have the save as option over here. And similarly, you can go ahead and rename your notebook. Either you can select this or you can just click over here. Then you can go ahead and rename it. So I'll just write it as my Python notebook, and then I'll rename this file over here. Now let's go ahead and write our first Python program. So to print something out on the console, we would have to use the print command. Then I'll give this parenthesis over here. I'll use double quotes, and inside this I will give in the command, this is Sparta. And I'll just go ahead and click on run. And as you guys see, we have successfully printed out this is Sparta. We have written our first Python program in Jupyter Notebook. Now we are on our way to happily go and hack the NASA systems. So this is our building stone, guys. We can go ahead and do a lot of things with what we've learned with this. Now, you have something called as a kernel over here. So what exactly is a kernel? You can consider this kernel to be the executor of this program. So whenever you write a piece of code and you'd want to execute it, you click on kernel, and this is what actually runs your entire code. Then let's say if you want to add a new cell above this. So this, what you see, is called as the cell. And if you want to add a cell above this, you click on insert, then you have the insert cell above option. Similarly, let's say if I want to insert a cell below this, I click on insert, I select insert cell below, and this is how I can add another cell. So this was a basic intro about Jupyter Notebook. So let's start off by understanding what exactly are variables in Python. Now, when you work with any programming language, your first task needs to be to work with data, isn't it? So whatever programming language you're working with, you are essentially working with data. But the question over here is, how do you actually store the data that you work with? So let's say you're working at a company and you want to store the names of all of the employees. So we start off with taking 3 employee names. So let's say we have John, Sam, and Matt with us, and we'd have to store these names somewhere. So where can we store them? This is where a variable comes in. So you can consider a variable to be a temporary storage space. Now what we'll do is we'll take this string value. So this, what you see inside double quotes, is known as a string, and we'll take the string value and we will store this in this variable called as student. Either we can call the student or employee or whatever we want to. And this variable will have a particular address associated with it. And since this variable is a temporary storage space, the values which are stored inside it can be changed again and again. So initially, we are storing this value John inside this variable employee or student. Then after some time, we can go ahead and replace this value John with this value Sam. Similarly, after some time, we are changing this value of Sam with this value of Matt. And this is how variables work in Python. So now let's go to Jupyter Notebook and I'll give you a proper example of this. Here what I'll do is I'll create a variable called as var1. I'll give in this equal to symbol and I'll go ahead and store the value John inside this. Let me click on run. Now let me print out this print of var1 and let's see what will be the result. So we have successfully stored the value John inside var1 and we were able to print this out. And since var1 is a variable, it is a temporary storage space. So that is why we can change the value which is stored inside this. So now instead of John, I want to store the value Sam inside this. I'll click on run again. I'll use print and then I'll be printing out the value of var1. And as you guys see, initially we had John inside this. We were able to change this to Sam. Now again, after some time, I'll go ahead and change this value to Matt. Now let me print out var1 over here. Print of var1. And as you guys see, initially we had John, then we changed it to Sam. And finally, we have changed it to Matt. So that was a basic intro to variables. Now, another thing to be kept in mind is every variable has a data type associated with it. So when you're working with data, that data can be present in any format. So when you're working with numbers such as 10, 500, minus 1000, minus 323, these are called as integers. And when you work with decimal point numbers, so decimal point numbers such as 3.14, 15.97, minus 1.92, all of these would be floating point numbers. Then we have something called as Boolean values. So Boolean values are basically you have only 0 and 1, or you can also tag them as true and false. So you have only 2 values over here and those 2 values are true and false, or you can also tag them as 0 and 1. Then we have strings. So strings are something which you put in single quotes, double quotes or triple quotes. So these are the 4 main data types over here in Python. So let's go ahead and look at an example of each of these. And now I'm going to start off by creating an integer variable. So I'll name this integer variable as num1 and I'll store the value of 10 inside this. And just to see what is the data type of this, I will use the type method. And inside the type method, I'll be passing in num1. And as you guys see, this tells us that the data type of this particular variable is integer. Then I'll go ahead and pass in a floating point number or a decimal number. So I'll call this as, let's say, decimate, and in decimate maybe I'll store in the value of 3.14. Now let me go ahead and check the type of decimate. So inside this, I'll pass in decimate, and when I click on run, you guys see that this is of floating type. Then we have the next data type, which is of Boolean. So here I will have maybe another variable called as log1, and inside log1 I will store in the value true. Let me hit run again, and then let me check the type of log1. So inside type I will pass in the variable log1, and as you guys see, this tells us that this is of bool. Bool basically means this is of Boolean or logical type. And then we've got the character or string. So this time I'll have my variable as char1, and inside this I will store the name. Let's say I'll store the name Arjun over here. Then let me check the type of char1, and when I hit run, you see that this tells us that this is a string type variable. We also have another variable over here, or another data type over here, which is of complex type. So complex is basically a data type where you have a real part and an imaginary part. So let's say if I write something called as 3 plus 5j. So here 3 would be your real part and 5j would be your imaginary part. You would have learnt about complex numbers in your primary or in your secondary school. So normally in math, this j is represented as I. So you'd have something called as 3 plus 5i, where 3 would be your real part, 5 would be your imaginary part. So in Python, this I is represented with j instead of I. So now I'll go ahead and store this in a variable called as comp1. Now let me go ahead and check the type of this. So type of comp1, and I see that this is of complex type. So we have successfully understood what are variables, and we have also looked at the different data types of variable can have. Now we'll go ahead to the next concept in Python, which will be operators. And as the name suggests, operators help us to perform simple operations on this data. And we've got arithmetic operators, relational operators, and logical operators. So we'll start with the first set of operators, which are the arithmetic operators. Let me go ahead to this Jupyter notebook over here, and what I'll do is I will clear out everything which is present in the console. So this scissors which you see, if you click on this scissors symbol, you will be able to cut out all of these cells. Now let me add a comment. So what is a comment? Comment is something which is not executed by the Python interpreter, and you can add a comment with this hash symbol. So after this hash symbol, I am going ahead and writing arithmetic operators. I'll click on run, and as you see, this is not executed over here. So whenever you add a hash symbol over here, Python interpreter automatically recognizes whatever follows hash symbol as a comment. Now if I remove this hash symbol and then if I click on run, you'd see that we get this error which tells us that this is invalid syntax, because if we don't add the hash symbol over here, then Python interpreter would consider these two actually as two separate variables. And since we have not declared any variable called as arithmetic or as operator, this is giving us this error. So I'll just go ahead and add this hash over here. Now after this, since we have to perform arithmetic operators, and arithmetic operators basically constitute of plus, we have plus, then we have minus, then we have multiplication, and then we have division. Now I'll create two variables over here. I'll have first variable num1, and I'll store the value of 10 inside this. Then I'll have the second variable num2, and I'll go ahead and store the value of 20 inside this. Now after creating these two variables, let me perform the basic arithmetic operations. So I'll start off by adding num1 and num2. So I'll type num1 plus num2. And when I perform num1 plus num2, I get a result of 30. So basically, if you want to add two numbers, you have to use the plus symbol between those two operands. And since 10 is stored in num1, 20 is stored in num2, we get a result of 30. Then similarly, I'll go ahead and perform the subtraction operation. So here I'll have num1 minus num2. And when I type num1 minus num2, I get a result of minus 10 because 10 minus 20 is minus 10. Going ahead, I'll also perform multiplication. And to perform multiplication, I'd have to type num1 into num2. And when I have num1 into num2 over here, which is basically 10 into 20, I get a result of 200. Then we are only left with division. So to perform division, I'll have num1, then I'll use the forward slash symbol, which denotes division. Then I'll have the second operand over here, which is num2, and I'll click on run. And as you guys see, when we divide 10 with 20, we get a result of 0.5. So these were some basic arithmetic operations. Now we'll go ahead and work with relational operators. So I'll just add another comment over here, and I'll add the comment as relational operators. And what are the relational operators? These help us to find the relationship between two operands. So we can understand if one operand or the value of one operand is less than the other operand, or maybe the value of one operand is greater than the other operand. So we will have less than symbol, greater than symbol, equal to symbol, and not equal to symbol. Now again, we will use the same variables num1 and num2. Let me just print out num1 and num2 over here for your sake. And as you guys see, we have 10 stored in num1 and 20 stored in num2. Now I want to check if the value in num1 is less than the value in num2. So I'll type num1, I'll use the less than symbol, then I'll type num2 over here, I'll click on run, and as you guys see, I get the result as true, which means that num1 is less than 20, which we get because 10 is obviously less than 20. Now, I want to check if the value in num1 is greater than the value in num2. And when I hit run, I get a false value because 10 is not greater than 20. Now going ahead, I want to check if the value in num1 is equal to the value in num2. So this, what you see, is the double equal to operator. You have to understand the difference between the double equal to operator and the single equal to operator. So this is the single equal to operator, and with the help of single equal to operator, we are assigning a value to a variable. But when we are using this double equal to operator, this helps us to understand if these two values, if the operand on the left hand side and the operand on the right hand side are equal to each other or not. And when I click on run, I get a false value because 10 is obviously not equal to 20. Then going ahead, I have the not equal to operator. So I'll have num1. So not equal to operator is represented like this. So I'll have exclamation mark, then I'll have the equal to symbol, then I'll have num2 over here. And I get a true result because 10 is obviously not equal to 20. So these were some of the relational operators. Going ahead, we'll work with logical operators. So I'll add a comment over here, which would be logical operators. And we have two logical operators, which are AND, OR. Let's start with AND. So AND is a logical operator which would give us a true result only when both of the operands are true. But OR is a logical operator which would give us a true result when either of the operand is true. So let's understand this in detail. So this time I will be creating two Boolean variables over here. I'll have log1. And in log1, I'll have the value true stored. Then I'll have log2, and in log2, I'll have the value false stored. So I have log1 and log2 over here. Now, I'll perform the AND operator on both of these. So let me go ahead and type log1 and log2. And when I hit run, I get a false value because Log 1 is true, log 2 is false. True and false will give us a false result. Now, let me see what will happen when I have log 2 and log 1. Again, I get a false result because false and true is also false. Now, let me check log 2 and log 2. Log 2 and log 2 will also give me false because false and false is also false. And finally, I'll check log 1 and log 1. Log 1 and log 1 will give me a true result because AND operator gives a true result only when both of the operands are true. Now we'll head on to the OR operator. So this time I'll have log 1 or log 2. Now true or false will give me a true result because OR will give me a true result when either of the operands is true. Then I'll have log 2 or log 1, and this again gives me a true result because false or true is again true. Then I'll have log 1 or log 2, and this again will, let me actually change this to log 1 or log 1, and this will give me a true result because true or true is also true. And finally we'll have log 2 or log 2, and this is the only case where we'll have a false result, which is false or false. So only in the case where both of your operands are false, that is when you will get a false result when you're working with the OR operator. So this was all about the different types of operators in Python. Now we'll understand what exactly are Python tokens. So Python token is the smallest meaningful component in a program. So when you combine all of these Python tokens together, that is when you get your final Python code. So the basic Python tokens are keywords, identifiers, literals, and operators. So we have already worked with operators, which were one of the tokens in Python. Now we'll go ahead and understand what are keywords, identifiers, and literals. So we'll start with Python keywords. Python keywords, as it is stated, are special reserved words. So when I say special reserved words, you can't use these special reserved words for any other purpose, which would mean that you can't give the name of a variable or the name of a function or maybe the name of a class with these Python keywords. And you have some of these reserved keywords over here, which are if, def, del, true, false, while, not, or, return. So these are some of the Python keywords. Now let me just show you how to use these. So if I type in DEF, so as you guys have seen over here, when I type DEF, this automatically turns into green. So Python interpreter recognizes this word def as a keyword. Now let's say if I try to store something in this def is equal to 10, I get an error. Because since this is a keyword, I can't use this as a variable. Similarly, let's say if I have if again is a keyword, and that is why this turns into green. Then we have something called as identifiers. So identifiers are basically the names used for variables, functions, or objects. So till now we had created some variables called as var1 or num1 or log1. So those all are identifiers. So the names which you give to the variables, functions, or objects are known as the identifiers. So let's say if you have a person and the name of that person is Arjun or Sam or Matt. So here the names of these people are the identifiers. So similarly, as you need a name to identify a human being, that is how you will also need an identifier to understand or to call or invoke a variable, function, or object. And this is the simple analogy between the real life and these Python identifiers. And there are some basic rules when you're working with these identifiers. So the first rule is you cannot have an identifier with special characters. So you can have underscore, but instead of except underscore, you can't have any other special characters in the name of the identifier. And also identifiers are case sensitive. So let's say if you create a variable called as var1 with v in small case, and then you create a variable as var1 with v in capital case, then both of them will constitute as different variables. And then also you have another rule over here which states that the first letter cannot be a digit. So these are some basic rules which normally a Python coder keeps in mind. So let's go ahead and understand about these rules in Python. So I have told you guys that special characters cannot be used in the name. So let's say if I have J% and I have this over here, and if I try to store the value 10 inside this, let me click on run. So you see that we have a syntax error over here. Similarly, what I'll do is I'll have a variable called as n1, and inside n1 I'll store the value 10. Then I'll have the value capital N1, and inside this I'll store the value 20. Now let me print in both of these, N1 with a small n and N1 with a capital N. And as you guys see, both of these values are different because both of those variables are different. So this is about Python identifiers. Then we have something called as literals, and literals are just the constants in Python. So constant is a value which does not change. So whatever values you are storing inside a variable, that is called as a literal. So here when you are storing 10 into n1, 10 would be literal. Similarly, when you are storing the value 20 into n1, 20 would be your literal. Then over here, when you are storing the values such as 10 into num1, 20 into num2, again they are your literals. Now we'll head on to an interesting topic in Python where we'll understand about strings in Python. So what are strings? Strings are basically sequence of characters which are enclosed within single quotes, double quotes or triple quotes, and we already know that, and we have already seen an example of Python strings. So let me just give you an example of all three of these where I'm creating a string with single quotes, double quotes and triple quotes. Let me go ahead and remove all of this over here because I like it clean. Let me just remove all of this stuff from over here. Now what I'll do is I will create a new string variable called as str1, and the value I'll be creating with single quotes, and inside this I'll just type hello world and I'll print out str1 over here, and I have successfully created the string str1 with hello world. Then I'll have str2. And in str2, I'll be creating this with double quotes, and over here, I'll just type in this is Sparta, and I'll print out str2 over here. Going ahead, I'll have another variable called as str3, and this time I'll create a multi-line string. So if you want to create a multi-line string, we can create it using triple quotes. So I'll have triple quotes over here, and inside this I'll just type I am going to France tomorrow. Let me run this and let me print out str3 right now. So as you guys see, I have successfully created a string called as I am going to France tomorrow, and this what you see /n, that indicates a new line. So after I am, we have /n, which tells us that going to comes in a new line. Similarly, we have /n followed by France tomorrow, which tells us that this again is in a new line. So this is some basic idea about strings in Python. Now that we know this, let's actually see how can we extract individual characters from a string. So here we have created a string called as myString. So the name of the variable is myString, and the value which is stored inside this is my name is John. Now if we want to extract individual characters, we'd have to understand the concept of index. So here these characters are present at indices, and the index value starts from 0. So here M is present at index 0, Y is present at index 1, the space is present at index 2. Right, so similarly all of these have a particular index assigned to them and the index value starts from 0. And if you want to extract this particular character or the first character from a string, we'd have to give in the name of the string, we'd have to give in the parenthesis, and inside the parenthesis we will give in the index value that we would want to extract. And since I want to extract the first character, we'd have to give in index 0. And that is how we were able to extract this. Then similarly, if I want to extract the last character, so the index of the last character will be -1. So either you can manually count the last value over here, so that is basically time consuming. So instead of counting the index, if you just want to directly extract the last character, then you can just go ahead and give in -1 and that will automatically give you the last character which is present in the string. So let's go ahead and perform these operations in Jupyter Notebook. Let me add in a new cell over here, insert cell below, and I'll go ahead and create a string called as my string, and over here I'll have, let's say, a string called as my name is John. Let me print out my string over here. Now after this, I'd want to extract the first character. So if I want to extract the first character, I'll just type my string, I'll give in parenthesis, I'll have 1 written over here, and I'll actually have to give 0 because the first character is present at the 0th index. So guys, this is important. You'd have to remember that in Python, the indexing starts from 0. So this is how I have extracted the first character. Now similarly, if I want to extract the last character, which is n, then I will give -1 over here. And as you guys see, I am able to extract the last character. Now similarly, let's say if I want to extract this a. So this is present at 0, 1, 2, 3 and 4. This is present at index number 4. So let me just give in 4 over here. And as you guys see, I have successfully extracted this particular element from this entire string. Now we'll go ahead and work with some string functions. So the first string function is len, which will give us the length or the number of characters which are present in the string. So all we have to do is use len, and inside that we will pass in the name of the string. So when we pass in my string, this tells us that the length of the string is 15. And similarly, let's say if I want to convert all of the characters in the string into lowercase, we have the lower method. So all I'll do is type in my string dot lower, and this will convert all of the characters into lowercase. And a method which is analogous to lower is the upper method. So I'll type my string dot upper, and with the help of this, I'll be able to convert all of the characters into uppercase, which you see in the result over here. So I have my string ready. Now I would want to check the length of this, and inside len I will pass in my string, and this would tell us that the length of the string is 15. Now similarly, as you see over here, we've got 2 capital characters over here. M is capital, J is capital. I'd want to convert them into lowercase. So for that purpose, first I'd have to give in the string name, which is my string. I'll use the dot operator, then I'll use the lower method. And when I click on run, you will see that all of the characters have been converted into lowercase. Now similarly, if I want to convert all of the characters into uppercase, I'll go ahead and type my string. I'll use the dot operator, and then I'll have upper written over here. I'll click on run, and as you guys see, I have converted all the characters into uppercase. Now we'll go ahead and see some more functions. So we've got the replace method over here, and we've got the count method. So if I want to replace some particular character or some particular string with another string, then we can use the replace method. So again, first we'd have to give in the name of the string, which is my string. I'll use the dot operator, then I'll use replace method, and it takes in 2 parameters. The first parameter is basically that character which I'd want to replace. So as you see over here, initially we had y over here. I want to replace that y with a. So initially the sentence was my name is John, but I have changed that to my name is John. So quite an interesting method, isn't it? Then we have the count method. So here we have created a new string where we have stored the value hello hello world. And if I want to check the count of the number of times a word occurs or number of times a particular substring occurs, then we can just pass in the substring into this method. So if I want to understand the number of times this substring hello occurs in this entire string, so if I pass in hello, this tells me that this substring hello occurs 2 times in the entire string over here. So let's work with this replace method and the count method. So we already have this myString variable ready, and let's say instead of my name is John, I would want to change the name over here. So instead of my name is John, I would want to change that to my name is Sam. So I'll have myString, then I will use the replace method over here, and we already know this takes in 2 parameters. The first parameter is the substring which I'd want to replace. So I would want to replace John, and I'd want to replace it with, let me actually keep it like this, and I'd want to replace it with Sam. And when I click on run, you would see that I have successfully changed this substring from John to Sam. Then we have the count method. Let me create this new string variable over here. I'll have new string, and inside this I'll store hello hello world. Now that we have this, what I'll do is I will go ahead and use the count method. So I'll have new string and use the count method, and inside this I'll pass in hello, and when I pass in hello, this tells me that the substring hello is occurring 2 times. Now we have 2 more string functions over here. So now we have the find function. So the find function helps us to find the index or the starting of the index of a particular substring. As you see over here, if I want to know the starting index value of this substring Sparta, I'll just pass this entire substring into this method find. And this gives us the value of 8. So let's just understand this. So now if I count the index, it will be 0, 1, 2, 3, 4, 5, 6, 7 and 8. So as you see, this S is placed at index number 8, and that is what this find method gives us. So let's say similarly, if I would have passed in S into this find method, then this would have given us the result of 0, 1, 2, 3, 4 and 5. Then we have another method called as split. So the split method helps us to divide this string into a list of substrings on the basis of one split criteria. So here we've got this entire string called as I like apples, mangoes and bananas, and I would want to divide this entire string into multiple substrings on the basis of comma. So here, wherever this method encounters comma, it will separate or segregate it into a substring. So I like apples becomes one substring, mangoes becomes second substring, bananas becomes the third substring. Let's go ahead and implement an example of these two. Let me write str1 over here, and what I'll do is I'll just have a new value over here. Let's just say I'll just type I love pizza, and I would want to know the starting index of this substring pizza. So I'll have str1.find, and inside this I'll just pass in pizza, and we get the result of 7. So let's just verify this. 0, 1, 2, 3, 4, 5, 6 and 7. Now we'll go ahead and work with the split method. So for that purpose, we'd have to create a new string value, and I'll name it as fruit. And here I'll just type in I like apples, guavas, bananas, and I'll also write maybe strawberries. Then I'll use the split method, fruit dot split. Inside this, I'll give in the separator, which will be comma, And I've got a list of substrings. I like apples becomes one substring, guavas becomes the next, bananas is the next substring, and then we have strawberries as the final substring. Now we'll go ahead and work with the next data structure in Python, which is a list. So when it came to a tuple, that was an ordered collection of elements enclosed within round braces. But a list is an ordered collection of elements which is enclosed within square braces, and that is not the only difference. So tuples were immutable. That is, when you created the elements inside a tuple, you could not change them later on. But when you create a list, you can actually change the values which are present in it. And this is how we create a list. So L1, that is the name of the list which I'm creating, and I'll have square braces and I'll have these different elements stored inside it. Let me delete all of these over here and let me start fresh for the list. I'll add a new comment which will be list, and inside this I'll name the object as L1. I'll have square braces over here. I'll have 1, A and true. Let me print out L1. And this is our new list. Now let me go ahead and check the type of this. Inside type, I will pass in L1. And as you guys see, this tells us that this is a list. Now, as we had extracted individual elements from a tuple, similarly, we can go ahead and extract individual elements from a list as well. And it is the same process. So over here, we've got all of these elements and the indexing starts from 0. So it is very important. Keep in mind, guys. So the indexing of a list or whatever data structure you're working with in Python, it starts from 0. And if I want to extract the second element over here, the index of the second element will be 1, because this is index number 0, this is index number 1. And when I pass in L1 of 1, I'll be able to extract this particular element from this entire list. Similarly, if I want to extract a series of elements, so I've got all of these. If I want to start from index number 2, so this will be index number 2. So we've got 0, 1 and 2, and this will go on till index number 4. So as I've already told you, when it comes to Python, the outer limit is exclusive. So when we give it till 5, we will be only able to extract till index number 4. So that is why over here we'll be extracting 2, B and 3. Let me create L2 over here and I'll have some elements. I'll have 1, A, then I'll have 2, then I'll have B. After that, I'll have 3, and going ahead, I'll also have C over here. I have successfully created L2. Let me print this out. And now if I want to extract, let's say B from this, let's see what would be the index. It'll be 0, 1, 2 and 3. So I'd have to give in L2 inside the parenthesis. I'd have to give in 3, and I am able to extract this particular element from this. Similarly, if I want to extract the last element, I'll give in L2, I'll give in -1 over here, and I am able to extract the last element. And if I want to extract a series of elements, then in that case, all I have to do is give in L2. And as we saw in the example, if I want to extract 2, B and 3, so the index for this is 0, 1 and 2, I'll give in 2 over here. And if I want to extract till 3, so this will be 2, 3 and 4. So that is why I'd have to give in index number 5 as well. And we are able to extract 2, B and 3 from this entire list. Now, let's see how can we modify a list. So we have the same list over here. And initially at index number 0, we have the element 1. But if I want to change it to some other element, all I have to do is give in the index number and I have to assign a new value to that particular index number. So as you guys see, I am assigning the value of 100 to this particular index number and I'm able to change this value of 1 to 100. Now, we can also append a new element at the end or pop the last element. And to add a new element at the end, we will be using the append method. So we'd have to give in the name of the list, we'll use dot operator, and then we'll use the append method, and we'll just give in the value which we'd want to append. So when I type in Sparta over here, this gets appended at the end of the list. Now similarly, we can go ahead and pop the last element. So if we have to pop the last element, popping basically means removing the last element. So we would have to use L1.pop and it automatically removes the last element. So as you guys see, we had added Sparta, but after using the pop method, this Sparta value was removed from this list. Now we have the same list over here, which is L1. Let me actually, I'll have L2 over here, not L1. Let me print in L2 for you guys over here, and I'd want to change, let's say, this particular value over here. So let's say instead of A, I'd want Z. So I'll have L2 and the index for that is 1. And instead of A, I'd want to store Z inside this. And let me print out L2 again. So initially we had A, but after changing it, we have Z over there. Now we'll see how to append an element at the end of this list. So we'd have to give in L2, I'll use dot operator, then I'll be using the append method. And inside this, I'll just add this word called as Python. Let me print in L2 for you guys. And I have added Python at the end of this. Now if I want to pop this out, I have to write L2.pop, and when I click on run, we see that this has been popped out. And let me print out L2 again for your reference. We see that the last element has been removed. Now there are some more modifications which we can perform on the list. So let's say if we want to reverse the elements which are present in a list. So as you see in L1 we have all of these elements over here, and if I want to reverse the order of these elements, all I have to do is use the reverse method. So I'll type in L1.reverse, and when I print this out, we see that the elements are printed backward. Then if we want to insert an element at one particular index value, so when we use the append method, we were able to add an element at the end of a list. But instead of adding an element at the end of a list, if we want to insert an element at some particular index, then this is how we can do. So I'll have L1.insert, then I'll give the index position where I'd want to insert. So initially at index number 1, we had this value A. But now at index number 1, I want to insert Sparta. So this takes in two parameters. First parameter is the index at which I'd want to insert. Second parameter is the value which I'd want to insert. And as you guys see, I have inserted Sparta at index number 1. Now, here as you see, the rest of the elements have been shifted one index towards the right. So A, which was initially present at index number 1, is now present at index number 2. 2, which was initially present at index number 2, is now shifted to index number 3. So each element shifts towards the right by one index value. Then we can also go ahead and sort a list. So we have all of these elements over here. Now if we want to sort these elements in alphabetical order, then we can just go ahead and use the sort method. And this sort method sorts all of these with respect to alphabet. So we have apple followed by banana followed by guava, and then finally we have mango. So let's use the reverse method, insert method, and the sort method in Jupyter Notebook. So we have the same L2 over here. Now if I want to reverse this, I'll just type in L2.reverse, and when I click on run, this has been executed. Now let me print in L2. So as you guys see, initially we had this particular sequence over here, which was 1, Z, 2, B, 3, and C. And after using the reverse method, the elements have been reversed. Now we'll go ahead and add an element at one particular index. So if I want to add something at maybe index number 3. So now we've got 0, 1, 2, 3. So we've got 2 which is present at index number 3. But now let's say I'll have L2.insert, and at index number 3 I'd want to insert great learning, and let me hit run, and let me print out L2. And as you guys see, at index number 3 I have inserted great learning, and the elements which are followed after that shift towards the right by one index value. Now finally we'll see how to sort a list. So I'll have L3, and inside this I'll have some elements. So I will have apple. After that I'll have mango. Then let me actually change the sequence over here. So let me start off with mango first. Then I'll have apple. Going ahead I'll have guava, and then maybe I'll have lychee. Now this is the sequence which is present in this list, and if I want to sort this out, I would just have to use the sort method. So when I hit L3.sort, so this has to be a list and not a tuple. So this has to be square braces. You guys have to keep that in mind. Let me change this over here. Let me cut all of this out and let me paste it over here. And as you guys see, this method has been executed, and when I hit on run, we have changed the order. So we've got apple followed by guava followed by lychee, and we have mango at the last. Now we can also perform the same concatenation and repeating operations on list as well. So here we have L1 where we have the elements 1, 2 and 3. Then we have L2 where we have the elements A, B and C. And if I want to concatenate this L2 at the end of L1, all I have to do is use the plus operator. And when I use L1 plus L2, this is what I get. I'll have 1, 2, 3, A, B and C. And if I want to repeat the elements which are present in a list, I would just have to multiply the name of the list with a particular scalar number. So as you guys see, I am multiplying L1 with 3 and I have repeated these elements 3 times. So here I'll just have concatenating a list, and I'll just go ahead and create 2 lists over here. Inside L1 I'll have 1, 2 and 3. Inside L2 I will have A, B and I'll also have C. Now I'll perform L1 plus L2, and we have appended L2 at the end of L1. So you'd have to understand that L1 plus L2 and L2 plus L1 would give you different results. So now when I actually type in L2 plus L1, you would see that we have appended L1 at the end of L2. So this sequence also changes when you change the sequence with the plus operator over here. Now let's go ahead and repeat the elements. So I'll have repeat a list, and let's say if I want to repeat the elements which are present in L2, so I'll just multiply L2 with, let's say, 5 because I want the elements to be repeated 5 times. So I have A, B and C being repeated 5 times. Now we'll head on to the main component, which is about the different data structures in Python. So we have tuple, list, dictionary and set. Let's start off with the first data structure, which is a tuple. So till now, when we have worked with single variables, we were able to store only one value or a single value inside a variable. But with the help of these different data structures such as tuple, list, set and dictionary, we'll be able to store multiple elements inside a data structure. And it's not that we can store only multiple elements of a single data type. We can also store elements of different classes or different types into this data structure. So let's start with tuple. What exactly is a tuple? It is an ordered collection of elements enclosed within round braces, and tuples are immutable. What do I mean when I say tuples are immutable? So what this basically means is if you create a tuple, then you can't go ahead and change any of the values present in it later on. A tuple cannot be modified once you create it. And this is the example of a tuple over here. So we have round braces. Inside the round braces, I have stored the elements 1, A and true. So as you see, I have elements of different types. So we can store elements of different types into a tuple. So let me create my first tuple in Jupyter Notebook. I'll type in, let me actually have this in a fresh space. I'll add the comment tuple. And over here, I'll type in tup1. I'll have round braces over here. So first element is 1. Then I'll have Sparta. Then I'll have true over here. And then let me just print out tup1. So I have created this tuple. Now let me check the type of this. Type inside this, I will pass in tup1. And this tells us that this is a tuple. Now, if I want to extract individual elements from a tuple, how can I do that? Well, the process is pretty much similar as when compared to strings. So if we want to extract the first element from a tuple, so as you guys see over here, I have created a tuple which comprises of all of these elements. 1, A, true, 2, B, false. And if I want to extract the first element, since the first element is present at index number 0, I'd have to give in the name of the tuple, and inside the parenthesis, I'd have to give in the index value, which will be 0. And I have extracted this particular element from this entire tuple. Similarly, if I want to extract the last element, so if I want to extract the last element, I just have to give in -1. So in tup1, I'll give in -1, and with the help of this, I am able to extract the last element. Now, if I want to extract a continuous sequence of elements, so here if I want to extract A, true and 2, which is a continuous sequence of elements, I'd have to give something like this. So inside the parenthesis, I'll give in 1:4. So this is the starting value of the index. This is the ending value of the index. Now here, when it comes to Python, you'd have to keep in mind that the ending value is exclusive. The starting value is inclusive. So when you give 1, the starting index value A, right? So we have 1 and we have extracted this element. But when you give in 4, this only goes till index number 3. So that is why we have extracted only A, true, and 2. So 2 is present at index number 3. We have extracted A, true, and 2. But when we have index number 4, so index number 4, we have the value B, but this is not extracted because index number 4 is exclusive. So let's go ahead and create a new tuple and extract some elements from those tuples. So what I'll do right now is I will have a new tuple called as tup2, and let me just store some random values inside this. I'll have 1, A, true, then I'll have 2, B, and I'll have false inside this. So I have created tup2. Now if I want to extract the first element, so that is obviously present at index number 0, I'll just type in tup2, and inside this I'll give in the index value, which is 0, and as you guys see, I was able to extract this particular element from this entire tuple. Now similarly, if I want to extract the last element, so I'd have to type in tup2, I'd have to give in the parenthesis, and to extract the last element, I'd have to give in -1. And if I want to extract a series of elements, so let's say if I want to extract true, 2, and B. So here, true, the index value would be 2. So I'll have tup2, the starting index value is 2, and this is 2, 3, 4, 5. So since this goes till 5, 5 is also included, I would have to give 6. 0, 1, 2, 3, 4, 5. This will go till 6. Let me hit run. And as you guys see, I have included true, 2, B, and false. If I, let's say, wanted only till B, so this will be 2, 3, 4. And if since this has to be included, I'll just give in 5 over here. And I have extracted only true, 2, and B. Now we'll actually try to modify a tuple. So initially I had told you guys that a tuple is immutable. Now when I say a tuple is immutable, I would basically mean that whatever you store inside it cannot be changed. So here I am actually trying to change the value which I had actually stored in a tuple. So as you guys see, tup1, and inside this, the whatever element was present at index number 2, I am trying to change it. But we get an error over here, and the error is tuple object does not support item assignment. So let me just print in tup2 over here. I'll hit run, and let's say if I want to change this particular value, so I have this is present at 0, 1, 2, and 3, index number 3. So tup2 and index number 3, I'd want to change that from 2 to 20. Let's see what do we get. We get the same error. Tuple object does not support item assignment because tuple is an immutable object, and that is why you cannot go ahead and change whatever is stored inside a tuple. So we have seen that a tuple cannot be modified. Now let's go ahead and perform some basic operations on top of the tuple. So here we have the same tuple where we have all of these elements over here: 1, A, true, 2, B, and false. Now if you want to find out the length of a tuple, or in other words, you would want to find out how many elements are present in a tuple, then we can just go ahead and use this len method. So this would give us the number of elements which are present in this tuple. And as you see over here, we've got 6 elements, and that is the result over here. Then going ahead, we can also concatenate 2 tuples. That is, we can attach the elements of one tuple to the back end of another tuple. So here we have tup1 where we have elements 1, 2, and 3. Then we have tup2 where we have elements 4, 5, and 6. Now when we are trying to concatenate, all we have to do is use the plus symbol or the plus operator, and when we use tup1 plus tup2, we get the result 1, 2, 3, 4, 5, 6. So let's go ahead and perform these operations in Jupyter Notebook. So I'll just create the tuple again over here. I have tup1 and let me add in some elements. So I'll have 1a true, then I'll have 2b, and then I'll also have false over here. So I have created this tuple. Now if I want to check the length of it, all I have to do is use the len method, and inside this I will be passing in the object. And as you guys see, we have the result which tells us that there are 6 elements present in this tuple. Now I'll create 2 more tuples. I'll have tup2 over here, and inside this I will have the elements 1, 2 and 3. Going ahead, I'll create another tuple with the name tup3, and inside this I will store the elements 4, 5 and 6. Now I would have to perform tup2 plus tup3. Let me change the spelling over here. And as you guys see, we have concatenated these elements at the back end of tup2. So this was a very simple operation. Now, if we want to repeat the elements which are present in a tuple, that is also something which we can perform. So here in this tuple, we just have 2 elements which are Sparta and 300. Now, if we want to repeat these elements a certain amount of time, then we have to multiply this with a scalar number. So here when I'm multiplying tup1 with 3, I get Sparta 300, Sparta 300 and Sparta 300, which basically means I am just repeating these elements 3 times. Now we can also perform repeating and concatenating at the same point of time. So here we have tup1 and tup2. So first what I am doing is I am repeating the elements which are present in tup1. So here when I use tup1 into 3, the elements are repeated 3 times. So I have Sparta 300 repeating 3 times. Then I am attaching or concatenating tup2 at the back end of this. So let me add a comment over here. I'll just have repeating elements in a tuple. And now I have this tup1 over here. Let me just print out tup1. And if I want to repeat these elements 3 times, all I have to do is type in tup1 into 3 and let's see. So as you guys see, 1a true, 2b false. So we have this once, then the same thing is being repeated twice and the same thing is being repeated thrice. Now similarly, if I want the entire thing to be repeated 5 times, I would have to multiply this with 5. So as you guys see, I have repeated all of the elements 5 times. Now we'll do repetition and concatenation at the same time. I'll add a new comment over here. Repetition and concatenation. I'll have 2 tuples over here. I'll have tup1 where I'll have, let's say, A, B, and then I'll have C. Then I'll go ahead and create a new tuple which will be tup2, and inside this I will have X, Y, and then I'll also have Z. And now this is an interesting operation. So I'll have tup1 into 3 plus tup2. And let's see the result. So as you guys see, I have repeated the elements which are present in tup1 3 times. So I have ABC, ABC and ABC. Then I'm adding this at the back end of it and I get X, Y and Z. So this was another simple operation. Now we also have some simple tuple functions. So if you have a tuple and if you want to find out the minimum value and the maximum value which are present in it, all we have to do is use the min method and the max method. So over here I have these elements, and if I want to find out the minimum value which is present over here, all I have to do is use the min method and I pass in the tup1 object inside this. And as you guys see, this method tells us that the minimum value which is present in this tuple is 1. Going ahead, similarly, we use the max method, and when we pass in tup1, this tells us that the maximum value which is present in this tuple is 5. So I'll have tup1, and let me add some numerical values inside this. So I'll add some random numbers in a random order over here. So I have 825107. Now if I want to, I have to remove the C over here. Now if I want to find out the minimum value which is present in it, all I have to do is use the min method, and inside this I'll be passing in tup1, and as you guys see, this method tells us that the minimum value which is present in this tuple is 0. Similarly, if you want to find out the maximum value, I'll use the max method, and inside this I'll again pass in tup1, and we get the result of 8. This brings us to the end of this tutorial on tuples in Python.
So dictionary is an unordered collection of key value pairs enclosed within curly braces. And a dictionary again is mutable. So what exactly are key value pairs? Let's see an example of that. So over here we are creating a dictionary where we have two key value pairs. So the first key is apple, second key is orange. First value is 10, second value is 20. So you can also consider it this way. Let's say we have the name of the fruit and the cost of the fruit, or maybe the quantity of the fruit. So we have apple, and let's say there are 10 apples. Then we have orange, and let's say there are 20 oranges. And you will be separating the key with the value with this colon over here. Now let me just delete all of this and let's start fresh for our dictionary. So instead of list, I'll just type in dictionary over here. And let's say I'll create this dictionary like this, and I'll have let's say my first fruit is mango, and I have 10 mangoes with me. Then I'll have apple, and let's say I have 20 apples. Then I have lychee, and I have 30 lychees, and finally I would have strawberry, and I would have 40 strawberries with me. Let me print out the result over here. So this is our first dictionary which we have just created. And just to ensure that we have actually created a dictionary, let me check the type of it. So type of fruit would tell us that this is of dict type, which is basically a dictionary. Now, once we have created a dictionary, we can actually go ahead and extract the individual keys and values which are present over here. So this is our dictionary, and if you want to extract only the keys, so this what you see on the left side of the column, those are our keys. And if you want to extract only the keys, all you have to do is use the name of the dictionary, follow it up with the keys method, and we'll get all of the keys which are present in this dictionary. Similarly, if you want to extract all of the values, we would have to use the values method. So when I type in fruit.values, I am able to extract all of the values which are present over here. So I'll have fruit, which is a dictionary, which is already present. And if I want to extract all of the keys, I'll just go ahead and use the keys method. And as you guys see, I am able to extract all of the keys which are present. Similarly, if I want to extract the values, I'll type in fruit.values, and I have extracted all of the values which are present. Now, since dictionary is mutable, we can modify it. So that would mean we can add a new element, or we can change an existing element. So here we had only 4 elements, but if I want to add a 5th element, so here we don't have mango initially, but if I want to add mango, all I have to do is use the name of the dictionary, then inside parenthesis, I'll add the new key. So this is what you see. Inside parenthesis, I'm adding the new key, and I'm adding the value to it. So here, as you guys see, I have attached this new key value pair at the end of this dictionary. Similarly, if I want to change an existing element, so initially the value of apple was 10. But if I want to change the value, then inside the parenthesis, I'll just give in the key and I'll assign a new value to it. So initially we had 10, now we have modified it to 100. Now we'll see how to add a new element. So I'll have fruit over here. Let me just print it out. We have 4 elements. Now let me add a new element inside this. So I'll have fruit. I'll have the square braces, and let's say the new fruit which I'll be adding is guava, and let's say I have 50 guavas with me. And let me print out fruit right now, and let's check the results. So as you guys see, we have attached this new key value pair at the end of this dictionary. And finally, let's see actually how can we modify an existing element. So we've got, let's say if I want to modify this particular key value pair, so I have lychee and the value of lychee is 30. So I'll have fruit inside this. I'll give in the key which is lychee, and I want to change 30 to 300. I'll just assign 300 to this and let me print this out. And as you guys see, initially the value was 30. I have successfully changed it to 100. Now we'll go ahead and work with some dictionary functions. So let's say if we have two dictionaries over here, we have fruit1 and fruit2. So in fruit1 we have apple and orange, in fruit2 we have banana and guava. And if I want to append the elements of fruit2 to fruit1, or in other words, if you want to concatenate the fruit2 values to fruit1, all we have to do is use the update method. So I have fruit1 and I'll use update method and I'll pass in fruit2 inside this. So as you guys see, we have appended banana and guava to the end of fruit1. Then similarly, we can go ahead and pop an element from a dictionary. So we can, so if we want to pop any key value pair, so inside the pop method, we would have to give in the key which we'd want to pop. So we had orange, but I don't really like oranges. So that is why I went ahead and I popped out orange. So as you guys see, orange is not present in this particular list. Now let's create two more dictionaries. I have fruit1 and I'll have two fruits inside this. So I'll start with mango and I have 10 mangoes. Then I'll have apple and maybe I have 20 apples with me. Then I'll have fruit2. And in fruit2, let's say I'll start off with guava and I have 30 guavas with me. Then going ahead, I'll have lychee and I'll have 40 lychees with me. So I have created these two dictionaries. So we have made a mistake over here. Let's actually check what this mistake is. So instead of the equal to operator, I'd have to give in colon over here. That is important. So I have created fruit1 and fruit2. Let me print out fruit1 and fruit2 for your sake. And once we have printed these two, let me go ahead and actually append the values of fruit2 to fruit1. So for this, I'd have to use fruit1, then I'll use in the dot operator over here. And after that, I will use the update method. And inside the update method, I'll be passing in fruit2. And let me print out. Let me close this first. Now, let me go ahead and print out fruit1. Now, as you guys see, I have appended the values of fruit2 to fruit1. Now we have fruit1 already, but let's say if I want to pop out something from this. So let's say from this, if I want to pop out the value of lychee, I'll have fruit1. Then I'll use the pop method. So fruit1 dot pop. So we have an error because we'd actually have to give a key inside this. So because I'd want to pop out lychee, I'll give in lychee over here and we have successfully popped out lychee from this. Now we'll head on to the last data structure in Python, which is set. So set is an unordered and unindexed collection of elements enclosed within square braces. So when we say unordered, so in whatever sequence you insert the elements in a set, that particular order does not remain intact. And also when we say it is not indexed, you can't extract elements from a set with a particular index value because there is no proper ordering. And also you'd have to keep in mind that in a set, duplicates are not allowed. So you can't have the same element twice. But if you're actually given the same element twice, what happens is the set takes it only once. And we are creating one particular set over here. And if you want to add a new element inside this, so initially we are creating this set where we have all of these elements. So we have 1, A, true, 2, 2, B, and false. And if I want to add a new element at the end of this or somewhere, so I'll just use s1.add, and this is how we can insert the new element inside this. Now let's say if instead of adding just one particular element, if I want to add multiple elements at the same time, so instead of the add method, we'll be using the update method. And with the update method, I am passing in these list of values which are 10, 20, and 30. And as you guys see, I have inserted 10, 20, and 30 inside this. But then again, you have to keep in mind that the order is not maintained in a set. So these are inserted randomly. And if you want to remove a particular element, you can just use the remove method and you will pass in the element that you'd want to remove. Again, since there is no indexing, you can't remove elements with an index value. You would have to give in the value which you'd want to remove explicitly. So let's create our first set. So I'll have S1. I'll just add some elements over here. I'll have A, B, C, D, E, and F. Let me print out S1 for your reference. And this is what we have. Now, let's say I'll add some duplicates inside this and let's see what happens. So I'll have A repeating 3 times, then I'll have B also repeating 2 times, then I'll have C repeating 2 times. Now if I print this out, as you guys see, we have only A, B, C, D, E, and F. Even though A is repeating 3 times, we'll only have one unique value of A. Similarly, even though B and C are repeating 2 times, we'll only have one unique value of B. Now, if I want to go ahead and add a new element inside this, I'll use the add method. So S1.add, and inside this, I'll just add Sparta. So when I use S1.Sparta, and when I print S1, so we have inserted Sparta over here. Similarly, if you want to pop out something or remove something, we will have to use the remove method. So I'll have S1.remove over here. And inside this, let's say if I want to remove the element E, I'll just pass in E over here. And let me print out S1 again. So we have successfully removed the element E from this entire set. Now we'll work with some set functions. So here we have 2 sets, S1 and S2. In S1 we have the elements 1, 2 and 3. In S2 we have the elements A, B and C. Now if we want to combine all of the elements which are present in S1 and S2, then we can use the union operator. So S1 dot union S2 will give us a union of S1 and S2. And as you guys see in the resultant, we have 1, 2, 3, A, B and C. Similarly, we have 2 sets over here, and if we want only the common elements which are present in both of the sets. So here we have 1 to 6, here we have 5 to 9. If you want the common elements, I would use the intersection method. So when I use S1 dot intersection S2, you will see that we have 5 and 6 common in S1 and S2, and that is the result which we get. Let me have S1 over here. And in this, I'll have 1, 2 and 3. I'll have S2 in which I'll store 4, 5 and 6. Now let me use the union operator. So I'll have S1 dot union, and inside this I'll be passing in S2. And as you guys see, I have appended 4, 5, 6 at the end of S1. Now similarly, if I want to find out the common elements, so let me make some modifications in S1. So in S1, let's say I have from 1, 2, 3, 4 and 5. And then S2, let's say I have the elements 4, 5, 6, 7 and 8. Now if I want to find out the common elements which are present in S1 and S2, I'll have S1 dot intersect, and inside this I'll be passing in S2. And we seem to have an error over here. So this has to be intersection and not intersect. Let me click on run. So as you guys see, by using the intersection operator, we have the common elements which are 4 and 5.
Now we'll understand about flow control statements in Python. And in flow control statements, we'll have decision making statements and looping statements. We'll start off with decision making statements. And as you can get from the name itself, decision making statements would help us to make a decision on the basis of a condition. And we have a very good example over here right in front of us. So let's say you would want to play football, but it's actually raining outside. So the condition over here is, if it's raining outside, then you can't play. You'd have to sit inside. On the other hand, if it's not raining, else it is not raining, then you can go out and play football. So this is a very good example of if-else statement. Then let's look at another example. Let's say you have your main exam coming up and you go ahead and give a mock exam. And in that mock exam,
if you score greater than 70 marks, then your parents tell you that they'll buy you an ice cream. But on the other hand, if you score less than 70 marks, then you would have to give another mock test. So this again is an example of if-else statement. So now that we've understood how if-else statements work, let's go to Jupyter Notebook and implement them. So here we have two variables A and B. We have stored the value of 10 in A and 20 in B. And we are trying to see if the value of B is greater than the value of B. That is, we are checking if 20 is greater than 10. And if that is evaluated to true, we will just go ahead and print out B is greater than A. And this is the syntax as you see. We'll give an if, the keyword if, you'll follow it up with the condition. And in the condition, we are checking if B is greater than A. So is 20 greater than 10? That is evaluated to true. And since that is evaluated to true, when I hit on run, I'll get this result, which is B is greater than A. Now let me change the condition over here. So instead of checking if B is greater than A, I want to check if the value which is present in A is greater than the value which is present in B. So I'm basically checking if 10 is greater than 20. And obviously this evaluates to false. And since this evaluates to false, whatever is present inside the body of this if will be skipped out. And when I hit run, you'll see that I'll not get any result over here because this is evaluated to false. So whenever if is evaluated to false, you need something else. So that is why we have this else keyword over here. So here we are checking if A is greater than B. And since this has been evaluated to false, I'll give an else keyword over here and I will print out whatever will happen. Since this is false, I would have to print out B is greater than A. And when I hit on this, you would see that I'll get B is greater than A, and which is actually right. So this is about if else condition. Then we have another variation of if else, which is if elif else. So with the help of this, we can compare multiple variables together, or we can have multiple conditions together. And this time I'd want to find out the greatest value among three values. So I have three variables over here, A, B and C. I'm storing the value of 10 in A, the value of 20 in B and the value of 30 in C. And once I do that, using if, I start off by checking if the value of A is greater than B and also if the value of A is greater than C. So as you can look over here, I am giving two conditions and those two conditions have been joined with the help of this AND operator. If A is greater than B and if A is greater than C, and if that is the case, I'll go ahead and print out A is the greatest. And if either of these is evaluated to false, then with respect to AND operator, you know that if either of these is false or both of them are false, then this part will be skipped. So here, if A is greater than B, we are checking if 10 is greater than 20. That is obviously false. And here we are checking if A is greater than C. So is 10 greater than 30? That again is false. So false and false will be evaluated to false. And that is why we'll be skipping out this particular line. Then we'll head on to elif. And this time we are checking if B is greater than A and B is greater than C. So if B is greater than A, 20 is greater than 10. This is evaluated to true. After this, we are checking if 20 is greater than 30. This is evaluated to false. So true and false is again false. And that is why we'll skip this as well. And finally, we'll enter the final else statement and we'll just go ahead and print out C is the greatest. So this is about if, elif, else. Then we can also go ahead and use the if statement with a tuple. So here we have created a tuple where we have three elements A, B and C. And once we create this tuple, I am trying to find out if the element A is present in this tuple. So here if A in tup 1, then I go ahead and print out A is present in tup 1. And as you see, since this is evaluated to false, or in other words, this element is present in this tuple, I am able to print out A is present in tup1. Now on the other hand, if I would want to check if an element Z is present in this tuple, so here I have if Z in tup1 print Z is present in TUP1, and as you see, I don't get anything because this element is not present. So here what I'll do is I'll add the else statement and I'll print out Z is not present in TUP1, and this time I'll get the result because this is evaluated to false and will print out whatever is there in the else condition. And this time we are going ahead and using the if statement with a list. So again we are creating a list L1 over here, and we have these three elements A, B and C. And this time what we are doing is we are checking if the value which is present at 0th index of this list is equal to A. And if that value is equal to A, I would want to change that value to 100. So you see, if L1 of 0 is double equal to A, I am assigning a new value over here, and that value is equal to 100. And after I run this, you would see that initially the value is A and I have changed that value to 100. Now, let's say if I run this back again, and if I would want to change this value from A to Z, I'll just have Z over here. And you would see that initially the value is A, and this time I have changed the value to Z. And finally, we will be applying the if statement with a dictionary. So here we have created a dictionary D1 where we have three key value pairs K1, K2, K3. The value of K1 is 10, the value of K2 is 20, and the value of K3 is 30. And with the help of the if statement, I am adding 100 more to the first key over here. So the condition is if D1 of K1 is double equal to 10. I'm checking if the value for the key K1 is equal to 10, then I will add 100 more to this by using this condition. So D1 of K1 is equal to D1 of K1 plus 100. So I have an error over here. I'd have to initialize D1. And as you guys see, initially the values were 10, 20 and 30, and after using the if condition, I have added 100 more to the first value of the first key. So those were decision making statements. Now we'll head on to looping statements, and these are used to repeat a task a certain number of times. And again, we have a very beautiful example over here. Let's say you have a bucket and you'd want to fill up that bucket with a mug of water. Now what you'll do is consider the mug and the bucket to be empty at this point of time. First, you'll fill up the mug and you'll pour this water into the bucket. Then you'll check if the bucket is full or not. After this, again you'll take a mug full of water, then pour it back into the bucket. Again you'll check if the bucket is full or not. Then next time again you'll take a mug full of water, pour it back into the bucket, and again you will check if the bucket is full or not. And this process goes on until the bucket is completely filled up with water. And you will stop this only when the bucket is filled. So here what you're doing is you're looping, or you are performing the same task again and again until a condition is met. We have another example over here. Let's say you're listening to your favorite song and you put that song on loop. So here the condition is the same song will be kept on playing until you either close the app or maybe you switch off your phone. So this is the condition over here. The song is on loop until you close the app, you stop the song, or maybe you switch off your phone. Then we have a very interesting example. So at the end of every month, you will get credited with a salary amount. So here what is happening is, if the date is equal to 30th or 31st, and if it is the last day of the month, you will have salary credited into your bank account. This again happens in a loop. So these are some examples of looping statements, and we have two types of looping statements in Python, which are for and while. We'll be working with both of them. So we'll go ahead and start off with the for loop. So here we have created a list called as fruits, and this has these three fruits over here: apple, mango and banana. Now with the help of this for loop, I would want to print out all of the individual elements which are present over here. So I'll have for I in fruits, print of I. So here I, what happens is Initially, the value of I will be equal to apple. Then the value of I will be equal to mango. Then the value of I will be equal to banana. And this will end once I reaches the last element which is present in this list. And that is how we are printing out each element which is present in this list. So this is a very simple example of how we can work with the for loop. Then we can also have a nested for loop where we'll have one for loop inside another for loop. And here we have two lists again. We have one list comprising of different colors and we have another list comprising of different items. So the colors are blue, green and yellow and the items are book, ball and chair. And what I'm doing is I have an outer for loop which would help me to pick a color. So here it is for I in color. Then inside the outer for loop, I have an inner for loop which goes for J in item, which should help me to choose an item and I print out I, J. Let's understand how this for loop works over here. So initially value of I is equal to blue and we enter the for loop and the value of J over here will be equal to book. So I print out I, J, it will be blue book. Then value of J is incremented, it becomes ball and I print out blue ball. Again value of J is incremented, it becomes chair. Then I print out blue chair. Then I go back to the outer loop and blue is incremented, then the color becomes green. Then I have green book, green ball, green chair. Again after this value of green becomes yellow. Then I print out yellow book, yellow ball and yellow chair. This is how you can work with nested for loop. After the for loop, we have the while loop. So while again would help us to repeat a particular task and this task is repeated on the basis of a condition. And over here, I am trying to print out the first 10 numerical numbers using a while loop. Here I have initialized a variable called as I and I have assigned the value of 1 inside this variable. And after this, I am checking if the value of I is less than or equal to 10. And if the value of I is less than or equal to 10, I enter this while loop and I print out I. Then I increment the value of I. So let's understand what is happening in this while loop. Initially value of I is equal to 1. So the condition is 1 less than or equal to 10. And since that is true, I go inside the for loop, I print out 1. Then I value is incremented, it becomes 2. Then I go back and I check if 2 is less than or equal to 10. This again is true. I head back, I print out 2, then I increment the value of I, it becomes 3. Then I am checking if 3 is less than or equal to 10. This again is true. I head back into the while loop, I print out 3, then I value is incremented, it becomes 4. Then again I am checking if 4 is less than or equal to 10. This is true. I come back into the while loop, I print out 4, then I will increment the value of 5, it becomes 5. Then we will proceed the same way till the value of I is equal to 10. When the value of I is equal to 10, I am checking if 10 is less than or equal to 10. And this condition is true. I print out 10 over here. After this, I have I plus 1. Value of I becomes 11. And this time when I check is 11 less than or equal to 10, this condition fails. And this is when I come out of this while loop. And this is the result which I get over here. Similarly, instead of the first 10 numbers, if I want the first 15 numbers, I'll just go ahead and change this value over here. And you would see that I have printed out the first 15 numbers. Now using the while loop, I can also go ahead and print the 2 multiplication table. Here I have I and I'm assigning the value of 1 to I. Then I have a new variable called as n and I'm assigning a value of 2 to this new variable. And in the while loop again the condition is while I is less than or equal to 10. And while this condition is true, I will print out n into I is equal to n into I. Then I am incrementing the value of I. So let's again understand what is happening inside the while loop. So initially value of I is equal to 1. So the condition will be while 1 is less than or equal to 10, which is true. I come back over here and I print out n into I, which will be 2 into 1 is equal to 2. So I print out this. Then I increment the value of I. It becomes 2. Is 2 less than or equal to 10? Yes, that is true. I come inside. Then this time I print out 2 into 2 is equal to 4. Then I value is incremented. It becomes 3. So is 3 less than or equal to 10? That again is true. So this time I will have 2 into 3, which is equal to 6. And I print this out. And this process continues till I value is equal to 10. And when I value is equal to 10, I will have 10 is less than or equal to 10, which is true. So here it will be 2 into 10 is equal to 20, and we'll print that out. And after that, when we increment the value of I, it will become 11. So it's 11 less than or equal to 10, which is false. And this is when we will come out of this while loop. So these were some examples with the help of while loop. Now we'll also see how to apply this while loop on top of a list. So here we have this list L1 with all of these numbers 1, 2, 3, 4 and 5. And I would want to add 100 to each individual element of this list. So I start off by initializing this variable I given the value of 0, and this while loop will go on till the length of the list, or in other words, the number of elements which are there in the list. So what is the length? It will be 1, 2, 3, 4 and 5. Initially, value of I is equal to 0. So we are checking if 0 is less than 5, which is true. We come inside the while loop. Here it will be L1 of 0 is equal to L1 of 0 plus 100. So it will be 1 plus 100. We'll print out 1 plus 100 over here. Then we are incrementing value of I. It becomes 1. So is 1 less than 5? It is true. So here we will have L1 of 1 is equal to L1 of 1 plus 100. So it will be 2 plus 100, which will become 102. And this is how we'll go on and print out or add 100 to each element of this list. Now we'll head on to one of the most important concepts in Python, which is object-oriented programming. Now when you look around you, you would see that you are surrounded with objects. The laptop which is there in front of you, that is an object. The phone which is there in your hand, that again is an object. The bottle which is there beside you, that again is an object. Now, if you'd want to represent all of these real world objects in the programming paradigm, you would need an object-oriented programming language. So you would have a lot of object-oriented programming languages, and Python is also an object-oriented programming language because it allows us to represent all of these real world entities in a programming world. Now, to understand the concept of object-oriented programming, we would need to understand two main components of it, which are classes, and then we obviously have objects. So let's start with this term called as class. So what exactly is a class? Simply put, you can consider a class to be a template or a blueprint for real world entities. And we have a very simple example over here. Let's take the example of a phone. Now, when we talk about a phone would again have two things associated with it. It will have some properties and it will have a certain behavior associated with it. Now, when I say properties, the phone will have a color associated with it. The phone will have a cost associated with it, and the phone will also have a certain battery life associated with it. And along with these batteries, when I say a phone will have certain behaviors associated with it. Now, what do I mean by behaviors? I simply mean that with the help of a phone, you can make calls. With the help of a phone, you can watch certain videos on it. And also, some phones allow you to play games in it. So this class, this phone class, has properties and behavior associated with it. And what exactly is a class in Python? You can consider this class to be a user-defined data type. So as we have predefined data types, so we had looked at all of these predefined data types, which were integer, float, boolean, and string. So similar to these predefined data types, we can create a user-defined data type, and that user-defined data type will be this class. So here what we are doing is we are creating this class, this user-defined data type called as mobile. And this user defined data type will have attributes and methods inside it. So these attributes are nothing but the properties of the class, and these methods are nothing but the behavior of the class. Now that this is clear, let's understand the next component of object-oriented programming, which is object. So we already know what is a class. Now object is nothing but a specific instance of a class. So when we say we have a mobile class, the specific instances of this mobile. So we have Apple, Motorola and Samsung. So Apple, Motorola and Samsung would be objects of this class, phone or mobile. And if you want examples of what exactly is an object, so as we have these predefined data types, so these are integers. So A is an integer variable and I'm storing the value 10 inside this. Similarly, B is an integer value and I'm storing the value 20 inside this. So similarly, if we have the mobile data type, then for this mobile data type, we have the objects Apple, Motorola and Samsung. So that was a brief intro to object-oriented programming. Now let's see how can we actually create a class in Python. So to create a class in Python, we'd have to start off by giving this keyword called as class. Then going ahead, we will give in the name of the class. And by convention, you would have to remember that the name of the class needs to be capital. The first letter has to be capital. So that is why we have given capital P over here. So the name of this class is phone, and inside this we are defining two methods. So with the help of these methods, we can have the behavior of this class. So I am having this first method called as make call, and inside this method I am just printing out making phone call. And over here, as you see, this method takes in a parameter which is self. So for now, just understand that with the help of this self parameter, we will be able to invoke the attributes which are present in this class. Just understand this for now, and as we'll go ahead through object-oriented programming, it will be much more clear to you guys. So as we have created this particular method, similarly we will create another method called as play game, and this again takes in one parameter which is self, and all I'm doing is printing out playing game. So now that I have created my blueprint or my class over here, I would have to create a specific instance of it. Or in other words, I'd have to create an object of this phone class. So I'll just write down phone over here and I will store it in this object called as P1. And now that I have the object of this class, I can go ahead and invoke the methods which are present in this class with the help of this object. So when I type in p1.makeCall, with the help of this, I will be able to invoke this method and I am printing out making phone call. Similarly, when I invoke p1.playGame, I am invoking this method and I am printing out playing game. So this is how we can create a class and an object in Python. So let's go to Jupyter Notebook and work with this example. So my task would be to create a class. So I'll have class. I'll give the name of the class as phone. I'll give in a colon over here. And after this, I would have to create a method. And to create a method, we already know that we will be using the def keyword. And I will give the name of this method as make call. And we know that this takes in only one parameter, which is self. And inside this, I will just have a print statement, which will be making a phone call. And once I have this method, I will go ahead and create another method over here. So I will call this method as play game, def of play game, and I'll have self over here. Again, I'll have a print statement, and here I will write down playing a game. So I have created my phone class over here, and now that I have created this phone class, I would have to create an object of this. So here I will have P1 is equal to phone. So I'll have to give in parenthesis over here, and this is how I am creating an object of this phone class. And now that I have the object ready, so with the help of the dot operator, I can invoke both of these methods. So I'll start off by invoking the make call method. So I will have make underscore call. And when I hit on run, you would see that I have successfully printed out making a phone call. Similarly, now when I have p1.playGame, you would see that I have printed out playing a game. So we have created our first class and we have also created the object for this class. And now, in the methods which were present in the previous class, there were no additional parameters. We had only one parameter known as self, and with the help of that self parameter, we were just able to access the attributes which were present. And we did not actually have any attributes in the previous class. So we will modify that. So to our phone class, or actually the methods which are present in our phone class, we will be adding some additional attributes. So we are adding a new method over here called as setColor, and this setColor method over here takes in two parameters. The first parameter is self because it is compulsory. Then we will have this new attribute called as color. And with this color parameter, what I'm doing is I will have an attribute called as color, and I am assigning this color to the attribute color which is present in my phone class. Similarly, I have another method called as setCost. This again has two parameters. First is self because again it is compulsory. Then we have this additional parameter called as cost. And I would also have an attribute called as cost in the phone class. And what I'm doing is I am assigning this value of cost to my attribute cost in the phone class. So now that I have assigned the value of color and cost to my attributes, what I'd have to do is show the value of color and show the value of cost. So now that I have set these, I would need two methods to show the color and show the cost. So that is why I will create a new method called as showColor, and this only has the self attribute or the self parameter over here because I'm not assigning anything, and all I have to do is return the value. And if I have to return the value, I'll just use this keyword return and I'll print out return self.color. Similarly, if I would have to return the cost, I would have this new method called as showCost. This takes in only one parameter which is self, and I'll go ahead and return. Here as you see, I will have return self.cost. And these are the additional methods which I have, and then I have the same methods which are make, call and play game. And inside make call, all we are doing is printing out making a phone call, and inside play game, all we are doing is printing out playing a game. So let's go ahead and modify our phone class which we had created earlier. I'll delete these records from over here. Let me cut this entire thing, or actually I can write it over here itself. So these are the methods which were present earlier. I would have to add 4 more methods inside this. So to create a method, we would have to use the def keyword, and I would have to set a color to the attribute. So I will use this method called as setColor. The first parameter is self because it is compulsory. Then I will have this additional parameter called as color, and I am assigning the value of this color to the attribute color by using the self attribute or the self parameter which I have passed in. Now similarly, I will have another method over here. So as I have set the color, similarly I would have to set the cost as well. So def, I will have a new method called as setCost. This would take in 2 parameters. The first parameter would be self and the second parameter would be equal to cost. And over here I will write down self.cost is equal to cost, and this is how I'm assigning the value of cost. And after this I would have to print out the value of color and cost. I would need one method called as showColor, and the parameter will only be self. And what this does is it would just return out the color. So it will be self.color. Then I would need another method called as showCost, and this again would take in only one parameter which is self, and with the help of this I am returning out the cost. So here I will have self.cost. So these are the 4 additional methods which I have added inside this. So it seems that we have an error over here. Let me see what exactly is this. So this is line number 7 and this is set.cost. So here I would actually have to give in a comma instead of full stop over there. And now we see that we have successfully created this. Now after creating this class, I would have to create an object. So I will have p1 is equal to phone. And now that I have created this object, with the help of this object, I can access these methods and assign values to the color and cost. So I'll just invoke p1 dot set color, and I will set the color of this font to be equal to, let me keep it blue over here. Now similarly, I will also set the cost of it. So I'll have p1 dot set cost, and I will set the cost to be equal to, let's say, $999. Now that I have set the value of color and cost, I can print out these two values. So let me delete this. So I will have p1 dot show color, and now when I hit on run, you would see that the color is blue. Similarly, when I have p1 dot show cost, you would see that the cost is equal to 999. So this is how we can have additional attributes and pass in values to the attributes which are belonging to a class with the help of these additional parameters. Now there's a special example or a special concept in object-oriented programming which is known by the name of a constructor. So if you have worked with other languages such as C++ or Java, and if you have learnt about the concept of inheritance, you would know about a constructor. So normally in C++ or Java, a constructor is a special method which would have the same name as that of the class, and this would help us to initialize the values of the attributes during the object creation itself. So that is what a constructor is in Python itself. It's just that the constructor in Python, the name of this method will not be equal to the name of the class. So the constructor in Python goes by the name of init method. So here, as you see, this is our constructor. We have our init method over here, and I have def. So init, we have the prefix of 2 underscores, and also after init, we will have 2 underscores over here. So we have our constructor ready. And as I've told you, with the help of a constructor, we will be able to assign values to the attributes during object creation itself. So obviously we will have some parameters inside this, and with the help of these parameters, we'll be able to assign values to the attributes. So in this employee class, let's say I would have 4 attributes called as name, age, salary, and gender. So I'll have these 4 additional parameters over here, and I am assigning the value of name to this attribute. Similarly, I am assigning the values of age, salary, and gender. Now that the constructor is ready and I have assigned the values, I would have to show the values out. And to show the values, I have this new method called as employee details, and I will create this method like this. So I'll have def employee details, and I will pass in self inside this because I'm not assigning anything, and this is the default or and we definitely have to give in the self parameter inside this. And inside this method, I'm just printing out the name of the employee, the age of the employee, the salary of the employee, and the gender of the employee. And once we create this class, we will go ahead and create an object of it. So here, when we are creating an object, as you see, we have E1 is equal to employee, and during the instantiating of the object itself, as you see, I am passing in the values for all of the attributes. So as you see over here, the name, I am assigning the name to be equal to Sam. Similarly, the age, I am setting it to be equal to 32. Then the salary, I am setting it to be equal to 85,000. And the gender, I am setting it to be equal to male. And this is how I am assigning all of the values during instantiating of the object. And once I have created the object, and since I have also given all of the values to the attributes, I can directly invoke the employee details method. And when I invoke the employee details method, you would see that I am able to print out all of the details. Name of the employee is Sam, age of the employee is 32, salary of the employee is 85,000, and gender of the employee is male. So let's go to Jupyter Notebook and implement this concept of constructor. So I'll just add this comment over here, constructor, and I will create this new class. So I will have class employee, and inside this I will go ahead and create the init method. def, I will have 2 underscores, then I'll write down init, then again I'll have 2 more underscores over here. So I'll start off by giving the self attribute inside this, then I will start off by giving the name attribute, then I'll give in the age of the employee. After this I will give in the salary, and then finally we have the gender of the employee. And all I have to do is assign these parameters to the attributes which are present. So I will have self.name is equal to name, self.age is equal to age, self.salary is equal to salary, and self.gender is equal to gender again. So I have created this constructor over here. After this, I would have to create a new method called as show employee details. Let me just write down the name of this method. So I will have show employee details, and this will have only one parameter, which will be self. And inside this method, I'm going to print out all of the values of the different attributes which are present. So I'll start off by printing the name. So I'll have name of the employee is, I'll have self.name, then I will have age of the employee is, here I'll have self.age, then I will have salary of the employee is, here I will have self.salary, and finally I will have gender of the employee is, and here I will have self.gender. So let me hit on run, and I have successfully created this class where I have a constructor inside this. Now I can go ahead and create an object of this. So I will have E1 over here, and what I will do is I will give in the name of this class, which will be employee. The first value inside this should be the name of this person. So let's say this employee's name is Sam. Then Sam is 28 years old, and let's say Sam earns around $75,000. Let's make this $75,000, and Sam is male. So I have created this object over here. Now that I have assigned all of the values, I can go ahead and invoke the show employee details method. Here I will have E1 dot show employee details, and when I invoke this, you would see that I have this result. Name of the employee is Sam, age of the employee is 28, salary of the employee is 75,000, and gender of the employee is male. Now we'll understand the concept of inheritance. So simply put, inheritance is when you derive some properties from something else. And a real world example of inheritance would be, you'll be inheriting some of your features from your parents, and your parents will be inheriting some of their features from their grandparents. Or in other words, let's say you will sort of look like your parents in a way, and your parents might look like your grandparents in a way. So you're inheriting some physical features from your parents. Now, if we have to relate this concept of inheritance in Python, this basically means that we will have a child class and a parent class, and the child class would inherit some features or all of the features from the parent class. And we have an example of inheritance over here. So what we're doing is we are starting off by creating the parent class. So the parent class is called as vehicle. So we will have class of vehicle. And inside this, I have two methods. The first method is the default constructor. And in this constructor, I have two additional parameters, which are mileage and cost. And I am assigning the value of mileage. Then I'm also assigning the value of cost. And once this is done, I will go ahead and create another method called as show details. And inside show details, I'm printing out I'm a vehicle. Then I'll go ahead and print out the mileage of the vehicle, and also I'll print out the cost of the vehicle. So now that the parent class is ready, I would have to create an object of the parent class. So here I have V1 is equal to vehicle, and I pass in 500 and 500. So this 500 would denote the mileage of this vehicle. So this might basically mean 500 miles per gallon. Then we have the cost, which is 500 again. So this would mean that the cost of this vehicle is $500. So now that we have created this object, we can directly invoke the show details method with this object. So I have v1.show details, and as you have in the result, I'm a vehicle, mileage of the vehicle is 500 and cost of the vehicle is 500. Let's go to Jupyter Notebook and implement this. Let me delete all of these previous examples from over here. Let me keep it fresh. And I will create this new vehicle or new class called as vehicle over here. We will start off by creating the constructor. I would need the init method over here. And the first parameter is obviously self. After this, I would need the mileage of the vehicle, and I would also need the cost of the vehicle. Then I'll go ahead and set out these two values. So I'll have self dot mileage is equal to mileage. After this, I will have self dot cost is equal to cost. Now that I have created this constructor, I would have to show the details. So I will have show vehicle over here, and this will just have one parameter, which is self. And inside this method, I will go ahead and print out some basic things. So first I'll be printing out I am a vehicle. Then I will go ahead and print out mileage of the vehicle is. Here I'll have self.mileage. Then I'll go ahead and print out the cost. So I'll have cost of the vehicle is. Here I'll have self.cost. And this is how I have created this class. And after creating this class, I would have to create an object of it. So I will have v1 is equal to vehicle. And inside this, I would have to pass in the mileage value first. So let's say this vehicle would give me around 120 miles per gallon, and the cost of this vehicle is around $800. So I have set these values over here. Then I can just go ahead and invoke the show vehicle method. So here I will have v1 dot show vehicle, and when I run this, we have an error over here. Let's understand what exactly is this error. So we have self.mileage, we have self.cost inside this. Vehicle object has no attribute mileage. So I'm setting mileage. Let me keep it over here. Now when I run this, so as you see, I have successfully printed out I'm a vehicle, mileage of the vehicle is 120 and cost of the vehicle is 800. So we have created our parent class. Now it's time to go ahead and create our child class. So to create the child class, we will again go ahead and give the name of this class, which is car. So we'll have class of car, and to inherit something inside the parenthesis. So as you see, this class, we did not have any parenthesis over here, but after this child class, we'll have a parenthesis, and inside this, we will pass in the name of the parent class, which is vehicle. And this child class will have a method of its own, which is show car. This takes only one parameter, which is self. And I'm going ahead and printing out I am a car with this method. Now, once I create this child class, I will create an object of it, which is C1. Now here, as you see, even though I don't have a constructor inside this child class, but I'm passing in some values. This is because since this car class is inheriting the vehicle class, this will automatically have these two methods inside it. So this car class will have the init method and also the show details method. So this car class will have three methods in total, which are the constructor from the parent class, then the show details method from the parent class, and also this show car method, which is explicit for this car class. Now, since this also has the constructor, we would have to pass in the values for the mileage and the cost. And as you see, I am passing in the value for mileage, which is 200, and the value for cost, which is 1200. Then I'll go ahead and invoke the show details method with the help of this object of the child class. So as you see, this object is of child class, but this method is of parent class. But since this child class inherits the parent class, that is why we are able to invoke this method. And when you see the result, we have I'm a vehicle, mileage of vehicle is 200 and cost of vehicle is 1200. And since we also have this show car method, which is part of the car class, we can directly invoke it. So when I have c1.showCar, I get the result, I am a car. So we already have our parent class over here. Now let me go ahead and create the child class as well. So I will have class of car and I'll have this parenthesis, and inside this I will pass in this vehicle class. Then I would have to go ahead and create a method which is explicit to the car class. So I will have def and I'll name this method as show car. This takes in only one parameter, which is self. And inside this I will have the print method and I will go ahead and just print out I am a car. And when I hit on run, you would see that we have successfully created this class. So after creating this class, I would have to create an object of this. So I will have c1 is equal to car. And since this inherits this will also have a constructor. So I would have to pass in a value for mileage. Let's say this car would give me a mileage of around 300 miles per gallon. And the cost of this car is around, let's say $10,000. So I'll pass in these two values over here. Now that I have passed the values, let me invoke the show details method. This is actually show vehicle method, which is there in the parent class. So c1.showVehicle, and as you see, I have the result. I'm a vehicle. Mileage of the vehicle is 300 and cost of the vehicle is $10,000. And since we also have this particular method over here, I can go ahead and invoke it. I will have c1.showCar. This has to be small c. Now when I hit on run, you would see that I'm able to print out I am a car. Now we'll see how to override the init method in the child class. So in the previous example, we had created a child class where we had only one method over here. But what we'll do is we'll also have an init method in this child class. And this init method will take in 4 parameters. The first 2 parameters will just be the 2 parameters for the parent class. And since the vehicle class has mileage and cost parameters, I'll have them over here. I'll also have the self parameter, and I will add 2 new parameters for the car class itself. So I'll have tires and HP. Now to pass in the values for the super class or the parent class, I would need this super method. So I will write down super.init, which would basically mean that I am invoking the init method of the super class, or I am invoking the init method of the parent class. And inside this, I am passing in mileage and cost. So these are just values of the parent class which I am passing in. And after passing in the values of the parent class, I'll go ahead and assign the values for the child class as well. So here, as you see, self.tires is equal to tires. I am assigning the value of tires over here to the attribute of the car class. Similarly, I am assigning the values of HP over here to the attribute of the car class. And once I assign these values, I would have to show them out. So here I will have def of show car details, and I will print out I am a car. Number of tires are self.tires and value of horsepower is this. And after I create the template of this child class, I can go ahead and create an object of this. So here, as you see, I will have C1 is equal to car, and I given 4 values over here. The first value will be for the mileage of the vehicle class. The second will be the cost of the vehicle class. So here, as you see, I'm a vehicle. And when I invoke c1.showDetails, so here, even though show details is part of the parent class, I'm able to invoke this because car class is inheriting from the vehicle class. And here I have mileage of vehicle is 20 and cost of vehicle is $12,000. And I also have 4 and 300. And as you see, when I invoke c1.showCarDetails, I have the result I'm a car, number of tires are 4 and value of horsepower is 300. So I'll go ahead and create the parent class again and child class again over here. So I will have class of vehicle, and this will take in, this will have init method. So I'll write down def over here. I will write down init, and this will definitely have the self parameter over here, and this has two values which are mileage and cost. Now I would have to assign these values, so it will be self dot mileage is equal to mileage over here. Then I will have self dot cost is equal to cost, and this is how I am assigning the values for mileage and cost. Once I do this, I would have to go ahead and print out the values. So I will have a new method for it. I will have def of show car details over here, and this will only have one parameter, which is self, and I will start off by printing I'm a vehicle, and after this we would have to print out the mileage of the vehicle is the mileage of the vehicle is here it will be self dot mileage. Then I'd have to also print out the cost of the vehicle is here it will be self dot cost. And this is how we have created this template for the vehicle class. Now I'd have to create the template for the child class as well. So here it will be class of car, and since this is inheriting from the vehicle class, I'd have to pass the vehicle as the parameter inside this. And after that I would have to override the init method, and since I have to override, I need to create an init method of the car class itself. And I'll start off by giving the self parameter. Then this will have mileage and cost for the parent class. Then it will have tires and HP, which are exclusive to the car class itself. And after this, I will invoke the super method. So this is, with the help of this, I'll be able to invoke the init method of the super class. So I will have super dot init, and inside this I will just pass in mileage and cost. And once I do this, I would have to assign the values for tires and HP. So it will be self dot tires is equal to tires, and self dot HP is equal to HP. And now that I have created this init method or overridden this init method, I would need an explicit method for the car class itself. Let me give it a space over here, and this time it will be def of show car details, and I'll have self over here. And after this will actually only have self and nothing else, and I'd have to go ahead and print out I am a car, and after this I'd have to print out the number of tires are. Here it will be self dot tires, and after that I'd have to print out the horsepower as well. So here it will be the horsepower is, and the value will be equal to self dot HP. And now that I have created the parent class and the child class as well, I'd have to create an object of it. Here it will be equal to C1 is equal to car, and I'd have to given the value of mileage and cost. Let's say the value of mileage is around 30, so it would give around 30 miles per gallon, and the cost, I would say this is $5,000. And after that, let's say this car would have 4 tires, and the horsepower of this would be equal to 499. And we have created the object of this. Now that we have also assigned the values, I can go ahead and invoke the methods of the parent class and the child class. I will have c1.show car details over here, and you would see that I have printed out I'm a car. The number of tires are 4 and the horsepower is 499. So these are the details of the child class or the car class. Now I'll print out the details of the parent class. So here I will have c1 dot show vehicle details, and when I print this out, This is, so seems like I've overridden this. I will keep the name as show vehicle details over here. So this method in the parent class will be show vehicle details, and this method in the child class will be equal to show car details. And once I have done this, you would see that I have this result. I'm a vehicle, the mileage of the vehicle is 30 and the cost of the vehicle is equal to 5,000. Going ahead, we'll look at the different types of inheritance. So we've worked with single inheritance. Now we'll see what is multiple inheritance and what is multi-level inheritance. So we'll start off with multiple inheritance, and in multiple inheritance, we'll have a child which inherits from more than one parent class. So let's say if you have a mother and a father, obviously you will have a mother and a father, and you would be inheriting some of the features from your mother and some of the features from your father. And thus what is happening over here is known as multiple inheritance. So as you see, if there's a child class, this child class will be inheriting some features from parent 1 and some features from parent 2. And this is what is known as multiple inheritance. And let's have a look at this over here. So we are starting off by creating the first parent class of parent 1. I have two methods over here. In the first method, I am assigning the value for string 1. So assign string 1, I have self and str1. And with the help of this, I am assigning the value for this attribute of str1 in this parent 1 class. Then once I assign the value for this str1, I'll go ahead and show out this value or return this value with show string 1. So in parent class 1, I'm assigning the value for string 1. Then I have parent class 2, and with the help of parent class 2, I am assigning the value of str2 first. Then I will go ahead and return the value of str2. Then I will have a child class. I will name this child class as a derived class, and this over here takes in two parameters, or in other words, this is inheriting from parent 1 and parent 2. And this again has two methods over here. The first method is assign string 3, and I am assigning the value for string 3 over here. Then I will go ahead and show it out. As you see, I am returning, or I am printing out self.str3. So parent class 1, parent class 2 and child class. And after that, what I'm doing is I am creating an object of the derived class or of the child class. And here I have d1.assign string 1. So even though assign string 1 and assign string 2 belong to the parent class, I am able to invoke them because child class is deriving from both of the parent classes. So here I am assigning the value of 1 to string 1, I am assigning the value of 2 to string 2, and I am assigning the value of 3 to string 3. Once I given the values, I go ahead and show out the values over here. So d1.show string 1, I get 1, d1.show string 2, I get 2, and d1.show string 3, I get 3. Now, if this is a bit confusing, let's go to Jupyter Notebook over here, and let's create our two parent classes and one child class. So for this purpose, I'd have to given this keyword class, and I'd have to given the name of the first parent class, which is parent 1. And after this, I will create a method def, and I will name this method as assign str1. This will have two parameters. The first parameter will be self, next will be str1 over here. And I'll just write down self.str1 is equal to str1 over here. And once I assign the value, I'd have to print out this value or show out this value. So for that purpose, I would need another method. Here it will be show str1. And what I'll do inside this is this will only have the self attribute, and I would have to return the value of string 1. So this will be equal to return of self.str1. And you would see that I have created the first class, first parent class. Similarly, I'll go ahead and create the second parent class. This time it will be equal to class of parent 2. And here I will have def of assign str2. it will be self. I will have str2 over here, and I'd have to assign the value. This will be equal to self.str2 is equal to str2 over here. And I'll go ahead and create the next method. I will have show str2. I'll have self over here, and I'd have to return str2. And I have also created the second parent class. Now that both of my parent classes are ready, I can go ahead and create the child class. So here, class of, I'll just name this child class as child because that is more intuitive. And inside this, I will be passing in both of the parent classes. I'll have parent1 as well as parent2. And now that I pass in both of the parents, I'll create one method exclusive for the child class itself. And inside the parent class, I'll be assigning the string 3. Assign str3 over here. This will have the self parameter, and I'll have str3 over here. And this is how I'll be assigning the value. Self.str3 is equal to str3. And once I assign the value, I would have to go ahead and print it out. So here it will be show str3. It will be self over here, and I will go ahead and I will return. So again, here I'd have to keep in mind that this is self of str2, and here again it will be equal to self of str3. And as you see, I have created all of the 3 classes, 2 parent classes and 1 child class, which is inheriting from these 2 parent classes. Now I can go ahead and create an object of this. So here I will have C1 is equal to child. Once I have created this object, I can go ahead and invoke the methods. So I'll start off by invoking the method of the first parent class. So C1.assign str1. Inside this, I will pass in the value of 1 over here. Then I will go ahead and invoke the method of second parent class. This will be equal to assign str2. Inside this, I will pass in the value 2. Then I will go ahead and invoke the method of the child class itself, assign str3. And inside this, I will pass in the value 3. Once I invoke all of this, then I can go ahead and print them out. So I will have show str1, and you would see that I have printed out 1. Then I will have c1.show str2. Then I would have, we have an error over here. So let's check this properly. Self.str2, we are assigning the value over here, and we are returning this over here. c1.show str2, name str2 is not defined. So what I'll do is I'll run all of these again because I had added the self parameters, and this time we need to get the result. And this time, as you see, when I have c1.show str2, I get 2 over here. Now similarly, I'll go ahead and invoke the third string. So I will have c1.show str3. And this time when I hit on run, you would see that I get the result 3. So this is how we can implement multiple inheritance. Going ahead, we have something known as a multi-level inheritance. And you can consider multi-level inheritance to be grandfather-father-child relationship. And as a grandchild inherits his or her features from maybe his parents, and those parents inherit their features from their grandparents. So here you have multiple levels, and this is what is known as a multi-level inheritance. So here we have 3 classes. We start off by creating the parent class first, and in the parent class we are assigning the name of this person, and then we are showing out the name of the person. Then in the child class, we are assigning the age of the person, and we are showing out the age. And as you see, this child class is inheriting from the parent class. Then we have the grandchild class, where we are assigning the gender and we are showing out the gender. And here you see that the grandchild class is inheriting from the child class. So here there are three levels. Child class is inheriting from the parent class and the grandchild class is inheriting from the child class. Now let's go to Jupyter Notebook and implement this. We'll have to start off by creating the parent class. I will have class, I'll have parent over here. And inside this, I will create a new method called as assign name. This will have self and then we will have name over here. And inside this, I'll just write down self.name is equal to name. This is how I'm assigning the name. Then I'd have to show out the name. And for that purpose, I will have show name. This will only have self over here and I need to return self.name. And I have created the parent class. Now after this, I would have to create the child class. So here I will have class of child. I will create a new method over here and I will name this method as assign age. I will have self. I'll have age over here and I need to assign this age. So here it will be equal to self.age is equal to age. Then I would have to show out the age. I'll have to create a new method. This will be equal to show age. I'm writing down self over here and I would have to return this. So this will be equal to return self.age and this child class is inheriting from the parent class. So that is why I'll pass in the parent class as a parameter to the child class. Then finally, I will create the grandchild class. Here I will have class of grandchild and this grandchild class will be inheriting from the child class. This again will have two methods. The first method will be assign gender and this is how I am passing in the two parameters. I'll have self and gender and here I would have to set self.gender is equal to gender. Then I will create a new method over here, show gender. And here I will only have self and I would have to return this. It will be equal to return self.gender. And now that I have created these three classes over here, I have my parent class, the child class and the grandchild class. I can go ahead and create the object of the grandchild class. I'll call it GC and I will invoke it like this. And once I create this grandchild class, I can assign the name, age and gender. So I will have gc.assign. Let me write it down again. So here it is gc.assign name. And the name which I am setting or giving to this person is Bob. Then I'd have to give him some age. So here it will be gc.assign age and let's say Bob is 54 years old and I'll also assign the gender. This will be equal to gc.assign gender and the gender is male. I have assigned these three things. Now I'd have to go ahead and show them out. So here it will be gc.show name and I am setting the name to be equal to. I don't have to give anything over here. I just have to invoke it. And as you see, I get the name of this person as Bob. Now let me also invoke the age over here, gc.show age. You would see that the age of this person is 54. Then I will have gc.show gender. And here, as you see, the gender of this person is male. Now we'll start off with this library called as Numpy, which stands for numerical Python. And as it is stated over here, it is the core library for numeric and scientific computing. So whatever numeric or scientific calculations you'd have to perform, Numpy should be your go-to language. And this library called as Numpy consists of multi-dimensional array objects and a collection of routines for processing these arrays. So let's go ahead and create our first Numpy array. So you can have a single dimensional Numpy array or a multi-dimensional Numpy array. Now we'd have to start off by importing this library. So to import NumPy, we'll type in import NumPy as NP. So this NP which you see over here is known as the alias. So we are importing the library NumPy with this alias NP. Now this NumPy library has a lot of methods, and one method is called the array method. And with the help of this, we will be able to create the NumPy array. All we have to do is type in np.array, and inside this I am passing in the list of values starting from 10 going on till 40, and I'll store it in this object called as n1. And when I print it out, I get the result 10, 20, 30, 40. Similarly, I go ahead and create a multi-dimensional array. So here we are passing in a list of lists. So here we had a single list. Here we are passing in a list of lists. So as you see, we have a list over here, and inside this we have two more lists. The first list comprises of the elements 10, 20, 30 and 40, and the second list comprises of the elements 40, 30, 20 and 10. And when I print it out, this is how I get this multi-dimensional array. The first list is present in the first row and the second list is present in the second row. Now let me go to Jupyter Notebook and implement these two. Let me just add a comment over here. I'll name it as NumPy. Now I'd have to import the NumPy library. So I'll have import NumPy as NP, and let's just wait till this library is loaded. Now that this is loaded, I can go ahead and create the NumPy array. So for this, I'll have to use np.array, and inside this I'll be passing in a list of values. So I'll pass in 10, 20, 30 and 40, and I'm storing it in this object called as n1. Now let me print out n1 over here. And as you guys see, I have successfully created this NumPy array, which over here the values are 10, 20, 30 and 40. And just to be sure, I'll go ahead and check the type of this NumPy array. So I'll have type. Inside this, I'll pass in n1, and as you guys see, we get the result numpy.nd array. So nd array stands for n dimensional array. Now we'll go ahead and create a multi-dimensional array over here. So to create a multi-dimensional array, we'd have to pass in a list of lists inside this np.array method. So I'll have this outer list. Inside this, I will create two lists. So the first list, let's say, comprises of the elements 1, 2, 3 and 4, and the second list comprises of the elements 4, 3, 2 and 1. Now I'll just print out n2 over here, and I have created this multi-dimensional array where all of the elements from the first list are present in the first row and all of the elements from the second list are present in the second row. Now that we have created these NumPy arrays, we'll now see how to create or how to initialize a NumPy array with different ways. So now let's say if I want to initialize a NumPy array with only zeros, then we have a method called as zeros. It's very intuitive, isn't it? So here we are importing the NumPy array, then we are using np.zeros, and it takes in two parameters. So these two parameters basically indicate the dimensions of the NumPy array. So if I want to create a 1 cross 2 NumPy array where all of the values are zeros, then I can just go ahead and type in np.zeros, and inside this I'll pass in the dimensions, which is 1, 2, and I get a 1 cross 2 NumPy array where the values are only zeros. Similarly, over here I am creating a 5 cross 5 NumPy array where all of the values are zeros. So I'll just use np.zeros, and inside this I'll pass in 5, 5. Now let me go ahead and implement this in Jupyter Notebook. Here I'll add the comment np.zeros. Now I'll go ahead and let me just create this in n1, and inside n1 I'd have to use the np.zeros method, and over here I'd have to pass in the dimensions. So the dimensions would be 1, 2. And let me go ahead and print out n1 over here. So as you guys see, I have successfully created this NumPy array. Now if I want maybe a NumPy array with a different dimension, so the method would be the same. I'll have np.zeros over here, and inside this, let's say I want to create a 3 cross 3 NumPy array which consists of only zeros, and this I'll go ahead and store it in this object called as n2. Now let me print out n2 over here. And we have a 3 cross 3 NumPy array which comprises of only zeros. Now, if I want to initialize a NumPy array with the same number, then we can go ahead and use the full method. So here I am using np.full, and this takes in two parameters. The first parameter is the dimension of the NumPy array. The second parameter is the value which we'd want to insert into this NumPy array. So here we are creating a 2 cross 2 NumPy array where the value is filled with 10. So as you guys see, it's a 2 cross 2 NumPy array where we only have tens. So it's time for np.full. I'll just type in np.full. I'm adding a comment over here. Then let me add np.full, and I'd have to give in two parameters. Let's say I'd want a 4 cross 8 NumPy array, and I'd want the value 5 inside this. Now I'll store this in this object called as n3, and I'll just print out n3 over here. And as you guys see, I have created a 4 cross 8 NumPy array where the value is only 5. Now similarly, if I want to initialize a NumPy array within a particular range, then I can go ahead and use the aRange method. So here, as you guys see, I am using np.aRange, and this again takes in two parameters. The first parameter is the initial value from which the range has to start. So here when I give in 10, as you guys see, the range starts from 10. And when I give in 20, so here again you'd have to remember that 20 is exclusive, or maybe the second parameter is exclusive. And since this is exclusive, we'll only have values starting from 10 and going on till 19. And that is why 20 is not included in this result over here. Now we can go ahead and add another parameter. So here the initial value is 10, the final value is 50, and we have the skip value. So the skip value is 5, which would mean that after 10 we'll have 15. So 15 plus 5 becomes 20, 20 plus 5 becomes 25, and that is how this keeps on proceeding. Now when we reach 45, when you add 5 more to 45, that becomes 50. And since 50 is exclusive over here, that is why we end at 45. But on the other hand, if we had given the final value as 51, then we would also have the element 50 over here. So let's go ahead and implement aRange method over here. np.aRange, and I'll store this in n4. Now I'd have to use np.aRange, and I'll go ahead and give in the initial value as, let's say, 100. Then I'll give the final value as 200, and I'll print out n4 over here. And as you guys see, we have all of the numbers in sequence starting from 100 going on till 199. Now if I actually want the value 200 to be included in this as well, let me make the final value to be 201. And as you guys see, this time the range starts from 100 and also includes 200 over here. And we can also add a skip value. Now let's say if I given the skip value of 10. So here after 100 we have 110, then 120, and this goes on till 200. Now instead of 201, if I keep the final value as 200, we see that this NumPy array ends at 190 because 200 is exclusive. Now we can also go ahead and initialize a NumPy array with random numbers. And to initialize NumPy array with random numbers, we can use random.randint. So here we are invoking np.random.randint, and over here we have three parameters. The first parameter is basically, and over here we have three parameters. The first two parameters basically indicate the range from which we would want the random numbers. So we would want the random numbers in this range of 1 to 100. And this third parameter would tell the Python interpreter how many random numbers do we need. So in the range of 1 to 100, we would need 5 random numbers. And as you guys see, this is the result which you get over here. So we have 95, 88, 26, 22 and 76, which are 5 random numbers generated between the range of 1 and 100. I'll add this comment random. Now let's go ahead and initialize a NumPy array with some random numbers. So I'll have np.random.randint because I want a random set of integers, and this will take in 3 parameters. Let's say I would need values between 50 and 100, and I would need 10 random values over here, and let me store this in N5. Let me go ahead and print out N5 over here. And as you guys see, I have 10 random values which are generated between the range of 50 and 100. Now, similarly, if I go ahead and run this again, I'll get a different set of values. As you guys see, we have a different set of values again. When I click this, we again have a different set of values. That was all about initializing a NumPy array with different methods. Now you can also go ahead and check the shape of a NumPy array. And to check the shape of a NumPy array, we have the shape method, which again is very intuitive. So here we are creating a NumPy array where we are passing in a list of lists. So in the first list we have 1, 2 and 3. In the second list we have 4, 5 and 6. So obviously we will have a NumPy array where we'll have 2 rows and 3 columns, and this is what the n1.shape gives us. Now if we want to change the shape of this, then we can use the same method. So here what I'm doing is I'm typing in n1.shape and I'm changing the shape from 2, 3 to 3, 2. That is, instead of having 2 rows and 3 columns, I will have 3 rows and 2 columns. So this same shape method can be used to check the shape of the NumPy array and also reshape the dimensions of the NumPy array. So let me create a NumPy array over here. So we would have to create a multi-dimensional NumPy array. So this will be n6 is equal to, I'll have np.array, and inside this I'll have to create a list of lists. So in the first list I'll have values 10, 20 and 30, and in the second list I'll have values 40, 50 and 60, and I'm storing this in n6. Now once that is done, let me just print out n6 over here. So you guys can see this NumPy array. Now I'll also go ahead and check the shape of it. So I'll have n6.shape, and we get the result that this is a NumPy array where we have 2 rows and 3 columns. Now I can also go ahead and change the shape of this. So I'll have n6.shape, and over here I am changing the shape to be equal to 3, 2. Then I'll go ahead and print out n6. And as you guys see, we have converted this from a 2 x 3 NumPy array to a 3 x 2 NumPy array. So you had 10, 20, 30 in the first row. We've got 10, 20 in the first row here. So similarly, this is how this has been changed. Then we have some stacking methods over here. We have vstack, head stack and column stack. So let's just start with vstack. So we are creating a NumPy array n1 where we have the values 10, 20 and 30. Then we are creating the NumPy array n2 where we have the values 40, 50 and 60. Now when we use vstack over here, this again takes in 2 parameters where we'll just pass in 2 NumPy arrays inside this. So as you guys see, we are vertically stacking over here. So when I say vertically stacking, I have one NumPy array on top of another NumPy array. So because I'm using n1, n2, n1 comes at the top, n2 comes at the bottom. So this is how vertical stacking works. Then we can also go ahead and horizontally stack 2 NumPy arrays. So n1 and n2, we've got the same NumPy arrays over here, and instead of using vstack, I'm using the head stack method. I'm passing in n1 and n2, and as you guys see, 40, 50 and 60. So n2 has been stacked horizontally to n1. Then we have the column stack. So if we want to stack these NumPy arrays into separate columns, so we have n1 and n2, and when I'm using column stack over here, as you guys see, n1 goes into the first column, n2 goes into the second column. And this is how we can work with these stacking methods. So I'll have to create these 2 NumPy arrays over here. I'll have n1, which will be np.array, and inside this I'll have 1, 2 and 3. Then I'll also go ahead and create n2. So this will be np.array, and inside this I'll have 4, 5 and 6. So I have my n1 and n2 ready. Now I'll start off with vertical stacking. So I'll use np.vstack, and inside this I'm passing in n1 and n2, and let's see what would be the result. So we have vertically stacked n1 with n2. n1 is at the top, n2 is at the bottom. You can also change how these are stacked. So instead of giving n1, n2, let's say if I give in n2 and n1, you guys would see that n2 is at the top and n1 is at the bottom. Now we can similarly work with the head stack method. So here I'll type in np.hstack, and inside this again I'll pass in n1 comma n2, and as you guys see I have stacked n2 at the back end of n1. Now if I want n2 first and n1 second, I just have to change the sequence. So inside np.headstack I'll give in n2 comma n1, and I have 4, 5, 6 first, and n1 is attached at the back end of n2. Then we have column stack, so I'll just have np.column stack over here, and inside this I'll pass in n1 comma n2, and as you guys see I have n1 in the first column, n2 in the second column. Similarly, if I give in n2 comma n1, you will see that I have n2 in the first column and n1 in the second column. So this is all about stacking the NumPy arrays. Now we'll also work with intersection and difference methods. So here again we have two NumPy arrays. So in the first NumPy array we have the values from 10 to 60, and in the second NumPy array we have the values from 50 to 90. And if I want the common elements between these two NumPy arrays, then I can use the intersect 1D method. So here in the intersect 1D method, I would just have to pass in these two NumPy arrays, and as you see in the result, we get a new NumPy array comprising of the common elements in these two NumPy arrays. Then over here I have n1 and n2. If I want to find out all the elements which are unique to n1, then I can use the setDiff1D method. So here in n1 we have the elements starting from 10 going on till 60. In n2 we have elements starting from 50 going on till 90. So here as you guys see, 50 and 60 are common in n1 and n2. And if I want the elements which are unique to only n1, then I would have to use setDiff1D, and I'll pass in n1 and 2. As you guys see, I get only 10, 20, 30 and 40 because 50 and 60 are present in both the NumPy arrays. I can also change the sequence over here. So instead of passing in n1, n2, when I pass in n2, n1, then this will give me all of the unique elements which are present in n2. And since 50 and 60 are common in both the NumPy arrays, the resultant will be 70, 80 and 90 because these are the only unique elements in n2. So let's go ahead and work with intersect 1D and setDiff1D. I'll just add a comment over here, intersect 1D, and I would have to create two new NumPy arrays. I'll have n1 over here. So I'll have np.array, and inside this I'll pass in 1, 2, 3, 4, 5, 6, and I'll have n2, and inside this I'll go ahead and create a list of elements where the elements start from 5, 6, 7, 8 and 9. So I have these two set over here. Now that my two NumPy arrays are ready, if I want to find out the common elements which are present in these two NumPy arrays, I'd have to use intersect 1D. So I'll have np.intersect 1D, and inside this I'm passing in n1, n2, and when I hit on run, we see that the common elements between n1 and n2 are 5 and 6. Now if I want only the elements which are common to n1, then I can use the setDiff1D method. So here I'll have np.setDiff1D, and inside this again I'll be passing in n1, n2, and as you guys see I have 1, 2, 3 and 4 which are common to only n1. Now similarly, if I want all of the elements which are only common to n2, then I can have np.setDiff1D, and I'll just change the sequence over here. Instead of passing n1, n2, I'll have n2, n1, and the only unique elements which are there in n2 are 7, 8 and 9. Now we'll go ahead and perform some simple NumPy array mathematics. So we'll see how to add two NumPy arrays. So again over here we have two NumPy arrays. In N1 we have 10 and 20, in N2 we have 30 and 40. Now if I want the total sum of all of the elements which are present in both of these two arrays, I can just directly use the sum method. So I'll have np.sum, and inside this as a list I'll pass in n1 comma n2, and you will see that the resultant value would be 100 because 40 plus 30 plus 20 plus 10 is equivalent to 100. Now if I want to find out the individual sum along the rows and along the columns, then I can use the additional parameter called as axis. So if I want to sum the values along the column, then I'll set the axis to be equal to 0. So when I have the axis value to be equal to 0, as you guys see, I have 30 plus 10 equal to 40 and 40 plus 20 equal to 60. Similarly, if I want to sum these up along the rows, then I'll set the axis value to be equal to 1. And over here I have 10 plus 20 equal to 30 and 30 plus 40 equal to 70. I'll add a new comment over here, addition of NumPy arrays, and let me create new n1 over here. So I'll have np.array, and inside this I'll have 10 and 20. Then I'll go ahead and create n2, and inside n2 I'll again have np.array, and over here I'll have 30 and 40. I'd have to pass this on as a list of values, so I'll have 30 and 40 inside a list. So I have created n1 and n2. Now it's time to find out the total sum which is present along all of these. So I would have to use np.sum, and inside this I'll just pass in n1 comma n2, and actually I'd have to pass this as a list. So I'll have n1 comma n2 over here, and as you guys see, the resultant comes out to be 100. If I want to add the values along the column, so I'll have np.sum, then I'll have this list over here, I'll have n1 comma n2, then I'll have this new attribute called as axis, and I'll set the axis value to be equal to 0. And I get the resultant 40 and 60 because 30 plus 10 is equal to 40 and 40 plus 20 is equal to 60. Now going ahead, if I want to add the values along the horizontal rows, so here it will be np.sum, and over here I'll have n1 comma n2 again, and this time I'll set the axis value to be equal to 1, and I have 30 and 70 because 20 plus 10 is equal to 30 and 40 plus 30 is equal to 70. Now we'll see how to do some scalar operations on these NumPy arrays. So here we have a NumPy array where we have values 10, 20 and 30, and if I want to add the scalar value 1 to each individual element of the NumPy array, all I have to do is add this value 1 to this NumPy array, and as you guys see, n1 plus 1 becomes 11, 21 and 31. Similarly, if I want to multiply each individual element of a NumPy array with a particular value, so here if I want to multiply it with 2, I'll just write down n1 into 2. So 10 becomes 20, 20 becomes 40 and 30 becomes 60. And if I want to subtract a value, all I have to do is perform n1 minus 1. So 10 becomes 9, 20 becomes 19 and 30 becomes 29. And if I want to divide it, I'll just have n1 divided by 2. So 10 becomes 5, 20 becomes 10 and 30 becomes 15. So this was some basic idea about NumPy. Now let me just see what is there in n1 over here. Let me actually add some more elements inside this. So I'll have n1 is equal to np.array, and inside this I'll have 10, 20, 30 and 40. Let me also print out n1 over here for your reference. So now that we have n1, what I can do is I will just go ahead and add some scalar values to it. And let's say if I want to add 5 more to each individual element of this NumPy array, so I'll just write down n1 plus 5. And as you guys see, 10 becomes 15, 20 becomes 25, 30 becomes 35 and 40 becomes 45. Similarly, if I want to subtract a value, I'll just write down n1 minus 5 over here. and 10 becomes 5, 20 becomes 15, 30 becomes 25, and 40 becomes 35. We can also go ahead and multiply something to this. So I'll have, let's say, n1 into 10. Let me print this out. And as you guys see, we have multiplied these values with 10. Similarly, I can go ahead and divide this with something. So if I have n1 divided by 10, so we see 10, 20, 30, 40 becomes 1, 2, 3, and 4. So this is some basic scalar operation on top of the NumPy arrays. And we can also go ahead and use some mathematical functions. So we have this mean function over here, which would give us the mean value of all of the elements which are present. So the mean value of all of these elements comes out to be 35. Similarly, if you want to find out the median, then all we have to do is use this median method. We have to use np.median, we'll pass in this NumPy, and we see that the median value comes out to be 55.5. And if you want to find out the standard deviation, I'd have to use std, and I'm passing in n1 inside std, and the value becomes 36.59. So we have n1 over here, and if I want to find out the mean value, I'll just have np.mean, and inside this I'll be passing in n1. And as you guys see, the mean or the average value of all of the elements which are present in n1 comes out to be 25. Let me go ahead and create another NumPy over here. So I'll have np.array, and inside this I'll be passing in some random values. So let's say these are all of the values which are present in n2. And if I want to find out the median of all of the values which are present, so I'll just use np.median method, and inside this I'll be passing in n2. And the median of all of these values comes out to be 5. Similarly, if I want to find out the standard deviation, so here I'll have np.std. And if I want to find out the standard deviation of this particular NumPy array, so I'll pass in n2, and you would see that the standard deviation of all of the elements of n2 would be 2.397. So till now we've worked with some basic NumPy arrays. Now let's go ahead and work with a NumPy matrix. So here we are creating a 3x3 NumPy matrix, and to do that you'll again need a list of lists. So over here we'll have 1, 2, 3, 4, 5, 6, and 7, 8, 9. So this first list goes into the first row, second list goes into the second row, and third list goes into the third row. Now that we have created this NumPy matrix, let's see how can we access individual rows and columns from this entire NumPy matrix. So here, let's say if we want to access the first row, again you'd have to remember that the indexing in Python starts from 0. If we want to extract the entire first row, we'll just have n1, and inside parenthesis we'll pass in 0. And as you guys see over here, I have successfully extracted the entire first row. Similarly, if I want to extract the entire second row, then the index value for second row will be 1, and I have extracted the second row. And if I want to extract a column, then I'd have to do something like this. So in a column, I would want all of the rows. So here from this NumPy matrix, I would want the second column and all of the rows from the second column. So here, since I would want all of the rows, I'll just put in a colon over here. And since I want the second column, I'll give in the index value as 1. And as you guys see, I have extracted the entire second column over here. Similarly, if I want to extract the entire third column, the index value will be 2. And I have extracted the entire third column. Let's perform this in Jupyter Notebook. So I'll just write in NumPy matrix over here. Now that this is set, I'll have np.array, and over here I'll have a list of lists. So in the first list I will have 10, 20, and 30. In the second list I will have 40, 50, and 60. In the third list I will have 70, 80, and 90. And I will go ahead and store this in n1 again. Now I'll go ahead and print out n1, and let's see what would be the result. So this is our NumPy array which we have just created. Now if I want to access individual rows from this, I'll have to give in n1, And inside parenthesis, let's say if I want to extract the third row, then the index for the third row will be 2. I'll just have 2 over here. And as you guys see, I have successfully extracted the entire third row. Now similarly, if I want to extract the entire third column, then this time I would have to write n1. And over here, since I would want all of the records from the third column, so I'll just have a colon over here, then over here. So here you'd have to understand whatever is given on the left side of the symbol would indicate rows, and whatever is given on the right side of this comma would indicate all of the columns. So I'd want all of the rows, and all of these rows need to be from the third column, and the index for the third column is 2. And I have successfully extracted all of the elements which are present in the third column. Now we'll see how to transpose a matrix. So what is transposing? Transposing basically means when you're interchanging the rows and columns. So here, as you guys see, we have 1, 2, 3, 4, 5, 6 and 7, 8, 9. Now the rows should be interchanged with the columns. So here 1, 2, 3 which is present in the first row comes into the first column. 4, 5, 6 which is present in the second row comes into the second column. 7, 8, 9 which is present in the third row comes into the third column. Let's go ahead and perform transpose as well. So all I have to do is use np dot transpose, and inside this I'll just pass in n1 over here. So as you guys see, initially I had 10, 20, 30 which was in row. This became in column. 40, 50, 60 was in second row, became the second column. 70, 80, 90 was the third row, which became the third column over here. Now we'll see how to perform two matrices. So over here we have n1 where we have the elements starting from 1 going on till 9. Then we have n2 where we have elements starting from 9 going on till 1. Now if we perform the dot operator on this, which is basically matrix multiplication, this is how the multiplication happens. So the multiplication is row by column, which would basically mean, so here we have 1, 2, 3, here we have 9, 6, 3. So it will be 1 into 9 plus 2 into 6 plus 3 into 3, which will give you a result of 30. Then again we'll have row by column. So here it will be 1 into 8 plus 2 into 5 plus 3 into 2, which will give you a result of 24. Then it will be 1 into 7 plus 2 into 4 plus 3 into 1, which will give you a result of 18. And this is how this progresses, and finally we'll get this result over here. And the dot product of n1 into n2 and n2 into n1 will be different. So as you guys see, this is the dot product of n1, n2, and this is the dot product of n2, n1. Both of these will be different. So I already have n1 over here. Let me go ahead and also create n2. So here I'll write n2 is equal to np.array, and over here I'll have the elements in reverse order. So I'll have 90, 80, and then I'll have 70. Going ahead, I'll have 60, 50, and 40. After this, I'll have 30, 20, and 10, and I am storing this in this object called as n2. Let me also go ahead and print out n2 for you guys over here. So this is what we have. Now if I want to perform the dot product, so I'll have n1. I'll actually have, if I want to perform the dot product here, I'll have n1 dot dot. Inside this, I'll pass in n2. And as you guys see, this is the dot product of n1 cross n2. But we know that n1 cross n2 and n2 cross n1 is different. So when I perform n2 dot n1, the result will be different from n1 dot n2. So this was about matrix multiplication. Now we'll go ahead and see how can we actually save a NumPy array and then load it from somewhere else. So here we are creating this NumPy array where we have elements from 10 to 60. Then to save this NumPy array, we just have to use the save method. And over here we are saving this NumPy array with this name called as my_NumPy. So this takes in two parameters. First parameter is the name by which we'd want to save this NumPy array. Second is the array which we'd want to save. Now once that we save this, to load this NumPy array, we will have to use np.load, and over here we'd have to give in the name by which we save this NumPy array. So we save this NumPy array as my_NumPy, and we'd have to give the extension which is .npy, which basically stands for NumPy, and we go ahead and store this in n2 and we print out n2. we see that we have successfully loaded this NumPy array over here. Now I'll go ahead and save this. So I'll have np.save, and this, as we have seen, takes in two parameters. The first parameter is by which I save this. So I'll have save n1, and I would want to store n1. So I have saved this. Now if I want to load this, I would have to use np.load, and over here I'd have to give the name of the NumPy array. So it will be save underscore n1 dot npy. Let me actually remove this over here, and I will store this in, let's say, n9. Let me click on run over here. So we have an error over here. We have this error because I'd have to give this inside single quotes. Now if I click on run, we'll get the result. Now if I print in n9 over here, we finally get the result. So Pandas stands for panel data and is the core library for data manipulation and data analysis. So if you want to perform any sort of data analytical task, Pandas should be your go-to library. And Pandas provides single and multi-dimensional data structures for the purpose of data manipulation. So the single dimensional data structure is known as the series object, and the multi-dimensional data structure is known as the data frame. We'll start off by understanding about the series object. So series object is a one-dimensional labeled array. So we have already worked with the NumPy array. So in NumPy array, we had no labels along with it. It was just a simple blank array where we had stored some values. But over here in a series object, as you guys see, we have labels, or you can consider them to be indexed with labels over here for these. So first, we'd have to start off by importing pandas, which is the library, and we are giving this alias as PD. So import pandas as PD. Then if we want to create a series object, we'll have pd.series, and inside this, I am passing in the values 1, 2, 3, 4, and 5. And when I print it out, I get this series object. So when I check the type of this, type of S1, this gives me pandas.core.series.series. Now over here, you'd have to keep in mind that S is capital over here. So if you're given a small s, you will get an error. So let's go ahead and create our first series object. So I'll just add the comment pandas. Now our first task would be to import the pandas library. So I'll go ahead and type in import pandas as PD. Let's just wait for this to be loaded properly. Now that we have loaded the library, I can go ahead and create the series object. So I'll type in pd.series, where S is capital. Inside this, I'll pass in the list of values. So let's say I'll just have 10, 20, 30, 40, and 50, and I'll go ahead and store it in this object called as S1. Let me print out S1 over here, and as you guys see, I have created this series object. Let me also check the type of this. So inside the type method, when I pass in S1, you guys would see that this is a series object. And over here, we have the labels. So the labels are 0 to 4. So by default, the label or the index starts with 0 over here. So 10 is present at label or index 0, 20 is present at index 1, 30 is present at index 2, and that is how it proceeds further. Now, since we have labels in a series object, we can change how the label of the index looks like. So over here, we just had numbers starting from 0, but instead of numbers, let's say if I wanted alphabets over here, then I can add a new attribute called as index. So over here with this index attribute, I am setting the values to be equal to A, B, C, D, E. So here initially we had index 0. 0 has been changed to A. Then we had 1, 1 has been changed to B. We have 2, 2 has been changed to C, and that is how it proceeds. So now over here, let me go ahead and change these index values. So it is the same command over here. And with this same command, all I'm doing is adding a new attribute called as index. And I'll pass in a list of values for the indices. So I'll have A, B, C, D. Let me have D over here, and I'll have E. Now, when I click on run and I print out S1 over here, you guys would see that I have changed the indices from 0 to 4 to A to E. Now we can go ahead and see how to create a series object from a dictionary. So we have already worked with dictionaries. We know that the dictionary is a key value pair. So here we'll just give in pd.series, and over here we have three key value pairs, A10, B20, C30. So here automatically the keys are taken as the labels and these values are taken as the series values over here. Let me create a new dictionary. So I'll have D1, and inside D1 let me have four key value pairs. Maybe I'll have A and 10. Then I'll have B and 20. After that, I'll have C and 30. Going ahead, I'll have D and 40. Now, I'll just go ahead and print this out. As you guys see, I have successfully created this dictionary. Now, I would have to create a series object out of this. So I'll just have pd.series, and inside this, I'll pass in D1, and let's see what would be the result. So these four keys which were present became the labels, and these values over here in the dictionary became the series values as well. Now we can also go ahead and change the index position. So similarly, as we had actually changed the index values from numerical to alphabetical. So when I given the index values as B, C, D, A, this sequence is maintained. So I have B and C first. So for B, I have the value 20, C, I have the value 30. And D, we had not created any key with this particular index. So that is why we have NaN over here. And then we have A, for which we have the value 10. So this is how we can maybe add a new index position or change the existing index positions. So this is what we had over here. This was our series object. And now what I'd want to do is, so instead of A, B, C, D, I would want, let's say, C, B, A, and D. And if I click on run, you guys see that the sequence has changed over here. Now we'll also see how to extract individual elements from the series object. So here we have all of these elements starting from 1 going on till 9. And again, you'd have to keep in mind that the indexing starts from 0. So if I want to extract this particular element over here, so the index value for this would be 3. So 0, 1, 2, and 3. And when I given the index value as 3, I am able to extract this particular element. And if I want to extract a sequence of elements over here, so if I want the first 4 elements, then I'll have S1 colon 4. This would mean that I've been extracting all of the elements starting from index number 0 going on till index number 4. And since 4 is exclusive, so that is why we will only have till index number 3. So we'll have index number 1 going on till index number 3. And if you want to extract elements from the back side, here we'll have S1 and we'll type in -3 over here. So -3 basically means third element from the end. Third element from the end. When I give in colon, this would mean third element from the end going on till the end. So this is the third element from the end over here. So that is why I'll have 7, 8, and 9. And this is how I'll be able to extract a single element, a sequence of elements from the beginning, and a sequence of elements from the back. And let me just create a new series object over here. So I'll have S1 is equal to pd.series, and inside this I'll pass in a list of elements. I'll have 10, 20, 30, 40, 50, 60, and 70. Now that I have this, let me extract this element which is present at index number 3. So I'll have S1, I'll have parenthesis, then I'll just go ahead and give in the index value. So index value will be 3. And as you guys see, I have successfully extracted this particular element. Now if I want to extract the first 4 elements, then I'll just give in the colon over here and I'll have 4. And as you guys see, I have extracted the first 4 elements. Now if I want the last 3 elements over here, then I'll have S1, then I'll have colon, and I'll type in -3, which would mean the third element from the last going on till the last element over here. And I have 50, 60, and 70, which are the last 3 elements. Now we can also go ahead and perform some simple operations on top of the series object. So if I want to add a scalar value, So initially we had this series object where the number started from 1, went on till 9. And if I just wanted to add the scalar value phi to all of the individual elements which are present in the series object, all I have to do is use plus phi. And as you guys see, 1 becomes 5, 2 becomes 7, 3 becomes 8, and so on. And we can also go ahead and add two series objects. Over here I have S1 where the elements are from 1 to 9 and S2 where the elements are from 10 to 90. And when I perform S1 plus S2, this would add the elements which are present at the same index position. So here we'll have 10 plus 1, 11, 20 plus 2, 22, 30 plus 3, 33, and this goes on till the last index position over here. So let's go ahead and perform some basic operations on top of the series object. So I already have S1 over here, and these are the original values which are present in S1. Now I'd want to add 10 more to these existing values. So I'll just type in S1 plus 10. And as you guys see, the values, all of the values which are present in the series object have been incremented by 10. Now, also I can add two series objects together. So in the series object, I have 7 elements. I'll go ahead and create S2 where I'll have 7 more elements over here. So I would have to type pd.series, and inside this, let me just have 7, 6, 5, 4, 3, 2, and 1. Let me print out S2 for your sake over here. So we have S1 and S2, and when I perform S1 plus S2, this is the result which we get. So 10 plus 7 becomes 17, 20 plus 6 becomes 26, 30 plus 5 becomes 35, and this proceeds to the last index value. So that was all about the series object, which was a single dimensional labeled array. Now we'll work with a data frame, which forms the major part of all of the machine learning data science projects. So what exactly is a data frame? It is a two-dimensional labeled data structure. And if you'd have worked with SQL or maybe Excel, you would have dealt with tabular data. And a data frame helps you to deal with tabular data in Python seamlessly. So a data frame, because this is a tabular data, consists of rows and columns. Now let's see how can we go ahead and create a data frame from a dictionary. So to create a data frame, we'd have to use this particular method over here. We'd have to type in pd.dataframe, where D is capital and F is also capital. So by any chance, if you give maybe D as small or F as small, you'll get an error. So both of them have to be in capital case. And over here, I have two key value pairs. So the first key is name, and then we have a list of values which are Bob, Sam, and Annie. Then we have the next key, which is marks. Then we have the list of values for marks, which are 76, 25, and 92. So here, as you see, the keys become the column names and the values become the records over here. So name and marks become the column names, and these values over here, the list of values Bob, Sam, and Annie, which are the values for this key, become the records of this particular column. Similarly, these values are there for this particular key, and these become the records for this particular column. So let me go ahead and create a first data frame over here. So I'll just go ahead and type in data frame. Now to create a data frame, I'd have to type pd.dataframe, and D and F both have to be capital. And inside this, I'll create a dictionary. So to create a dictionary, I would need curly braces. So the first key would be name, and I'll go ahead and give in a list of names over here. Let's say the first name is Sam. Then we have Annie. Going ahead, we have Jennifer. Now, once we have the first key value pair, I'll go ahead and also add their marks over here. So the second key would be marks, and I'll have a list of values over here. Let's say Sam has got 50 marks, Annie has got 60 marks, and Jennifer has got 70 marks. And I'll go ahead and store this in df. Let me print out df over here. And we have created our first data frame, where the column names are name and marks, and the values are these over here. And let me go ahead and also show you guys the type of this object which I've just created. So inside this type method, I'll be passing in df. And as you guys see, this is pandas.co.frame.dataframe, which basically means this is a data frame object. Now that we have created our first data frame, we'll perform some basic functions on top of a data frame. We've got head, tail, shape, and describe. So we'll just implement all of these. Now to implement this, we will be performing them on a dataset called as the iris dataset. Now to read any CSV file, we have a method called as pd.read_CSV. So here I'll have pd.read_CSV, and inside this I'll give in single quotes and given the name of the file. So the name of the file will be iris.csv, and I'll go ahead and store this in a new object called as iris. Now let me hit on run. Let me check the first 5 records which are present in this iris data frame. So if I want to check the first 5 records which are present in this iris data frame, I need to use the head method. So iris.head, as you guys see, I have the first 5 records. So this iris data frame comprises of 5 columns, which are sepal length, sepal width, petal width, and species. And we'll have 3 different species, which would be Setosa, versicolor, and virginica. So this is how we can work with the head method. Now, similar to the head method, we would also have the tail method, which would give us the last 5 rows which are present in a data frame. So here I'll type iris.tail, and when I click on run, you guys would see the index value over here. The index value starts from 145 and goes on till 149, because there are 150 records in this iris data frame. So we have extracted the last 5 records and we have printed it onto the console. Then if you want to check the number of rows and number of columns which are present in this iris data frame, we can just use the shape method. So here I'll have iris.shape, and as you guys see, this gives us a dimension value of 150, 5, which means there are 150 records and 5 columns. Then we'll have the describe method. So here I'll have iris.describe. And now when I click on run, we have all of these numerical quantities over here. So let's say if I want to find out what is the minimum value which is present in the sepal length column. The minimum value present in this sepal length column will be 4.3. Similarly, what is the maximum value in sepal length column? It will be 7.9. What is the mean value? It will be 5.84. So these are some interesting metrics which we can find out with the describe method. So now that we know this, let's actually see how can we extract individual records or individual columns from a data frame. So for that purpose, we can use the .iloc and loc methods. So let's start off with the .iloc method. So .iloc method, with the help of it, we can extract rows and columns on the basis of index. So here iloc basically stands for index location. And over here, as you see, I have a comma, and on the left side of the comma, that would indicate all of the rows, and the right side of the comma, that would indicate all of the columns. So from this entire iris data frame, I am extracting the first 3 records. So here the rows would be 0 to 3, and 3 is exclusive over here. That is why I'll have the records where the index values are 0, 1, and 2. And similarly, the columns would be 0 to 2, which would mean the column which is present at index 0, which will be sepal length, and the column which is present at index 1, which is sepal width. 2 again over here is exclusive. So let me go ahead and extract some rows and columns with this iloc method. So we already have this iris data frame with us. Let me again print out the head for you guys, so that will be easier for you to have a glance at this. Now let's say from this entire data frame, I would want the records from index number 30 going on till index number 40, and I would want the columns which are present at maybe index number 3 and index number 4. So index number 3 will be 0, 1, 2, and 3. This is index number 3, this is index number 4. So here I'll have index number 3 going on till the end, because this is the last column. Let me print this out and show you guys the result. As you guys see, I have extracted all of the records starting from index number 30 going on till index number 39, and the columns which you see starts from index number 3, which is this particular columns index, and goes on till the end over here. So this is how we can extract individual rows and columns with the .iloc method. Now we have the .loc method. So instead of giving the column index, if I want to extract columns on the basis of their names, then I can go ahead and use the .lock method. And over here, when it comes to rows, you see that I've given 0 to 3. Here, when it comes to .lock, you'd have to keep in mind that 3 is inclusive. This is the only case where maybe you will find that the final value over here is inclusive. So when I given 0 to 3, you will get all of the records starting from index number 0 going on till index number 3, which is also inclusive. And over here I'm giving in the column names, which are sepal length and petal length, and that is what I'm extracting over here. So I have this iris data frame, then I'll just go ahead and use this .lock method. Now from all of these records, let's say I'd want all the records starting from index number 10 going on till index number 20, and the columns which I'd want to extract are sepal length and petal length. I'll just have sepal.length over here, and the next column which I want would be petal.length. Let me hit on run, and as you guys see, I have all the records starting from row number 10 going on till row number 20, and 20 is also inclusive over here. And the columns which I've extracted are sepal length and petal length. Now we'll see how to drop a particular column. So many a times it would happen that not all columns which are present in a data frame are important. So from this entire data frame, if we want to drop a particular column, then we can just go ahead and use the drop method. So here I'll have iris.drop, and I am dropping or removing the sepal length column from this entire data frame. So here, when I set the axis value to be equal to 1, this would basically mean that I am dropping a column. So if you want to drop a row, then you'd set the axis value to be equal to 0. And if you want to drop a column, then you'd set the axis value to be equal to 1. So if from this entire iris data set, again, I'll show you guys the head of this so that you guys can have a glance at all of the columns which are present over here. So from all of the columns, if I want to drop the species column, all I have to do is type in iris.drop, and inside this I'd have to give in the name of the column, which would be species, and I'd have to set the axis, which will be equal to 1 because I'm dropping a column. And as you guys see, I have successfully dropped the species column from this entire data frame. Now similarly, if I want to drop some particular rows which are present in this data frame. So here, as you guys see, the index value, it starts from 0, goes on till 4 over here. But if I want to drop the row indexes of 1, 2 and 3. Here, as you guys see, I have two parameters. First parameter, I'll give in a list of all of the indices that I'd want to drop. So I'd want to drop the index value 1, index value 2 and index value 3. And the resultant which you see over here, after 0, we directly jump on to the index number 4. So now from this entire data frame, this what you see over here, I'll just use iris.drop, and I would want to drop the index values of 1, 2 and 3, and I'll set the axis to be equal to 0. And when I hit run, you would see that after 0, we are directly jumping onto index number 4. So this is a very simple example of how to drop some records and how to drop some columns from your data frame. Now we'll go ahead and work with some simple pandas functions. So from the iris data frame, if I want to find out the mean values of all of the columns, I can just go ahead and use the mean method. Similarly, if I wanted the median values of the records of all of the columns, then I'll just go ahead and use the median method. Similarly, if I wanted to find out the minimum value, I'll use the min method. And if I wanted to find out the maximum value, I will use the max method over here. So very basic operations. So when I use iris.mean, this would give me the average values of all of the columns. So average sepal length of the entire data frame is 5.8. Average sepal width is 3.05, average petal length is 3.75, and average petal width is 1.19. Similarly, if I want to find out the minimum value of all of the columns, so I'll have iris.mean, and this will give me all of the minimum values. And if I want to find out the maximum values, I'll just go ahead and type iris.max, and this would give me the maximum value of all of the columns over here. So I've got the mean value, the minimum value, the maximum value, and I can also find out the median value. So I'll just type in iris.median, and when I click on run over here, this would give me the median values with respect to all of the columns which are present. Now we will get on with this library called as Matplotlib, which is mostly used for data visualization. And with the help of this library, we can create stunning plots such as bar plots, scatter plots, histograms, and a lot more. So we'll start off by creating our first plot, which will be a line plot. So we would require two libraries over here. The first library would be Numpy, because we would want to create our data with this Numpy library. Then we would import this PyPlot submodule from this Matplotlib library. So we'd have to type in from Matplotlib import PyPlot as PLT, and the alias which I'm giving for PyPlot is PLT. Then I'll create two NumPy arrays over here. The first NumPy array will be X, and I'm creating this NumPy array with the help of this np.arange method, and the range will be from 1 to 10. And then I'll create the next NumPy array, which is basically 2 times of X. So all I have to do is multiply X with 2, and then I'll get Y. So here we have 1, we have 2. 2 becomes 4, 3 becomes 6, and this is how it proceeds. Now once we create the data, all we have to do to create a line plot is use this plt.plot. So we'll have the plot method in this PyPlot module. So this takes in two parameters, which are X and Y. So we have already created our data X and Y. So X will be plotted on the X axis, Y will be plotted on the Y axis. And as you guys see over here, X goes from 0 to 10 and Y goes from 1 to 20 over here. And we see that there is a linear relationship between X and Y, or in other words, as the value of X increases, the value of Y also correspondingly increases. So let's go to Jupyter Notebook and create our first line plot using Matplotlib. So I'd have to start off by importing the required libraries. So I would need NumPy. Here I'll type import NumPy as np. And after this, I would also require Matplotlib. So I'll type from Matplotlib import PyPlot as PLT. Let me write the spelling properly over here. And once I've imported these two libraries, I'd have to create the data. So first I'll have X, and this I'll be creating with np.arange, and the range will be from 1 to 10. Since I want the numbers from 1 to 10, I'd have to give the value 11 because 11 will be exclusive over here. Then let me just go ahead and print out X for you folks over here. As you see, we have the numbers starting from 1 going on till 10. Now, if I have to create Y, Y will just be 2 times of X. So here I'll have 2 into X, and then let me print out Y for you folks over here. And as you guys see, this is all of the elements are just 2 times of the elements which are present in X. Now, since I have to create a simple line plot, I would have to use plt.plot, and this would take in 2 parameters, which are X and Y. So this data would be plotted onto the X axis. This data would be plotted onto the Y axis. And I'll just show this as a result. So as you guys see, we have this object X mapped on the X axis, this object Y mapped on the Y axis, and this is the corresponding line plot. Now that we have created this, we can also add the title X label and Y label. So we'd have to use this title method. So we'll have plt.title, and inside this we'll give the title as line plot. Similarly, we can also add X label and Y label by using these two methods. And as you guys see, we have added these two labels over here. So let me add the title X label and Y label plt. So I'll copy this entire code over here, and then I'll paste it over here. Now after this, I'd have to add the title. So for that, I'll use plt.title, and I'll just give the title as first line plot. Then I'll have X label. So here I'll have plt dot x label, and here I'll give the x label as x-axis. Then I would have the y label, so plt dot y label, and inside this I'll give the y label as y-axis. Let's run this and wait for the results. So as you guys see, initially this was just a bland plot without the title and the x and y-axis labels. Now with the help of these three methods, we have added the title, the x-axis label, and the y-axis label. Now we can also go ahead and change some more attributes with respect to this line plots. So we have color, line style, and line width. So initially, as you see over here, the color of this line by default is blue. But if I don't want the blue color and if I want some other color, then I can just use this color attribute and assign it a new color. Since I'm giving it a value of G, which basically means green color, and as you guys see, this is a green color. Similarly, we have this next attribute called as line style. So initially we have a solid line, but instead of a solid line, if I want a dotted line, then I can go ahead and use a colon over here. And as you guys see, we have a dotted line right now. And by default also the line width is 1. So we can go ahead and increase or decrease the line width. So here we are setting the line width to be equal to 2. And this is the final result which we get. So let's go ahead and add some color, line plot, and line width. I have the same code over here. Now what I'd have to do is add in some color. So I'll have this attribute called as color, and I'm setting, let's say I'll give it orange color to this. Now I would have to change the line style. So I would want a dotted line instead of this solid line. So I'll give in a colon over here, and I'll also change the line width. So I'll give the line width as 3. So as you guys see, initially this was the line which we had, but now I have changed it to this. So from blue, we have converted it to orange. From a solid line, we have converted it to a dotted line. And also you see that this is a thin line, and we have increased the width of this line by 2 points. Now we have only created one line in one plot, but we can also have 2 lines in the same plot. So for this purpose, I'll have 2 y variables. So x variable will be the same, which will be the number starting from 1 going on till 10. But I'll have 2 y variables, y1 and y2. y1 is 2 times of x, y2 is 3 times of x. So now that we have y1 and y2 ready, I'll have to make 2 plots because I'd want 2 line plots in the same graph. So first I'll have plt.plot, and this line will be between x and y1. So this first line which you are making, it will be between x and y1. And for this particular line, I'm setting the color to be equal to green, the line style to be equal to, so this will be a dotted line. Then we'll set the line width to be equal to 2. Then we'll have our next line, which will be between x and y2, and the color of this line will be red, and this will be a dashed line, and we are setting the line width to be equal to 3. Then again we have the title, x label, and y label, and we also have this new method called as grid. So in the earlier plot, as you guys see, we don't have any grid over here, but when we set plt.grid to be equal to true, we'll have a grid as well. And this is the resultant line which we get. So here we have the green line over here, which is this dash line. Then we also have this next line over here, which is between x and y2, and this is the line. And since I've also set the grid to be equal to true, we also have a grid over here in this particular graph. So I'll go back. We already have x. Now let me just print out x for you guys over here. These are all of the numbers which are present in x. Now y1, I'll set it as 2 times of x, and then I'll have y2, which will be equal to 3 times of x. So I have y1 and y2 ready. Now after this, I would have to make a plot between x and y1. So I'll have plt.plot, and onto the x-axis, I'll obviously have x. Then onto the y-axis, I'll have y1. And the color for the first line, I'll have green. And let's say the line width, I'll set this to be equal to 2. Then I'll have the next line which will be between x and y2. So here I'll just write down x comma y2, and for this line I'll set the color to be equal to red, and I'll change the line width over here again. So I'll set the line width to be equal to 5, and I would just have to print it out. So it'll be plt.show. And I would also want a grid over here. So before this, I'll set plt.grid, and I will set this to be equal to true. Let's hit run. And as you guys see, I have 2 lines in the same plot. Now in the earlier example, we had 2 lines in the same plot. But if we actually want 2 subplots itself, that is, as you guys see over here, this is one subplot, this is one subplot, and this line is present in the first subplot, this line is present in the second subplot. So this is also something which we can create. So first we have x, y1 and y2. So these would be the same variables. Once we have our variables ready, we would have to use the subplot method. So we'll have plt.subplot, and inside this I am passing in 1, 2, 1. So here 1, 2 basically means that I would have 2 plots over here, and those 2 plots would be present in this way. So I'll have 1 row, 2 columns. As you guys see, I have 1 row and 2 columns. So this is column number 1, column number 2, which are present in the same row. Then I will give in the index of this subplot. So this is index number 1. And for this first index, this will be the plot which we'll be creating. So for the first index, the plot will be between x and y1, color will be green, line style will be dotted, and line width will be 2. And as you guys see, at index number 1, we have this green colored line between x and y1. Then we'll have plt.subplot, which is our next subplot, and the first 2 parameters will be the same. The third parameter here will set the index value, which is 2. So this is what we'll be getting over here. And the second index will have the line plot between x and y2, and the color, as you see, is red, line style is dotted, and line width is equal to 2. Then we'll just go ahead and print it out. So we already have x, y1 and y2 ready with us. Now after this, we would have to start off by creating a subplot. So here I'll have plt.subplot, and I'd have to give in the dimensions over here. So I'll have 1, 2, 1. So I'm creating my first subplot over here, plt.plot, and this plot will be between x and y1. And I'll set the color to be equal to yellow. Then after this, I'll go ahead and create the second subplot. And the first 2 parameters will be 1 and 2 because I'd want these 2 plots along the columns. And I'll set the index to be equal to 2. Then I'll have plt.plot, and the next plot will be between x and y2. And over here I am setting the color to be equal to orange. Then I can just go ahead and show you guys the result. So as you see, I have 2 subplots over here. The first subplot is between x and y1, and the color of this line is yellow. The next subplot is between x and y2, and the color of this line is orange. Now, if I want the subplots along the row and not along the column, that is also I can set. So all I have to do is make this change over here. I'll set this to be equal to 2, 1. And similarly over here, I'll make this to be 2, 1, which means that I will have the plots along the rows. I'll have 2 rows and only 1 column. When I hit run, as you guys see, I have 2 rows and only 1 column. This is the first subplot. This is the second subplot. So that was a line plot which helped us to understand the relationship between 2 numerical entities. So whatever we mapped onto the x-axis was a numerical entity, and whatever we mapped onto the y-axis was also a numerical entity. Now we'll go ahead and work with something known as a bar plot, which would help us to understand the distribution of a categorical column. So for this, we are creating a dictionary called as student, and it comprises of 3 key value pairs. We have Bob 87, Matt 56, and Sam 27. Now we'll go ahead and extract the names and values individually. So the names of these students are basically the keys. So I'll have student.keys, which will give me all of these keys, and I'll go ahead and convert these keys into a list. So I'll pass this into this list method, and I'll store the result in this names object. Similarly, I'll extract all of the values, I'll convert all of the values into a list, or I'll store all of the values into a list, and I'll store that list in this object called as values. So I've got names, I've got values, and to create a bar plot, all I have to do is use plt.bar, and this takes in 2 parameters. The first parameter will have the categorical values, the second parameter will have the numerical values. Since the first parameter comprises of the categorical values, I'll pass in names over here, and the second parameter will be the values. And as you guys see over here on the x-axis, I have the names, which are Bob, Matt, and Sam, and on the y-axis, I have the corresponding values. So we see that Bob has scored the highest marks, followed by Matt, followed by Sam. Now, since we are creating a bar plot, I'll just add this comment bar plot over here, and I'd have to create a dictionary so that we get the data for this bar plot. So I'll name this dictionary as student, and we can create a dictionary with these curly braces over here. So I'll have the first student, who was Bob. Let's say Bob has scored 45 marks. Then we'll have the second student, Sam, and Sam has scored, let's say, 97 marks. Then we'll have Matt, and let's say Matt has scored only 23 marks. So we've got 3 key value pairs. Now that this is done, I'd have to extract the keys. So I'll type in student.keys, and I will convert this into a list. So I'll cut this, I'll put this inside the list, and I will store this in a new object called as names. Now that I have names of all of the students, I'll go ahead and also extract marks of all of the students. So I'll store that in this object called as values. I'll have to convert the result into a list, and inside this, I would basically have to extract all of the values. So it'll be student.values. I have names and values ready, and to create the bar plot, I would just have to use plt.bar. The first parameter will be names, and the second parameter will be values. Then I can just go ahead and show out the result. So we have Bob, Sam, and Matt mapped on the x-axis and their corresponding values, and we see that Sam has the highest marks and Matt has the lowest marks. And now, the plot which we had created earlier was very bland, and we can go ahead and add the title, x label, and y label to it, and also assign a grid. So we'll be using the same methods. To add the title, we'll have plt.title, and to add the x label and the y label, we'll be using plt.xlabel and plt.ylabel, and we'll also set the grid to be equal to true. I'll copy these 2 set of commands over here, and I would have to set the title. So here I'll have plt.title, and I'll set the title to be equal to marks of students. Then I'll have something on the x-axis, plt.xlabel, and I'll just have names and the x-axis. Then I'll have something on the y-axis. Here I'll just write down plt.ylabel, and on the y-axis I'll just write down marks, and I would also have to set the grid to be equal to true. So it'll be plt.grid, and here I'll set the value to be equal to true. And as you guys see, I have names on the x-axis, marks on the y-axis, and I've also set the grid to be true. Now after this, we can also create a horizontal plot. So the plot which we had created earlier was a vertical plot. So here we are basically doing two things. So if we have to create a bar plot, we have to use bar h instead of using just bar. And we are adding a color as well. So by default, we had the blue color. And if I want to change the color from blue to green, I'll use this color attribute and I'll map the green color to this. Rest everything will be the same. Let me add a new comment over here, which will be horizontal bar plot. Now that I have added this comment, let me go ahead and copy everything. I'll paste it over here, and instead of just having bar, I'll have bar h, and I'll set the color to be red. And we have this bar plot over here. So it's just that we have to interchange the labels. So on the x-axis, now we have the marks. So let me keep this as marks, and on the y-axis, we'll have names. Let me change this to names. And as you guys see, we have successfully created this horizontal bar plot. Now that we are done with the bar plot, we will head on to the next geometry, which will be a scatter plot. A scatter plot again is used to understand the distribution between two numerical entities. And these entities are represented in the form of data points. So we'll be creating two lists over here. The first list will be storing in X, which basically comprises of the elements starting from 10 going on till 90. Then we'll have the next list A, which comprises of some random elements. And here you'd have to keep in mind that both of the lists have same number of elements, else there'll be an error. And to create a scatter plot, we'll just use plt.scatter. We'll pass this over here, we'll pass this over here as a second parameter, and then we'll just show off the result. Let me go ahead and add a comment over here. So this will be a scatter plot. Now to create this scatter plot, I'd have to create the data. So I'd have to store something onto the x-axis. So in x, I'll just have 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then I'll have y, and in y, I'll just have 9 random numbers over here. So let me just store some 9 random numbers, which is done. Now to create this scatter plot, I'll have plt.scatter, and I'll just pass in x comma y, and I would have to show out the result, plt.show. And as you guys see, I have created this scatter plot. Let's start off with this particular point over here. This particular point indicates these two. So I have x, y, which is basically 1 and 5. So this intersection between 1 and 5 is where we'll be getting this point. So I have x, I have y, and this is the point I have. Then I have 2, 2. So the intersection of 2, 2, I'll get this particular point. Then we have this point over here, which is the intersection between 9 and 7. So as you guys see, I have 9 and 7 over here. Now we can also go ahead and add some aesthetics or change the aesthetics of the existing points. So we had same X and A. These are the same list which we have. It's just that we are adding new attributes over here. The first attribute is marker. Initially, we just had solid circles. So instead of having solid circles, if I wanted a star, then with the help of this marker attribute, I'll add star over here. Similarly, to change the color, I'll just have C and I'll assign green to this attribute C. And also I can change the size of this, and to change the size of this, I'll be using S. Let me copy this entire thing. I'll be pasting it over here. So these two will be the same. I'll add this new attribute called as marker, and I'll set the marker to be equal to star, and I'll change the color. Color will be, let's say, I'll have orange again, and I'll have size to be equal to 200. Let me print it out. And as you guys see, this is the result. Just to show you guys what happens if we increase the size. Instead of 200, if I keep it to be 500, you guys see that the size has increased again. Now instead of 500, what happens if I keep it to be 50? You would see that the size of the stars has decreased. Now, as we did with the line plot where we had two lines in the same graph, we can perform a similar sort of thing over here where we'll have two different sets of points in the same plot. So for this, we would need a new list. We already have X and A. Then we'll create a new list called as B. Again, we'd have to keep in mind that the elements which are present in this list, or the number of elements which are present in this list, should be equal to the number of elements which are present in A as well as X. Then we'll go ahead and create our first scatter plot by using plt.scatter, and the first scatter plot will be between X and A. And the first scatter plot here, these dots will be represented with stars. Then we'll go ahead and create the second scatter plot, which will be between X and B, and these will be represented with circles. And also we have different colors for both of these scatter plots, and also the size of the different data points will be different. I'll copy this entire thing over here and I'll paste it down. I'll change this to be equal to y1. Then I'll have a y2 as well, and then y2 I would need some bunch of elements over here, random 9 elements. So let me just have some random 9 elements. Let me just check how many elements do we have. So I have 1 2 3 4 5 6 7 8 and 9. So these 3 lists are ready. After this, I'd have to go ahead and create the first scatter plot, which will be between X and Y1. Then I'll go ahead and create the second scatter plot, which will be between X and Y2. And I'm not adding the marker because we have already added the marker for the first one. I'll just change the color for this. So the color for second one, let's just keep it to be blue, so I don't have to add the color as well. And I'll change the size of this. So for this, I'll set the size to be equal to 500. So as you guys see, I have two sets of points over here. The first set of point is being denoted by the small stars. The second set of points is being determined by these solid circles. Now, instead of having those set of points on a same plot, we can go ahead and create two subplots as well. So we'll be using the subplot method as we had used during the case of line plots. So here we have these 3 lists, then I'll have plt.subplot, then we'll have the same 3 parameters, and since I want these plots to be present column wise and not row wise, I'll have 1, 2, which means that I'll have 1 row, 2 columns, and then I'll give the index. So at index number 1, we'll have this scatter plot, which will be between X and A. So this is the scatter plot between X and A. Then I'll go ahead and create the next subplot, and the next subplot will be between X and B. I'll copy this entire thing. I'll paste it over here. It's just that I'd have to create a subplot now. So I'll have plt.subplot, and I want these plots column wise. So I'll have 1, 2, 1. And the first subplot will be this. Then I'll go ahead and create the second subplot. So I'll have plt.subplot, and here I'll be writing 1, 2, 2. And this is our first subplot, and this is our second subplot. So that was all about the scatter plot. A categorical column. But when it comes to histogram, we'll be using that to understand the distribution of a continuous numerical column. And we'll be creating this continuous numerical column or continuous numerical data with just a list over here. So this is a very basic example. I'm just creating a random list which comprises of all of these numbers, and I'm storing it in this object called as data. And to create a histogram, all I have to do is use this hist method. So inside plt.hist, I'll pass in this list. And when I show out, this is the result which I get. So here, let's actually have a look at this particular bin. So in a histogram, these are known as bins. So here for this bin, for the value 3, we have this value 4, or for the value 3 on the x-axis, we have this value 4 on the y-axis, which would mean that this number 3 is occurring 4 times. Similarly, if I look at this 1 over here, so for this 1 on the x-axis, we also have the value 1 on y, which would mean that 1 is occurring only once. Similarly, we have 4. So this number 4 is occurring 2 times. Then we have 8, which is occurring 3 times. So let's go ahead and create a histogram in Jupyter Notebook. I'll just add a comment over here. Histogram. And let me go ahead and create a list. So I'll store this list in L1 and I'll have some random numbers over here. So I have created my list. Now that this is ready, I can just go ahead and build out the histogram by using this method called as plt.hist, and inside this I'll be passing in L1. Then since I just have to show this out, I'll just have plt.show, and this is the result. So as you guys see, this number 3 is occurring 4 times. Then we have this number 6, which is occurring 3 times. And the rest of the numbers are occurring only once. Now we can also go ahead and change the number of bins which are present or the color of the histogram as well. So to change the color, we'll just use this over here. So for the color attribute, we are mapping in G, which will give us this green color. And initially we had 1, 2, 3, 4, 5, 6, 7 bins over here. But instead of 7 bins, let's say if I want to reduce the number of bins, I'll just use this attribute and set the number of bins to be equal to 4, and this is the result which I get. I'll copy this entire thing, I'll paste it over here. Now that I have created this histogram, I would want to change the color of this. So I'll set the color to be equal to green. And instead of, so how many bars do I have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Instead of having 9 bars, let's say I would want only 3 bars over here or 3 bins over here. I'll set the bins value to be equal to 3, and as you guys see, I have only 3 bins. Now let me set it to be 5, and I have 1, 2, 3, 4 and 5 bins. This was all about histogram. Now the earlier histogram which we had created was with respect to a single list. But if you want to create a histogram on top of a data frame, then let's see how can we do it. So here we'll be building this histogram on top of the iris dataset. So if you have to load any data frame, we'll have to use read_csv, since this is a CSV file. So inside read_csv, I am passing in the name of the file and I'll store it in this object called as iris. And when I use iris.head, this will give me the first 5 rows which are present in this data frame. Now after that, to create the histogram, we'll just use plt.hist, and inside this, so here we were passing in the list of numbers, but here instead of passing in the list of numbers, I'll pass in the column. So we have this sepal length column which is present in the iris data frame. So I'll just pass in the sepal length column, and I'll set the number of bins, and I'll also set the color to be equal to something, and when I show it out, this will be the result which I'll be getting. So here I'd have to load the iris data frame first. So in the iris object, I'll just have pd.read_csv, and inside this I'll give in the name of the file which will be equal to iris.csv. I'll click on run. So I'd have to import the pandas data frame as well to use read_csv methods. So I'll have import pandas as pd, and we have, let's just wait till this is loaded, both the library and also the data frame. Now in the while it is loaded, I'll go ahead and write in the head method as well. Now if I click on run, we'll have a glance at the first 5 records which are present in this data frame, and as we see, we have sepal length, sepal width, petal width, and the species column. And now I'd want to create a histogram for, let's see, this petal length column over here. then I'll just have to type in plt.hist, and inside this I'd have to pass in this petal length column. So here, so I'd given the name of the data frame first, and using this parenthesis I'll give in the name of the column. So the name of the column, let me keep this to be small, it'll be petal length, and I'll set the number of bins to be equal to let's say 50, and after that I'll set the color of the bins to be equal to green again, and we can just go ahead and show out the result. So this should be color and not C. I'll keep it as COLOR. Alright, so as you see, we have successfully created this histogram for this petal length column. Now we'll head on to the next geometry, which is a box plot. So this box plot basically gives us a 5-number summary. So here in this result, what you see, this is the minimum value, this is the 25% value, this is the 50% value, this is the 75% value, and this is the maximum value. So we'll be understanding more about this as we progress through the session. So first, what we'll do is we'll just go ahead and create 3 lists. In the first list, we just have numbers from 1 to 9. In the second and the third list, we have randomly given some numbers over here. And then we'll create a list out of all of these 3 lists. So inside this list method, I am passing in 1, 2, and 3 as a list, and I'll store the resultant list in this object called as data. Then if I have to create a box plot, I'll just use plt.boxplot, and inside this I'm passing in this data object which I just created, and when I show it out, this is the result which I get. Now when I compare these 3 boxes, let's actually understand the inferences over here. So for this plot, or this box basically refers to this particular list. This box tells us that the median value of the numbers which are present in this list is 5. The maximum value is 9. The minimum value is 1. Similarly, if we look at this particular box, so this box refers to this particular list. And this box tells us that the median value will be 3, the maximum value will be 5, and the minimum value will be 1. Then if we have a look at this particular box, this would tell us that the median value will be 7 for this list. The minimum value will be 4. The maximum value will be 9. So it's time to create a box plot. I'll add this comment over here, box plot. And after this, I'd have to create 3 lists. So I'll have L1. And inside L1, I'll just have all the numbers starting from 1 going on till 9. Then I'll have L2. Inside L2, I'll just randomly give in 9 numbers. And again, I'll have L3. And also in L3, I'll just randomly give in some numbers over here. Now, once we have L1, L2, and L3, I'd have to create a list of lists. So inside this, I'll just be passing in L1, L2, and L3, and I will store this in a new object called as data. So now that we have created data, I can just go ahead and build out the box plot. So I'll have plt.boxplot, and inside this, I'll just pass in data. Then I can just show it out to you guys. So we have these 3 box plots over here. So the first box plot represents this particular list. We see that the median value is 5, minimum value is 1, and the maximum value is 9. Then we have this second list over here. So for this, the median value is 5, the minimum value is also 1, and the maximum value is 8. So, and for this particular list, it seems that the median value and the 75% value is same. So for this, the median value is 8, the minimum value is 5, and the maximum value is 9. So one another geometry which is analogous to the box plot is the violin plot. So the only difference is to create a violin plot, we'll be using violin plot method instead of box plot method. And this is the difference between how these boxes and violins look. And we can, so normally if we don't set the show medians to be equal to true, we'll not have these lines or these indicators over here. So we'd also have to set this to be equal to true. So now here, I'll just copy this entire thing. I'll paste it over here. And instead of having plt.boxplot, I'll just have plt.violin-plot, and I'm printing out the same data. And as you guys see, I have created this violin plot. And now if I want the median, so I'll have show medians, and I'll set this show medians to be equal to true. And as you guys see, I have added the medians as well. And after the violin plot, we'll have the pie chart. And pie chart again helps us to understand the frequency or percentage of different categorical values. So here we have two lists. The first list comprises of all of the names of different fruits. So we've got apple, orange, mango, and guava. Then in the second list, we've got the quantity of these fruits. So we've got 67 apples, 34 oranges, 100 mangoes, and 29 guavas. And if I want to represent this relationship of the quantity of these fruits in a pie chart, this is how I can do it. So I'll be using plt.pie. And here first I'll be passing in the numerical entity. So the numerical entity is this quantity, and I'll be passing that over here. Then I'll have the categorical entity over here, which is fruit. So I'm assigning fruit to labels. Then I can just go ahead and show out the results. And as we see in the result, we see that the maximum percentage is of mango and the minimum percentage is of guava. So I'll have to create two lists over here. I'll create the first list. I'll have fruit, and the first fruit will be apple. The second fruit will be mango. The third fruit will be orange, and the fourth fruit will be lychee. Now that we have created all of these fruits, I'll also assign the quantity. So let's say I have 53 apples. I've got 43 mangoes, I've got only 12 oranges, and I've got 97 lychees. So I've got these two ready. Now after this, I'd have to create the pie chart. So I'll have plt.pie. First, I'd have to give in the numerical object, which will be quantity. Then I'd have to given the categorical object, so I'm mapping fruit onto the labels. Then I would just have to show out this pie chart, so plt.show. As you guys see, this is the resultant pie chart. So the maximum portion belongs to lychee and the minimum portion belongs to orange, because we have 97 lychees and we have only 12 oranges. Now we can also go ahead and change the colors of these different sectors and also add the actual percentage in these different sectors. To add the percentage, we'll be using auto PCT. So here for this auto PCT attribute, I am using 0.1f. Now what this basically means is the 0.1 basically means that I'll have the decimal values to one place. So if I have 0.1, this will mean I have decimal values to one place. If I'll keep it as 0.2, then I'll have decimal values to two places. And after this, I'm just adding this new attribute called as colors. And the coloring, it starts from the first label, which is apple over here. Orange, then I've got blue, which is for mango. Then I've got black, which is for guava. I'll copy this entire thing over here. I'll paste it over here. Now to add the percentage, I'll be using auto PCT, and here I'll have to use %0.1f. Let me add %%, and after this I'll also have to set the color over here. So the colors, I'd have to give in a list of colors. So let's say for apple, I'd want to give in green. Then for mango, I'd want to give in yellow. Then for orange, I'd obviously want orange. And for lychee, I'd want pink. Now when I hit on run, let's see what would be the result. Let me change this to colors instead of color. So as you guys see, I have the percentage over here because I had used auto PCT attribute, and it seems that we have, out of all of the fruits, 47.3 of them are lychees, and this is the color indicated. Similarly, out of all of the fruits, only 5.9% of them are oranges. So we have created the pie chart. Then something which is very similar to pie chart is the donut chart. And to create this donut chart, we'll be using two pie charts over here. So the data is same. We have fruit and quantity. It's just that first we'll go ahead and create our first pie chart, which comprises of quantity and labels. And I am adding a new attribute inside this, which is the radius. So I am setting the radius of this to be equal to 2. Then I'll go ahead and create another pie chart. Here inside this, I'll just pass in. So first we'd have to pass in numerical entity. So I'll just have a list which comprises of only one element or one value, which is 1. And this entire value or this entire list comprises of only one color, which is white. And I'll set the radius to be exactly half of the original pie. So I'm setting the radius to be equal to 1, and as you guys see, this is the outer pie chart, this is the inner pie chart. So the outer pie chart has a radius of 2, the inner pie chart has a radius of 1, and since I've given a color of white, this is what I have over here. So you can give in any random number over here, that doesn't really matter. So you can give 1, 10, 5, it is all the same. It's just that keep the color as W, because since a donut, it just basically looks like a donut, we'll have to give in the white color. I'll copy this entire thing, I'll paste it over here. I'll set the radius for this to be equal to, let's say, 4. Then I'll have a new pie chart over here. I'll just give in a random value. Let's say I'll give in 5 over here. And after this, I'd have to set in a color. And since there is only one value, I'll just give in white color over here. And after this, the only thing which I have to set is radius, and I'll set the radius for this to be equal to 2. Let's hit on run. And this is the donut chart which we get. So as you guys see, the radius for the outer pie chart is 4, the radius for the inner pie chart is 2. Let me reduce this. Let me keep this to be 2 actually, and let me keep this as 1. And this is the resultant donut chart. So Seaborn is another visualization library which is built on top of Matplotlib. So if you want to work with Seaborn, then we'd have to import Matplotlib as well. So to import Seaborn, we'd have to type in import Seaborn as SNS. And since this is built on top of Matplotlib, we'd also have to import Matplotlib. So we'll have from Matplotlib import pyplot as PLT. And inside Seaborn, we have this method called as load dataset, and we have some built-in datasets inside the Seaborn library. And one such built-in dataset is the fMRI dataset, and I'm storing this in this new object called as fMRI. And then I'll have a glance at this first 5 columns of this dataset. So we have these columns. We've got subject, time point, event, region, and signal. Now, out of all of these columns, I'd want to make a line plot between the time point column and the signal column. So to make a line plot with the help of this Seaborn library, since I've given the alias for this Seaborn library as SNS, I'll type in SNS.lineplot, and onto the x-axis I am mapping the time point column, and onto the y-axis I am mapping the signal column. And then I'll have a new attribute called as data. So basically I am building this line plot on top of this fMRI dataset, that I just go ahead and show out this line plot. So let's understand this properly. So if you look at this line plot closely, you would see that till the time point of 5 seconds. So let's say if this time point is in seconds, so till the time point of 5 seconds, the signal value is increasing. But from time point of 5 seconds to 10 seconds, you have the signal value to be increasing. And after 10 seconds, this sort of stabilizes and only increases to, so here if the value is minus 0.05, so from minus 0.05, it goes up to close to 0. So now that we are done with Matplotlib, let me go ahead and create a new notebook over here. And I'll name this new notebook to be equal to Seaborn. Let me rename it. I'll delete this. I'll name this as Seaborn Demo. And we'd have to load the required libraries. The first library is obviously Seaborn. So I'll have import Seaborn as SNS. Then I'd also need Pyplot. So I'll have from Matplotlib import Pyplot as PLT. Let's just wait for these two libraries to load. And once we have Seaborn with us, we'll be working with the fMRI dataset. So to load the fMRI dataset, we have the load dataset method, which is part of the SNS library. So I'll have SNS.load dataset, and inside this, I'll be passing in the name of the dataset, which is fMRI. And I will store it in this object called as fMRI, and let me have a glance at the first 5 records of it. So I'll just type in fMRI.head, and these are the different columns which are present, and I'd want to make a line plot between the time point column and the signal column. And for this purpose, I'd have to map the time point column onto the x-axis and the signal column onto the y-axis. SNS.line plot, and onto the x-axis I am mapping time point, and onto the y-axis I am mapping signal, and the data is obviously fMRI. Then I would just have to show out the result. So I'll have SNS. I'd actually have to give in plt.show over here. Let's hit run. So we have successfully created this line plot, and as we had already seen, so till 5 seconds there's an increase in the signal value, from 5 to 10 seconds there's a drop, and then it sort of stabilizes. Now we can also add a new attribute or new aesthetic called as hue. So here we had only one line, and this one line, arbitrarily the color of this was blue. But if I want the color of the lines to be actually determined by a column, what I can do is I can map a column onto the hue aesthetic. So we have the event column, and we are mapping the event column onto the hue aesthetic. So now the color of the lines would be dependent on this event column. And since we have two events over here, we have the stem event and we have the queue event. This blue color line represents the stem event, and this orange color line represents the queue event. And if we look at this blue color line over here, you would see that till time point of 5 seconds, the signal value, it goes up till maybe 20, and then it drops down to a minus 0.1. And similarly, if we look at this queue event, you see that the peak is not so high. So for the stem event, it was almost 0.2, and when it came to queue, it is only 0.05. But you'd also notice that the drop is not so steep. So for the drop of the stem event, it came from 0.2 and it will drop down to minus 0.10. But for this particular signal queue, the drop is very small. It dropped from 0.05 to only minus 0.05. And also if you see the increase of it, so once it dropped, the increase of queue event is much higher when compared to the increase of this stem event. So this is the same set of commands. It's just that I am adding a new attribute called as hue, and I'm determining the color of the lines on the basis of this attribute, and I'll be mapping the event column on top of this. So as you guys see, I have this event column, and this is the same column which I'm mapping onto this hue aesthetic. Event, we see that we don't have the event column. So what I'll do over here is I will cut this out. I'll paste it over here. I'll put in a comma, and since this is a column, I'd have to put this in double quotes. Now when I hit run, so seems like we have an error again over here. I have two commas. Let me go ahead and delete this comma. And we have successfully produced these two line plots over here. Now we can also go ahead and change the style of how these lines look. So now if I want these lines again, or the style of these lines again, to be dependent on a column, I can just go ahead and add a column onto the style aesthetic. So the color is also being determined by the event column, and also the style is being determined by the event column. So it will be the same command, and I'll be adding a new attribute to this. I'll have style, and to this I am mapping the event column, and you see that the queue event is being represented with this dotted line, and the stem event is being represented with this solid line. So now that we have created that, we can also add markers on top of it. So all we have to do is set the markers to be equal to true. Here in this command, I'll have this new attribute called as markers, and when I set this to be equal to true, you will see that, so I have markers now. When it comes to the stem event, the markers are solid circles, and when it comes to the queue event, the markers are crosses. So that was all about line plot with the help of the Seaborn library. Now we'll go ahead and create a bar plot with the Seaborn library. So to create this bar plot, we'll be actually needing the Pokemon dataset. So we'd have to start off by loading the Pokemon dataset. So we'll have pd.read_csv, and we'll store this pokemon.csv file in this Pokemon object. And once we store it in this object, we can go ahead and create a bar plot for this isLegendary column. So this isLegendary column is a categorical column, and that is why we are creating a bar plot. And in this isLegendary column, we have two categories, 0 and 1. So 0 indicates that the Pokemon is not legendary, and 1 indicates that the Pokemon is legendary. And onto the y-axis, I am mapping the speed column. And from this bar plot, it is very evident that legendary Pokemons, or the speed of the legendary Pokemons, is higher when compared to the speed of non-legendary Pokemons. So now I'll have to go ahead and load up the required data set. So to load the data set, I would need Pandas. So I'll just type in import Pandas as PD. Now once I have this, I need to load the CSV file. So I'll type in pd.read_csv, and inside this I'll give in the name of the CSV file, which will be pokemon.csv, and I will store it in this new object called as Pokemon. And once I've stored this, let me have a glance at this. So I'll just type in pokemon.head, and I'll show you all of these columns. So these are the different columns which are present over here. So against bug, against dark, against dragon, all of these columns basically tell us how does a Pokemon perform against these types of Pokemons. Then let me scroll it to the last. So here we have this isLegendary column, which would tell us if the Pokemon is legendary or not. Then we have this generation column, which would tell us to which generation does this Pokemon actually belong to. Then this column tells us what is the weight of this Pokemon in kg. Then this type 1 tells us what is the primary type of the Pokemon. Type 2 tells us what is the secondary type of the Pokemon. And then we've got other columns as well. So now for this bar plot, we'll be only working with this isLegendary column and then the speed column. So I'll be using SNS.barplot, and onto the x-axis, I would have to map isLegendary, and then onto the y-axis, I'll be mapping the speed column, and the data onto which I'd want to build this bar plot is the Pokemon dataset. Then I can just go ahead and show this out. And when I hit on run, you would see that I have successfully created this bar plot. And again, it is very evident that the legendary Pokemons, the speed of the legendary Pokemons is higher when compared to the speed of non-legendary Pokemons. So now we'll create a bar plot between isLegendary column and weight in kg column. So isLegendary column is again mapped onto the x-axis. It's just that here for the y-axis we are mapping weight kg column. And this time it is very obvious that legendary Pokemons, their weight is much higher when compared to non-legendary Pokemons. I'll cut this out, I'll paste it over here, and instead of mapping speed, I have the weight kg column. And when I hit on run, you would see that the weight in kg of a legendary Pokemon is much higher when compared to the weight in kg of a non-legendary Pokemon. Now, we can also go ahead and determine the color of these bars on the basis of a column, and we already know to do that we'll be using the hue aesthetic or the hue attribute. And I want the color to be determined by the generation column. So this time I'll be mapping the generation column onto the hue aesthetic. And as you guys see, we have 7 generations over here, starting from generation 1 going on till generation 1. And since we have 2 different legendary status, so 0 indicates that the Pokemon is not legendary, 1 indicates that the Pokemon is legendary. For these 2 categories, I'll have 7 bars each. So for those Pokemons which are not legendary, I'll have these bars, these 7 bars indicating to which generation does the Pokemon belong to. Similarly, for all of the Pokemons which are legendary, I'll have these bars indicating to which generation does the Pokemon again belong to. And again on the y-axis, since we have mapped speed, we have the speed values corresponding to whether the Pokemon is legendary or not legendary. So the same set of command, I would have to use the hue aesthetic, and onto this I'll be mapping the generation column. And as you guys see, so this denotes all of those Pokemons which are not legendary, this denotes all of those Pokemons which are legendary. And it is very clear that legendary Pokemons, they have much higher weight when compared to non-legendary Pokemons. And we have the distribution of Pokemons which belong to the different generations with respect to both legendary Pokemons and non-legendary Pokemons. Now going ahead, we can also change how the different palettes look for these bars. So we will use the palette attribute. So we've got these 3 different palettes over here. So again, the bar plot is between is legendary column and weight column. And it's just that instead of using a column to map it onto the hue aesthetic, we are using a new aesthetic called as palette, and we can directly use different predefined palettes. So first we have the blues D palette with a capital B. This is how it looks like. Then we have the rocket palette, and this is the resultant. And then we have the VLAG palette. Let me delete this hue attribute over here. And instead of that, I'll have palette attribute, and the first palette which I'll be using is blues D. And as you guys see, this is the blues D palette. Similarly, if I want maybe a more of red color, then I'll be using the rocket palette. Then if I want maybe a light shade of bluish gray, I'll be using VLAG, and this is what I'll be getting. Now, instead of maybe using a palette or maybe mapping a color onto the hue aesthetic, I can just go ahead and use the color attribute and assign one single color for all of the bars which are present. So I'm using the color attribute and I'm mapping the orange color to both these bars. I'll remove palette, and instead of palette, I'll have the color attribute, and I will set the color of these 2 bars to be equal to orange, and this is the result. So we are done with bar plot as well. Now we'll go ahead with the next type of plot, which is scatter plot, and we have already learned that a scatter plot is used to understand the relationship between 2 numerical entities. And over here we are building the scatter plot on top of the iris dataset. So we'll load this dataset up, then we'll be using sns.scatterplot, and onto the x-axis I am mapping the sepal length column, and onto the y-axis I am mapping the petal length column, and the data onto which I'm building this scatter plot is the iris dataset. And again, it's very clear that as the sepal length of the iris flower increases, the petal length of the iris flower also increases linearly. So here I'd have to load up the iris dataset first. So I'll have pd.read_csv. I'll give in the name of the file, which will be iris.csv. Now that I have loaded this, let me show you guys the first 5 rows of all of the columns, and this is the resultant. And to create the scatter plot, all I have to do is use plt.scatterplot, and since I want the scatter plot between sepal length and petal length, and I want sepal length to be onto the x-axis, so to x I'll be using sepal.length, and on the y-axis I would need petal length. So let me give in the name of the column over here, which will be petal length, and the data which I'm using is obviously iris. Then I can go ahead and show out the result. So let me just keep it as scatter over here. And again, this has to be equal to small d and not capital D. Let me hit on run over here, and this is the resultant value. Now, as you see over here, we can go ahead and add in color and also change the style of this. So initially we just had a simple plot between sepal length and petal length, but now I want these dots to be determined, or the color of these dots to be determined by the species column. So that is why I am mapping the species column onto the hue aesthetic. And after that, similarly, I am mapping the species column onto the style aesthetic as well. So here, as you see, we've got 3 different colors: blue, orange, and green. The blue color is being determined with the Setosa species. Then we've got this orange color, which is for the versicolor species. Then we've got this green color, which is for the virginica species. Similarly, we've got 3 different styles over here. For Setosa, we have solid circles. For versicolor, we have crosses. And for virginica, we have solid squares. The same command which I've copied, I've pasted it over here. I'll add 2 more attributes. The first attribute will be hue, and onto hue I'll be mapping the species column. Similarly, onto style as well, I'll be mapping species column, and when I hit on run, so I'll have it as hues. Now when I hit on run, seems like we have an error over here. Let me check it properly. And this over here has to be just hue. Now when I hit on run, this is the resultant scatter plot which I get. And now let's say instead of having the colors to be determined by a categorical column, if I actually want the color to be determined by a numerical column, I can also do that. So here, since petal length is mapped on the y-axis, and I want the color to be with respect to the petal length, I'll go ahead and map the petal length onto the hue aesthetic. And as you guys see over here, as the value of petal length is increasing, the intensity of these points is also increasing. So here on this lower left side over here, we have all of this very light shaded circles, and at the top right you have this high intensity or high intensely colored circles over here. I'll copy this, I'll paste it over here. Now I'll want the hue or the color to be actually determined by petal length itself. Let me keep the L to be capital, and when I hit on run, you would see that as the petal length value increases, the intensity of the color also increases. Let me just go ahead and also add the style over here. So this time the style will be determined by the species column, and you would see that we have 3 different styles. For Setosa, this is Setosa, you have solid circles. For versicolor, you have crosses, and for virginica, you have solid squares. So this was about a scatter plot. Now we'll go ahead and make a histogram or a distribution plot. So a distribution plot, you can consider this to be a combination of a frequency curve and a histogram. And we've already worked with histogram when it came to Matplotlib. We know that a histogram is used to understand the distribution of a continuous numerical value. So for this, we'll be using the diamonds data frame. So we'll load up this diamonds data frame, we'll store it in this diamonds object, and then we'll have a glance at it. After that, to create this distribution plot, we'll use dist plot, and inside this, if I want to understand the distribution of the price column, I'll just pass it over here. So I'll have diamonds of price, and as you guys see, this would show us the distribution plot. And as I've told you, the distribution plot is a combination of a histogram and the frequency curve over here. I'll just add this comment and I'll add distribution plot. Now over here, to create this distribution plot, I would need to load up the diamonds data set. So I'll have pd.read_csv, and inside this I'll be passing in the diamonds.csv file, and I will store it in this new object called as diamond. Now that I've loaded this data set, let me have a glance at the first 5 records of this. So diamond.head, and these are the different columns which are present. So I've got carat, which obviously tells about the carat of the diamond. Then we've got the cut type of the diamond. We've got color, clarity, depth, table, price. So this is price of the diamond in US dollars. So the price would mostly range from around $300 to around $18,000. Then we've got X, Y, and Z. X over here denotes the length of the diamond in millimeters. Y denotes the width of the diamond in millimeters, and Z denotes the depth of the diamond in millimeters. So once this is clear, I'd have to make a distribution plot, and since distribution plot is used for continuous numerical values, I'd want to make a distribution plot for this particular column. So I'll have sns.dist plot, and inside this I'll be passing in diamond. I'll have square braces over here. Inside this I'd have to pass in the column which is price, and I would just show this out. I'll have plt.show, and you would see that I have created this distribution plot over here. Now in the distribution plot, let's say if I want only the frequency curve without the histogram, that also can be done. It's just that in the same command, I would have to set hist to be equal to false. And when I set hist to be equal to false, I'll only get the frequency curve. I'll copy it, I'll paste it over here, and I'll add a new attribute called as hist, and I'll set this to be equal to false. And when that is done, you would see the difference. So this was a distribution plot which had both histogram and the frequency curve. Now this is a distribution plot which comprises of only the frequency curve. Now similarly, we can go ahead and add a new color to this, and to add a new color, we'll just use this color attribute and add this. So this was the distribution plot which we had created, and to this, if I want to add color, I'll use this color attribute. I'll assign it red, and you would see that I have assigned it the red color. Now if I want a distribution plot without the frequency curve, which would mean I'd want only the histogram, then here I will set KDE equal to false. So in the distribution plot, either we can have both the histogram as well as the frequency curve, or we can just have the histogram, or we can just have the frequency curve. To just get the frequency curve, we'll set hist to be false. To just get the histogram, we'll set KDE to be equal to false. And we can also go ahead and vary the number of bins which are present. To vary the number of bins, I'll use this attribute called as bins, and over here I'm setting the number of bins to be equal to 10. And I'm just setting the color to be equal to green. I'll select this over here, I'll paste it, and I'll set KDE to be equal to false. And when I do this, you would see that I have only the histogram without the frequency curve. Now if I want to change the number of bins which are present, so since there are 150 records, I'll have 150 bins, but instead of having all of this, so let's say if I want only 50 odd bins over here, I'll set 50, and as you guys see, I have only 50 bins. Now let's say instead of 50, maybe if I want only 10 bins, So you will see that I have only 10 bins. Now let's say if I want only 5, that also something which can be done. I'll set the value to be equal to 5 and we have only 5 bins over here. And after this, let's say if I want to plot it on a different axis. So till now we've been creating this distribution plot where on the x-axis, or basically this was based on the x-axis, but instead of having it to be based on the x-axis, if I want to map it vertically, then I would just have to set vertical to be equal to true. I'll have the same command over here. And here I'll set vertical to be equal to true. I'll remove this KDE equal to false from this. I'll also remove this particular attribute from this. Now, if I hit on run, you would see that I have mapped this distribution plot onto the y-axis. Next, we have a new geometry called as a joint plot. So this joint plot is a combination of a scatter plot and a histogram. So as you guys see over here, I have a scatter plot in the center and I have a histogram at the top side and the right side. And I'll be creating this joint plot on top of this iris data frame. So once I've loaded this iris data frame, I want to create a joint plot between sepal length and petal length. So I just created a scatter plot. So for scatter plot, we are just use scatter plot method. For joint plot, it's just that we have to use this particular method. We are passing in the same columns. Now, when it came to scatter plot, we had only this particular part. But when it comes to joint plot, here what you see for sepal length, you would have the histogram of the sepal length column as well. Similarly, for petal length, you will have the histogram for petal length column as well. So this is an interesting point about joint plot. We already have loaded the iris data frame. Now I'll have to use sns.jointplot, and onto the x-axis I'll be mapping sepal.length, and onto the y-axis I'll have to map something. So onto the y-axis I'll be mapping petal.length. And that is pretty much it. I'd actually have to give in the data as well. So the data on which I'm making this is the iris data set. Then here I'll have plt.show, and when I hit on run, so seems like we have an error over here. So sepal length, so L has to be capital. Let me make it capital L. And you would see that I have successfully created this joint plot where I have the scatter plot in the center and I have corresponding histogram for sepal length on the top, corresponding histogram for petal length on the right side. And over here, if I want to change the color, that is also something which can be done, and we've already seen this throughout. So all I have to do is use this color attribute, and I have to give in a color for this. And if I like the olive color, that is what I'll be going ahead and mapping it onto this attribute. I'll add this color attribute and I'll have olive. And as you guys see, I have mapped the olive color for this joint plot. Now for this, if I want a regression line through the scatter plot and also through the histogram, I'd have to use this new attribute called as kind. And for this new attribute kind, I am assigning this value reg. So as you guys see, I have this regression line which is passing through the sepal length values and the petal length values, and also it is passing through both of these histograms. So here I'll have kind and I'll have the value reg set for this kind attribute. Let's wait for the result, and you would see that I have added a regression line which goes through the histogram and also goes through the scatter plot. Once I have done this, let's go ahead to the next geometry, which is a box plot. And to create a box plot, we'll just be using this box plot method, and we'll be creating this box plot on top of the churn data frame. So we'd have to load this data frame first. So this data frame tells us about the different features of a telecom company,
And on the basis of this features, we'd have to find out if the customer will churn out or will stick to the same company. So here we have the churn column and the tenure column. The churn column I'm mapping onto the x-axis, the tenure column I'm mapping onto the y-axis, and obviously I'm building this box plot on top of the churn data frame. One interesting attribute about a box plot is that box plot can be mostly used to understand how does a categorical value change along with a numerical value. So that is why here we have mapped this categorical column churn onto the x-axis and this numerical column tenure onto the y-axis. And we see that, so this what you see is the median value which we have already seen. So when it comes to people who do not churn out, it seems that those people who do not churn out, their median tenure or their tenure in general is longer than those people who actually churn out. So I would have to load this data frame first. I would have to store it in this churn object. So churn is equal to pd.read_csv, and inside this I'll have churn.csv, and then let me have a glance at the first 5 records of all of the columns, and these are all of the columns. And for all of these columns, I'd have to make a box plot between this tenure column which would go on the y-axis and this churn column which would go on the x-axis. SNS.boxplot, and onto the x-axis I'd have to map obviously the tenure column. Onto the y-axis I am mapping the churn column. Then I'd have to use the data which is churn, and I'd have to show it out. So I'll have plt.show. So I've actually made a mistake over here. So tenure will go onto the y-axis and churn will go onto the x-axis. Now if we get this box plot, and we've already seen the inference, it seems that those people who do not churn out, their tenure seems to be longer than those people who actually churn out. And now this time we'll be creating a box plot between the internet service column and the monthly charges column. So we have the monthly charges column onto the y-axis and the internet service column onto the x-axis. And we've got these 3 different categories in this internet service column. So the internet service can either be DSL, fiber optic. So this no means that the people don't have or the people haven't subscribed to internet service. And it is very clear that those people whose internet service is fiber optic, they would have the maximum monthly charges. Similarly, those people who do not have internet service, their monthly charges is minimum. So when you compare this box to these 2 boxes, it is very evident that people who don't have internet service, their monthly charges are very, very low. I'll copy the same command over here, but on the y-axis, I'll have monthly charges, and on the x-axis, I'll have internet service, and this is the resultant box plot which we'll be getting. Now we'll go ahead and make another box plot between the contract column and the tenure column. Tenure column would go onto the y-axis, contract column would go onto the x-axis, and we can have 3 different types of contracts: month-to-month contract, 1-year contract, and a 2-year contract. And if we look at the tenure of it, so let's actually look at the median values of the tenures. So it seems that if the contract is of month to month, then the median tenure is the lowest. Similarly, if the contract is of 2 years, then the median tenure is the maximum. And we are setting a palette over here. So again, we can have different palettes. So the palette which I'm using is equal to set1. Onto the y-axis, I'll be mapping the tenure column. Onto the x-axis, I'll have the contract column. Let me write in contract column over here. And the data will obviously be the churn data set. And what I'd have to do is I'd have to use a palette, and the palette which I am using is equal to set1. And this is the resultant box plot. Now you see these boundary lines over here. if we want to change the thickness of these boundary lines, we can do that with the help of this line width attribute. So here I am setting the line width to be equal to 3. If you compare this particular box plot with the earlier box plot, it is very clear that the thickness has increased. The same code, I'll actually have tenure and contract over here. Onto the x-axis, I'll be needing contract. And I will use this line width and I'll set this to be equal to 3. And you would see that the line width has increased substantially. And after this, let's say if I want to change the order of how these boxes are present. So here, initially the boxes were present in the order of month to month, 1 year, 2 year. But instead of this order, let's say if I want 2 year first, followed by month to month, then after that, if I want 1 year, then I can use this attribute called as order, and inside this I'll pass in the list which will comprise of the order in which I would want these boxes to be present. So here I'll remove the line width, and instead of line width I'll use this attribute called as order, and first I'll have 2 year. After that I'll have month to month. Then finally I'll have the last box which will be 1 year. And you would see that I have changed the sequence. Now, if you want to add colors on the basis of a column, which we've been doing throughout, that can be done with the help of this hue attribute. And I want the color of all of these boxes to be determined by this payment method column. So here I am mapping this payment method column onto this hue aesthetic. And as you guys see, I have these 4 different payment methods. I have electronic check, mail check, bank transfer, and credit card. So electronic check. So this particular box, or wherever all of these boxes where the color of the box is purple or dark blue, that denotes electronic check. Then we have the box where the color is orange, that would denote mail check. And if the color of the box is green, that would denote bank transfer. And if the color of the box is red, that would denote credit card. So here I'll add this attribute called as hue, and I want the hue to be determined with the help of this payment method column. And you would see that I have 4 of these over here. So I have 4 boxes with respect to these 3 different categories.
So we have an interesting case study now. We have a IPL data set, and we'll be thoroughly analyzing this IPL data set with the help of the Pandas library and the visualization library, which is Matplotlib. So our first task would be to import all of the required libraries. So what we'll do is we'll go ahead and type in import pandas as PD. PD is the alias for pandas. Then we'll also go ahead and import the pyplot submodule from the matplotlib module. So here we'll have from matplotlib import pyplot as plt, and plt is the alias which we are giving for pyplot. And finally, we'll also include one more visualization library, which is Seaborn, and that is why we will have import Seaborn as SNS. Let me just go ahead and click on run, and let's wait for all of these libraries to be loaded. So it'll take a bit of time. So these are the 3 important libraries which we'll be needing to thoroughly analyze this data set. So now that we have loaded all of the required libraries, we would have to load the CSV file. And we have the CSV file called as matches.csv, which has all of the details of the different IPL matches. And we already know that to load a CSV file, we would need to use pd.read_csv. And inside this, we will give in the name of the file, which is matches.csv. And that we will store in this object called as IPL. So now that we have loaded this matches.csv file and we have stored it into the IPL object, let me go ahead and have a glance at the head of this data frame. So I'll have IPL.head, and we also know that the head method gives us the first 5 records of any data frame. So if you see over here, I have 1, 2, 3, 4, and 5. So these are the 5 records, or the first 5 records from this IPL data frame. So let's just look at the different columns which are present in this data frame. We have the ID column, which would tell about the unique match ID. So here each record represents one unique match, or one match which was played between different teams. So here, as you see, the match ID is 1, and this match ID 1 represents that particular match in 2017 between Sunrisers Hyderabad and Royal Challengers Bangalore. Then we have match ID 2, which would represent the match between Rising Pune Supergiants and Mumbai Indians. So this is how, or this is what the ID column tells you. Then we have the season column, which would tell you in which season or in which year this match had been organized or this match was played. So as you see over here, the first 5 records, these represent the matches which were played in the year 2017. Then you have the city over here, in which city was the match played in. So this match between Sunrisers Hyderabad and Royal Challengers Bangalore was played in Hyderabad. Then you have the date column over here, and the date tells you the exact date on which this particular match was played. So this match was played on, so you have 2017-04-05. So this would be 5th of April 2017. So team 1, team 2, this just indicates who were the, or what were the 2 teams playing against each other. Then you have the toss winner. Which team had won the toss? So between these 2 teams, Royal Challengers had won the toss. And after winning the toss, what did the team decide to do? So here you have the toss decision column. And this column tells you that after winning the toss, Royal Challengers Bangalore had decided to field. Then you have the result column. So in result column, we have 3 categories, and those 3 categories we'll look at them later on. Then you have DL_applied. This DL_applied tells you if the Duckworth-Lewis method was applied or not. And Duckworth-Lewis method would obviously only be applied if there was rainfall. After that, we have the winner column, which tells us which team has won the match. So this match between Royal Challengers Bangalore and Sunrisers Hyderabad, this match was won by Sunrisers Hyderabad. Then you have win by runs and win by wickets. So this column over here tells us that since Sunrisers Hyderabad had batted first, they have won by 35 runs. Over here you have the win by wickets column. Now you'd have to understand this interesting thing over here. So if a team bats first and wins the match, then it will be winning by a certain number of runs. But on the other hand, if the team batting second wins the match, then it will be winning by a certain number of wickets. So here, since the team batting first has won the match, that is why you have a value in this column and you don't have a value in this particular column over here. Let me give another example to make you understand it better. So let's say the team batting first has scored 100 runs and the team batting second was all out on a score of 75. Then we would say that team batting first has won by a margin of 25 runs. On the other hand, let's say if team batting first has made 100 runs and team batting second has achieved that score by losing 2 wickets, then we'll say that the team batting second has won by 8 wickets. So that is what is meant by win by runs and win by wickets. So if a team batting first wins, then we'll have a value in this particular column. And similarly, if a team batting second wins, then we'll have a value in this particular column.
Then you have the player of the match column over here, which absolutely tells you who was the man of the match or player of the match for that particular game. And in this game between Sunrisers Hyderabad and Royal Challengers Bangalore, Yuvraj Singh, the sixer man who hit sixes on a well, was the man of the match. Then you have the venue over here. And this match was played at Rajiv Gandhi International Stadium, Tuple. Well, I've actually seen an IPL match over there, so it's a pretty stadium. Then you have 3 columns which would tell you who is the first umpire, the second umpire, and the third umpire. So this is all about this particular data set. So now that we have comprehensively looked at this data set, let me see how many rows and how many columns are present in this data frame. And for that purpose, I will have the shape method. So I'll write down IPL.shape, and this will tell me the number of rows and number of columns present in this data frame. And as you see over here, I have 636, 18, which would mean that there are 636 records and 18 columns. And the 636 records also tell you that there were 636 unique matches played. Then I would want to know the frequency of most man of the match awards. So here, this column which you see, player of match, I would want to know which player has won how many man of the match awards. And since this is a categorical column, we have seen that if you would want to find out the frequency of a categorical column, we would have to use the value counts method, and that is what we'll be doing over here. So what I'll do is I will give in the name of the data frame, which is IPL, and inside parenthesis I will give in the name of the column, which is player of match. After that I will give in the dot operator, and then finally I will use value counts method, and this will give me the frequency. So here, as you see, Chris Gayle, the universe boss, has the most number of man of the match awards, which is 18. Then you have Yusuf Pathan, who has got 16 man of the match awards. After that, you've got AB de Villiers, who's got 15 man of the match awards, and you have David Warner, who's got 15 man of the match awards, and so on. Now, from this list, I would want to get only the top 10 players with most man of the match awards. So here the entire command will be the same. It's just that I will give in another parenthesis over here, and inside the parenthesis I will give in 0:10, which will give me the 10 players with most man of the match awards. So this, what we are doing is just a subset of this particular result. So here, as you see, we have Chris Gayle, Yusuf Pathan, AB de Villiers, David Warner, Rohit Sharma, Suresh Raina, Gautam Gambhir, MS Dhoni, Michael Hussey, and Ajinkya Rahane. So these are the top 10 players with most man of the match awards. And similarly, instead of the top 10, if I would want only the top 5 players with most man of the match awards, in parenthesis, I will give in 0:5. And here, as you see, these are the top 5 players with most man of the match awards. Going ahead, what I'd want to do is, I would want to make a bar plot for the top 5 players with most man of the match awards. And if I would want to make a bar plot, obviously I would have to use the Matplotlib library. So I have already imported the pyplot submodule from the Matplotlib library and have given it an alias of plt. Now what I'll do is I will write plt.figure, which would help me to set a figure size. So plt.figure, inside this I will use this parameter called as figure size, and I will set the figure size to be equal to 8,5, which is just the dimension of the plot which I'll be displaying right now. Then we have also seen that to make a bar plot, we would have to use plt.bar. So I'll write down plt.bar, and inside this we have seen that the first parameter needs to be a categorical value and the second parameter needs to be a numerical value. So here the categorical value will be the name of the player or all of the names of the players. So here, as you see, we've got the names of the players and also we've got the values of, or the result or the number of man of the match awards of these players. So to get the categories or the names, we would have to use the keys method. So here, as you see, this is the command which will give me this entire result, which is what I have over here. So this is the same thing. It's just that after this, I'll use dot operator. Then I will use the keys method and only get the names out of this. And that is what I'm showing you out above here. So as you see, when I use the keys method, this will only give me the names of the players. And similarly, if I would want only the values, I will just use this. That's it. So this command will give me only the values. So I have taken the categories, I have taken the values as well. Now after that, I would want to set a color to these bars. So here I have given color as equal to G, which will give a green color to all of these bars. And to finally show out the image or to plot the image, I would have to use plt.show over here. So as you see, we have successfully made a bar plot which would tell us or give an interpretation of the top 5 players who have received the most number of man of the match awards. And you see there's not much of a difference over here. So you have Chris Gayle leading, then you have Yusuf Pathan, AB de Villiers, David Warner and Rohit Sharma. Now we have the result column over here. So I would want to know the frequency or the different categories of this result column. And if I would want to know the frequency, again what we have to do is use the value counts method. So as you see over here, IPL is the name of the data frame and inside parenthesis I will give in the name of the column. So here the name of the column is result and I will use the value counts method when I click on run. As you see over here, I have 3 categories: normal, tie and no result. Normal here would mean that the match has progressed normally, which would mean that one team has won the match and another team has lost the match. Then you have tie. Tie would mean that both the teams have scored the same number of runs. Then you have no result. No result would mean that either the match was called off or it was washed off because rain or some other disturbance. So these are the 3 different categories which we have. And out of all of these matches, most of the matches have been done normally. And there were 7 instances where there was a tie. So out of all of these seasons, so I guess there would be 8 or 9 seasons. So out of the 636 matches, there were only 7 instances where there was a tie. So this is a very interesting insight over here which we have found out. Going ahead, I would want to find out which team has won the most number of tosses. So here, let me just show you this particular column, toss winner. So this toss winner column would tell us which team has won the toss. Now what I'm doing is I would want to know the value counts or the frequency of different categories of this toss winner column. And here, as you see, Mumbai Indians seem to be very lucky. So they have won the most number of tosses. So Mumbai Indians has won 85 tosses. Then we have Kolkata Knight Riders close behind with 78. Then you have Delhi Daredevils with 72. After that you have RCB with 70 and so on. Now I would want to know what team or how many teams have won the match batting first. So what is the percentage distribution of a team batting first and winning the match? And I've already told you guys that if a team wins the match by batting first, then we will have a value in this particular column. So it cannot be a 0. So if you have a 0 in this column over here, it would mean that the team batting first has lost the match. But I don't want that. What I want is, I would want all of those records where the team batting first has won the match, which means I would want all of the records where the value is not equal to 0. And that is what I'll be extracting from this entire data frame. So here, as you see, from this IPL data frame, from the win by runs column, I am extracting only those records where win by runs is not equal to 0. And I will store all of those records in this new object called as batting first. Now that this is done, I will have a glance at the top 5 records of this. So I'll have batting first dot head. And here, as you see, I have the list of all of those records where the teams have won batting first. And also, if you look at this particular column over here, I don't have a 0. We have some values. So here, between this match of Sunrisers Hyderabad and Royal Challengers Bangalore, we have already looked at it. So Sunrisers Hyderabad has won the match with 13 runs. Then between the match of Royal Challengers Bangalore and Delhi Daredevils, RCB has won the match by 15 runs. And this seems to be a huge margin over here. So this is the match between Delhi Daredevils and Rising Pune Super Giants. And Delhi Daredevils has won the match by 97 runs. So going ahead, I'd want to do more of visualization. And I'd want to see the distribution of this particular column, win by runs column, for all the teams who have won the match by batting first. And since this is a numerical column over here, I will obviously be making a histogram. So first, to make this histogram, I'll have to use plt.figure. I'm setting a figure size over here, and the dimension I'm setting it to be 7x7. Then to make a histogram, we already know that we will have to use plt.hist. And inside this, I will just directly pass in the column for which I'd want to make the histogram. So here it will be batting first, which is the name of the object, and I'll give in parenthesis and given the name of the column, which is win by runs. And I'll have plt.show. So here this is interesting, as you see over here. So on the x-axis, we have the number of runs by which the team has won. On the y-axis, we have the number of instances this has happened. So let's say if I take this over here. So this bin tells us that there have been around 100 matches where teams batting first have won in the range of 0 to 20 runs. Similarly, if I look at this particular bin, so this particular bin would tell me that there have been around 80 matches where teams batting first have won in the range of maybe 15 to around 30. Similarly, if I look at this particular bin over here, this would tell me that there would be around 18 matches where teams batting first have won in the range of maybe 75 to 85. And similarly, there would be very few matches. There would be only 3 or 4 matches where teams batting first have won by more than 120 runs. So all of this is some sort of insights which we were only able to find out after building this beautiful histogram. And also, if you would want to add a title, that is something which we can absolutely do. So here I'll just write down plt.title and I will give this the title of distribution of runs. So here, as you see, I have given this title, and if I would want to give an x-axis label, I'll write down plt.xLabel and I'll just write down runs over here. And as you see, the X label is runs and the title is distribution of runs. So after this, I'd want to find out the number of wins with respect to each team after batting first. So when I say this, what I basically mean is I have the winner column over here. So I just want to get the frequency of this winner column. So I want to know which team has won how many times after batting first. Let me just scroll down over here. So batting first, and in batting first, I am selecting the winner column and I'd want the frequency of this. So here, as you see, Mumbai Indians has won the most number of times after deciding to bat first. So Mumbai Indians has won 47 times after deciding to bat first. Then closely following behind, you have Chennai Super Kings with 46 wins. Then as you see, you have a huge difference over here between Kings 11 Punjab and Chennai Super Kings. So the top two teams, it seems that they win a lot after batting first. But then you see this disparity over here. Kings 11 Punjab, the third team to win the most number of times. There's a difference of 14 times over here, or 14 wins over here. And that's a huge disparity. Now, what I want to do is, I want to make a bar plot for the top 3 teams with most wins after batting first. And again, we'll do the same steps. First, I'd have to set the figure size. So I'll have plt.figure. Inside this, I will use this parameter fig size and I'll set the dimensions to be equal to 7,7. Then I'll have plt.bar, and we already know that this takes in 2 parameters. So the first parameter is basically all of the categories, and the second parameter is the values for all of these categories. So to get the categories, which are Mumbai Indians, Chennai Super Kings and Kings 11 Punjab, so this command will be the same over here. This entire thing will be the same. It's just that after that I will give in the keys method, and this entire thing I will pass in a list. So I've got the categories. After getting the categories, I would need the values. So it'll be batting first, winner value counts 0 to 3. And I'm setting colors for, or I'm basically setting 3 different colors for all of these different bars. So I am setting blue color for Mumbai Indians, yellow color for Chennai Super Kings, and orange color for Kings 11 Punjab. And as you see over here, this is what I have. I have a beautiful representation of the top 3 teams winning most number of times after batting first. So here, as you see, there's not much of a difference. But here, this is a huge gap over here between Kings 11 Punjab and Chennai Super Kings. Going ahead, I'd want to make a pie chart for the distribution of wins. So to make a pie chart, I'd have to use plt.pie. And also before that, again, I just have to set a random figure size. So by default, I'm setting the figure size to be equal to 7,7. And since I would want to make a pie chart, I will have plt.pie and over here. So the difference between, as you see over here, between making a bar plot and a pie chart is the first parameter we will give in the numerical entities, and the second parameter we will give in the categorical values. So the first parameter will have batting first winner dot value counts. The second parameter is batting first winner value counts dot keys. Now that we have given this, I will have auto PCT is equal to %0.1f which would help me to show the percentages on top of the pie chart which I have created. So as you see over here, with 16.4% wins, when compared to other teams, you have Mumbai Indians leading. So you have the biggest slice over here. Then you have Chennai Super Kings with 16% wins. After that, you have Kings 11 Punjab with 11.1%. Then you have Kolkata Knight Riders with 10.8% and so on. Now over here, let's say if I don't want these percentages, what I can do is I will just go ahead and remove out this parameter over here. Now, as you see, if I have removed the auto PCT parameter, I will not have anything on top of this pie chart. So till now we have analyzed how teams have performed after batting first. Now, similarly, I would want to look at those teams who have performed well after batting second. Now, for this, we have already seen this. So, if a team has won the match after batting second, you will have a value in this particular column. Or in other words, we will extract all of those records from this entire data frame where the value in this column is not equal to 0. Let me scroll down. And here, as you see, from the IPL data frame, I am extracting only those records where the value in win by wickets column is not equal to 0. And I will store all of those records in a new object called as batting second. Now, I will have a glance at the first 5 records of this new object which we have created. So, as you see over here, if I show you this particular column, you would see that we definitely have a value over here. And if you look at win by runs, you have only zeros present. And that is because if a team batting second has won the match, you will have a value over here and not over here. Now, as we had done with teams batting first, similarly, I would want to understand the distribution of this particular column. That is, the distribution of how teams have won with respect to number of wickets. And since this is a numerical column, I'll be making a histogram. First, I will go ahead and set out the figure size. I will have plt.figure. Inside this, I am using the parameter fig size and I am using a default size of 7,7. Going ahead, I will use plt.hist and inside this, I will just pass in the win by wickets column and I am setting the number of wins to be equal to 30. Then I just go ahead and show you guys the plot. So we have an interesting histogram over here. So what this tells you is there have been around 70 instances or 70 matches where the team batting second has won with 7 wickets in hand. And if I look at this, so this bin over here tells me that there have been around 15 matches where team batting second has won the match with 3 wickets in hand. If you look at these two, 1 and 2, so there have been maybe let's say only 3 or 4 matches where teams batting second have won with 1 wicket or 2 wickets in hand. So it seems that if a team batting second has won the match, then most probably it would not have lost a lot of wickets, right? So here, as you see, you have this peak over here. So this is in the shape of a bell curve and the peak is over here at 6 and 7. So you have this peak over here. So 4, 5, 6, 7, 8. So this is the normal distribution, or this is how normally the teams lose wickets. So normally it seems that the team batting second, if it has won the match, then it would lose around 4 to 8 wickets. Let's say if it loses more than 8 wickets, then there are very few chances for the team to win the match after that. And also if you look at this, there have been very few instances where the team has won with all of the 10 wickets remaining. So here maybe you have only exactly 10 matches. So that would have been exactly 10 matches where the team batting second has not even lost a single wicket and has gone on to decimate their opponent. So this again is an interesting analysis over here. Now after this, again I would want to make a bar plot for all of the teams who have won their matches batting second. So for this, let me just find out which of the teams have performed well batting second. So here from the batting second object, I am choosing the winner column and I'm using value counts method. So it seems that Kolkata Knight Riders have performed really well batting second. So Kolkata Knight Riders have won 46 times batting second. Then close behind you have Mumbai Indians who have won 44 matches, batting second. Then you have Royal Challengers Bangalore, also close behind, who have 142 matches. Then you have Delhi Daredevils, who have 141 matches after batting second. Now, similarly, since I would want to make a bar plot for this, first I'll have plt.figure, fig size is 7,7. Then I'll have plt.bar over here. Over here, the first parameter, I would have to set, or I would have to choose the top 3 categories, which are Kolkata Knight Riders, Mumbai Indians, and Royal Challengers Bangalore. So here what I'll do is I'll have 0 to 3 dot keys, since I would want only the categories. Then since I would want the values, this is what I'll give over here. Then going ahead, I will give in colors. So to Kolkata Knight Riders, I am assigning blue color. For Mumbai Indians, I am setting green, and for Royal Challengers Bangalore, I am setting orange. Let me actually change these colors. So let me give in a purple color for Kolkata Knight Riders. Then I have, who do I have next? I have Mumbai Indians. For Mumbai Indians, I will give in a blue color. Then I have Royal Challengers Bangalore, and for RCB I will give in a red color over here, so that this represents their jersey color. And as you see, I have changed the color. So Kolkata Knight Riders, since their jersey color is purple, I've given it a purple color, and Mumbai Indians, since they have a blue color, I've given them a blue color. Then we have RCB, who have a red color, and that is what I've given them. Now, as we had done for teams batting second, I had made a pie chart to look at the distribution of the percentage of wins across different teams, and that is what I'd want to know with respect to teams batting second as well. So again, plt.figure, fig size will be equal to 7,7. Then I will have plt.py. Over here, the first parameter will be batting second winner dot value counts. So again, first I'm giving in a numerical value, then I'm giving in the categories. Again, auto PCT is equal to %0.1 F %%, which will give me the percentage values on top of the pie chart. Here, as you see, Kolkata Knight Riders with the maximum percentage of wins batting second, which is 13.6. Then you have Mumbai Indians close behind with 13%. Then you have RCB with 12.4%. and so on. So these were some different visualizations which we had performed. Going ahead, I would want to look at the number of matches played in each season. So in the IPL data frame, we had the season column, and since I would want the frequency count of that, I'll just use value counts after that. IPL season dot value counts. And here, as you see, in 2013, we had the most number of matches played, which were 76. Then in 2012, we had 74 matches. In 2011, we had 73 matches. And over here, in 2010, 14, and 16, we had exactly 60 matches played. So this is something which again is interesting. So most number of matches were played in 2013, and the least number of matches were played in 2009. Then I'd want to know which city has hosted the most number of matches. So IPL city dot value counts will give me the frequency count of this, and Mumbai hands down has won this. So Mumbai has hosted the most number of IPL matches, which are 85. Then close behind you have Bangalore, which has hosted 66 IPL matches. After that, you have Kolkata with 61. And now, I would want to do something interesting again. I want to know what is the percentage of a team winning if a team has already won the toss. So what I'm going to do over here is, I have two columns over here, toss winner and winner. So if the value in this column is equal to the value in this column, it would mean that the team which has won the toss also has won the match. So if I compare this and this, the result would be no, because Royal Challengers has won the toss but has lost the match. Then if I compare this and this, here you would see that Rising Pune Super Giants has won the toss and also has won the match. So this again is interesting over here. So I'll be importing the Numpy library, import Numpy as NP. Then I will use np.sum, and inside this I will set toss winner is equal to winner. And this will give me 325. So it means that out of the 636 matches, 325 times, the team which has won the toss has also won the match. So what I'll do is, I'll have 325 divided by 636, which tells me that 51% of the times a team winning the toss also wins the match. So this actually means that, there's not much of an effect of the toss. 50% is actually, well, it's 50-50, isn't it? It's either heads or it's tails. So toss maybe doesn't really affect the match that much. Now after this, we have another data frame called as deliveries, or another CSV file called as deliveries, which gives us ball by ball information of all of the matches in the above CSV file. So let me go ahead and read this file. I'll have pd.read_csv. Here I am giving in the name of the file, and this I will store in this object called as deliveries. So now that I have stored this, let me go ahead and have a glance at some of the records of this data frame. So here, as you see, I have ball by ball information. So here match ID. So in the previous data frame, we had looked at the match ID for Sunrisers Hyderabad and Royal Challengers Bangalore was 1. And this represents the same match. So for this particular match, Sunrisers Hyderabad and Royal Challengers Bangalore, for which the match ID is equal to 1, here these 5 records represent the first innings, which is Sunrisers Hyderabad's innings. And here, as you see, the first 5 balls, David Warner is on strike. So you have a ball by ball information of what is actually happening over here. And I'd want to know how many unique match IDs are there. So unique match IDs will tell me the unique number of matches. So deliveries match ID dot unique. So this, as you see over here, the values are from 1 to 636, which tells me that there are 636 unique matches. Now, out of all of these unique matches, I would want to extract only those records where the match ID is equal to 1, which means that I just want to analyze this particular match between Sunrisers Hyderabad and Royal Challengers Bangalore. So deliveries of match ID is double equal to 1, and this I will store in an object called as match 1. And let me have a glance at the first 5 records of this data frame, and this we have already seen. And I'd want to have a glance at the shape of this data frame. So the shape of this data frame tells me that it has 248 records and 21 columns. Now let's understand this 248 records. What does this 248 mean? Well, a T20 match has 20 overs per side. And 20 overs per side would mean 120 balls. So 120 balls plus 120 balls would be 240 in total. So in the entire match, 8 extras were bowled. So counting both of the teams. So because you have 240 legal deliveries, so those 8 extra deliveries were either wides, no balls, byes, or something else. So this is also something which you were able to understand by using the shape method. And now, from this first match, I just want to analyze the first innings. So I'll set the inning to be equal to 1. And since the first inning is by SRH, that I would want to store in this object called as SRH. And I'd want to know the frequency of the different types of runs scored by SRH batsmen. So SRH batsman runs dot value counts. So this would tell me that 57 singles were taken. Then this tells us that there were 32 dot balls. We have 17 fours, we have 9 sixes, there were 9 couples as well, and there was 1 triple taken. Now I do want to know what were the different kinds of dismissals. So SRH dismissal kind dot value counts. So here it seems that only 4 wickets were fallen of the SRH team, and 3 of those were caught and 1 was bowled. And now we'll do the similar sort of analysis for RCB as well. So for RCB, what I'm going to do over here is, since the inning is equal to 2, match 1 inning is equal to 2, and this I will store in this object called as RCB. Now once that is done, I would want to know the different number of runs scored by the RCB batsman. So here, as you see, there are a lot of dot balls for RCB. When you compare the number of dot balls of RCB and SRH, this tells you the story of the match. So in SRH innings, there were only 32 dot balls. But in RCB's innings, there were 49 dot balls. And you have 44 singles, you have 15 fours, you have 8 sixes, and you have 7 twos. And I'd want to know the different kinds of dismissals. So RCB dismissal kind dot value counts. So 6-2-2, which would mean that all of the 10 wickets of RCB have been fallen. And out of those 10 wickets, 6 of them have been caught. 2 of them have been bowled, and there were 2 runouts.
So here we have the FIFA 20 dataset, and we'll be performing exploratory data analysis on top of this dataset. And now we'd have to import all of the required libraries. So we are importing Pandas for data manipulation, obviously. Then we have Matplotlib and Seaborn. So Matplotlib is a library which is used for data visualization. Seaborn is also a library which is used for data visualization. So Seaborn you can consider as it's an extension of Matplotlib. Extension in the sense that Seaborn is built on top of Matplotlib. So these are the 3 libraries which I would need, and what I'll do is I'll actually restart the kernel so that you're not able to see the output initially. So for you, it will be much more easier to understand. Now I'll hit on run, and let's wait for these libraries to load. All right, so we have loaded the required libraries. Then going ahead, we have this file called as players20.csv. So this is a file which I have already loaded in Jupyter Notebook. And to read a CSV file, we would need this method called as read_csv, and this method read_csv is a part of the Pandas library. So here, since I have loaded Pandas, so I'll write down pd.read_csv, and inside this I will give in the name of the file, which is players20.csv, and I will go ahead and store it in this object called as FIFA, and I'll just hit on run. Now, if I would want to have a glance at the first 5 records which are there, so I need to use the head method. So by default, this head method gives you the first 5 records which are there in this data frame. So FIFA.head, and here you would see that you have all of the different columns. So you have the FIFA ID, you have the player URL. So if you'd, this is a column which just gives you the home page or the description of this player over here. Then you have the short name of this player. So here you have El Messi, obviously Messi, long name is Lionel Messi. You have Cristiano Ronaldo, and you have Cristiano Ronaldo's long name. You have Neymar, you have Oblak, you have Eden Hazard. And here this column obviously tells you the age of this person. Here you have the date of birth, then you have the height in centimeters of this player and the weight in kilograms of this player. Then you have the nationality, So Messi is obviously from Argentina. Ronaldo, we all know, is from Portugal. Neymar is from Brazil. Eden Hazard is from Belgium. And these are the clubs for which these folks play. Cristiano Ronaldo, he plays for Juventus. Messi plays for Barcelona. Neymar plays for PSG. Eden Hazard plays for Real Madrid. Then you've got all of these different stats over here. So for now, we'll just leave out those stats. So let's actually see how many columns are present in this particular data frame right now. So what we'll do is, I will start a for loop and I would want to know all of the columns which are present. So what I'll write down is for call in FIFA.columns, and I will print out each of the column which is present in this entire data frame. So for call in FIFA.column, so what will happen is it will iterate from the first column. So it will start from this first column and it will go to the last column over here, and we are printing all of the columns which are present over here. So for call in FIFA.columns, print of call, when I hit on run, you would see that these are all of the columns which are present. You have FIFA ID, player URL, short name, long name, age, date of birth, height in centimeters, weight in kg, and so on. So you have a lot of columns over here. Now I'd want to know how many records are there and how many columns are actually present in this data frame. So for that purpose, I will use this shape method. I'll write down FIFA.shape and I will hit on run. And you would see that there are 18,278 records and 104 columns. So this is actually a huge data set. So I mean, for performing a simple case study. So here 18,278 records would mean that you have a list of 18,278 players in this entire data frame, and 104 columns are just the different features with all of these different players. So we've looked at the shape, and there is this column called as nationality in our data frame. So here, if you go up, you would see that there's this nationality column, and I would want to see how many players belong to which particular country over here. So since nationality is a categorical column, and if I'd want to understand more about a categorical column, I can use the value counts method. The value counts method gives me a frequency count of the different categories which are present. So what I'll do over here is, first I'll give in the name of the data frame, which is FIFA. Then I'll, inside the parenthesis, I'll give in the name of the column, which is nationality. Then I'll use the dot operator and use the value counts method. And when I run this, this is what I get. So you see that in this particular data frame, most of the players are from England. So you have 1,667 players from England. Then you have 1,216 players from Germany, and you have 1,035 players from Spain. Then you have 984 players from France, then followed by 886 players in Argentina. So this basically tells you that in this data set, you have a lot of players from England, and that could also be a reason because you have you have more number of clubs participating in the English Premier League. So you also have all of these relegation zones. So you have tier 1 clubs, you have tier 2 clubs, you have tier 3 clubs. So maybe this data frame comprises of all of the players belonging to tier 1, tier 2, as well as tier 3. And that could tell you why, why there are more number of players belonging to England. Then, if I would, so let's say from this entire result, if I would only want to have a glance at the first 10 records or the top 10 countries where most of the players belong to, what I'll do is I'll write down FIFA nationality dot value counts. And again, I'll just give in 0 to 10 inside this. And when I hit on run, you would see that So most of the players belong to these 10 countries over here. Again, at the top, you have England, Germany, and Spain. Then let's say instead of top 10, if I would only want to have a glance at the top 5, so over here, I'll write down 0:5. And you would see that I have these 5 countries. I have England, Germany, Spain, France, and Argentina. Now, I would want to make a bar plot for these top 5 countries where most of the players come from. So, if I would want to make a bar plot, I would need to use this library called as Matplotlib, and we have seen that we have imported the submodule which is pyplot, and we have given it an alias of plt. So here, first I need to set the figure size. So as you see, I'm setting the figure size over here, plt dot figure, and inside this fig size is a parameter inside this method, and using this parameter I set the dimensions of the image. And as you see, I set the dimensions to be equal to 8,5. Now once I set the dimensions, then I go ahead and create the bar plot using plt dot bar. And when I write down plt.bar, you have all of these different parameters over here. So when we are creating a bar plot, the first parameter which we give inside it should be the categorical values. Now, after that, what we do is we give in the numerical entries over here. So what we do is first, if we say categorical entries, these are the categorical values over here. Now, if I only use dot value counts method, that gives me these categorical values along with these numerical values. But what if I only want the categorical values, only the names of the countries? So in that case, what I can do is I can use the keys method. So here, as you see, till here, the command is the same. FIFA nationality dot value count 0 to 5. Then I am using the dot keys method over here, and I will hit on run, and you would see that I am able to extract the names of these top 5 countries without the values. And since I need to pass in categories as my first parameter, this code is what I'm passing in as the first parameter over here. Then going ahead, the next value is the same command without the keys method. Then going ahead, I have another parameter called as color, and I set the color to be equal to green. So G is, again, it's just a short form for the green color. So I have first passed in the categorical entries, then I've passed in the numerical entries, then I have passed in the color over here. Then I hit on run. So here you see that this is the bar plot which we have created, and it's pretty evident, isn't it? This is what we saw in the list as well. So most of the players, they are from England. Then you have around 1,200 odd players from Germany. Then you have 1,000 odd players from Spain. Then you have France and Argentina falling behind. So right now we have looked at the nationality column. Now we will go ahead and do some more analysis. So we have the wage in euro column. Now I'll just show you if we can. So now as you see, like some of the columns wouldn't be listed over here because this is a huge data frame, but we have this column called as wage underscore euro. So this tells me the salary of these players in euros, and I'd want to see, I'd actually want to see over here which player gets, what is the salary of some of these players. So what I'd want to do is from the entire FIFA data frame, I'd want to extract only 2 columns. The first column would be the short name of the player, and the second column would be the wage in euro. And this I will go ahead and store in this object called as player salary. Now that I have created this sub data frame from my original data frame, then I would want to have a glance at the first 5 records of this. So here player salary dot head, I will click on run. Here you see that in the first column I have the short name of the player, and in the second column I have the salary of the player. And here, as you see, Lionel Messi, his wage is, you have 65,000 euros. Then you have Ronaldo with 405,000 euros. Neymar is at 290,000 euros. Oblak is 125,000 euros. And Eden Hazard is at 470,000 euros. So I'm not sure if these are the latest salaries which these players get, but according to this particular data frame, it would seem that Eden Hazard and Lionel Messi actually get more salary than Cristiano Ronaldo. And now, what we will do is I'd want to see who is the highest paid football player. So from this data frame, from this sub data frame, what I'd want to do is I would want to sort this with respect to the wage column. So what I'll do is I'll write down player salary dot sort values, and inside this I have this parameter called as by. And what I'm doing is I'm just sorting this data frame with this column called as wage underscore euro, and I'll set ascending is equal to false because I would want that player with the highest salary at the top, and that is how it will proceed. And this again, I'm storing it back in the same object called as player salary, and I'll go ahead and hit on run. Now I will have a glance at the first few records of this. So when I say player salary dot head, so obviously as you see over here, Lionel Messi is the highest paid football player at 565,000 euros. Then you have Eden Hazard at 470,000 euros, Ronaldo at 405,000. Kevin De Bruyne at 370,000. You have Griezmann at 370,000 euros. So quite an interesting analysis, isn't it? So again, we will do the same thing. We will make a bar plot for these top 5 football players with the highest salaries. And since we have these categorical entries over here, we would have to make a bar plot. So you have to understand why we're using a bar plot. So normally whenever we do want to understand the distribution of a categorical entity, that is when we go ahead and make a bar plot. So here what we are doing is first the same thing, we will set the figure size. This time we are creating a bar plot for the players with highest salaries. Here, as you see, first I am setting the figure size. So I'll write down plt.figure. Inside this, I'm setting the figure size using this parameter called as fig size. And I given these dimensions. So the dimensions are 8, 5. 8, 5, 8 is the width, 5 is the height. So I've given the dimensions of the figure. Now, after I set the dimensions of the figure, I can just go ahead and create a bar plot. So to create a bar plot, I'd have to write down plt.bar. Inside this, so in a bar plot, always remember that the first parameter which you given has to be the categorical entries. The second parameter which you given has to be the numerical entries. So here, the first parameter, since it has to be capital, it has to be categorical. What I do is I would have to, so we have a categorical column, we have a numerical column. So obviously it is the names of the players which will be passing in over here. So this basically is your x-axis. So on the x-axis, we would need the names of the players. So I'll extract this particular column. So this short name column is from player salary data frame. So I'll write down player salary, and I given the name of the column, which is short name. And obviously I'd want only the top 5 records. So I'll give in 0 to 5 inside this. Then I will go ahead and in the next parameter, as you see, I have wage in euro. So again, since it has to be numerical, this time I'm extracting the wage in euro column, and I'll go ahead and set the color over here. So color, as you see, is equal to red. Then I will go ahead and plot it out. I will hit on run. And as you see, this is the result which we get. So on the x-axis, we have the names of the players, and on the y-axis, we have the salaries. So Lionel Messi obviously is leading the chart. Then you have Eden Hazard, Cristiano Ronaldo, Kevin De Bruyne, and Annie Griezmann. Now let's say if I would want different colors for all of these different bars over here. So that is something which we can also do. Now let's say instead of just keeping this as red, if I would want different colors, so what I'll do is I'll pass in a list of colors over here. So for Lionel Messi, let's say I give in blue color. Then for, let me just keep it small b. So for Lionel Messi, I'm keeping blue color. For Eden Hazard, I'll give green color. Then for Cristiano Ronaldo, maybe I'll give in red color. Then for Kevin De Bruyne, I'll give, let's make it pink. And finally for Griezmann, let's keep it, let's say, orange. And let's hit run. Seems like we have an error over here. The spelling which I've given is incorrect, so let me just keep pink and I'll hit on run, and as you see, this is the result which we get. So we can change the colors which are there in all of these bars as well. And now what I'd want to do is I'd want to do a simple analysis for the players who belong to Germany. So what I'm doing is, so let's say if I, from this FIFA data frame, if I set the nationality is equal to Germany and I hit on run, I get a bunch of true and false values. So when you have these bunch of true and false values, what does this actually mean? So if you have a false over here, this means that in that particular record, the nationality of the player is not equal to Germany. And if it is actually equal to true, then it would mean that the nationality of the player is Germany. So what I'd want to do is, from this list, I would want to extract all of those records where the value is actually true. So I will take this command and I will paste it again inside the FIFA data frame, and I will store it in this object called as Germany, and then I'll print it out. So I'll write down Germany.head. And if I would want to have a glance at the first 10 records of it, so Germany.head, inside parenthesis, I'll write down 10 and I will hit on run. And this is the result which we'll get over here. So as you see, this is the list of all of the players whose nationality is Germany. And now what I'd want to know is, I would want to see who is the tallest German player. So Germany.sort values, I will use by, and I would want to sort this with the height in centimeters column, and I will set ascending is equal to false. And I would only want to have a glance at the top 5 records, so I would want the top 5 tallest players of German nationality, and I'll hit on run over here. And as you see, so you have Aaron Seidel right now as the tallest player of German nationality. His height is 199 centimeters. Then you have Michael Esser, whose height is 198. You have Lars Unestal, whose height is 198 again. Then you have Dominic. Then you have Lucas. So these are the players with the, these are the tallest players. Then similarly, let's say if I would want to sort these German players according to their weight, I would want to see which player has the maximum weight. So again, this will be similar. I'd have to write down Germany.sort values, and I would have to sort it with respect to weight, and ascending, I'll set it to be false, and I'll hit on run. This time you would see that weight over here, so it's Lucas Woltowiak, who has the highest weight of 103 kgs. Then again you have Lars Unestal, whose weight is 103 kg. Then you have Ralph Farman. Then again you have Michael Lesser, and you have Nicholas Sule. And then I would want to see who is the highest paid German player. So this time I have the wage in euro column, and I am sorting it with respect to the wage in euro. Ascending is equal to false, and dot head method. Now if I show you these players, let's see what are these names. So Tony Cruz is the highest paid German player, and he plays for Real Madrid. So obviously if you're playing for Madrid or Barcelona, you would be paid a lot. Then you have Marc-Andre Stegen, and he plays for Barcelona, so he's the second highest player. And then you have Leroy Sané, who plays for Manchester City. Then you have LK, who plays for Manchester City as well. Then you have Thomas Müller, who plays for Bayern Munich. So top 5 players of German nationality who have the maximum wages. Now, again, what I want to do is I just want to make a simple data frame again. So I just want what I want is I would want 2 columns. The first column should have the name of the player, the short name of the player. The second column needs to have the wage in euros, and I would want to sort this with their salaries. So Germany, from this data frame, I'm selecting only short name and wage, and then I'm sorting this data frame by their salaries, and obviously I'm sorting this in descending order, and I would want to have a glance at the top 5 records. Now if I click on run, you would see that this is what I get. So obviously it is Tony Cruz, whose salary is 330,000 euros. Then Stegen has 250,000. Then you have Sané at 195, and at 5th place you have Müller at 170,000 euros. Now, after this, what I want to do is, from the original data frame, I would want to see who has the best rating for his shooting skills. So what I'll do is, from the FIFA data frame, I'll extract only 2 columns. The first column is short name. The second column is shooting. And I'll extract these 2 and I'll store them in this object called as player shooting. I'll hit on run and I'll go ahead and sort it again. Now, when I hit on run, you would see that Cristiano Ronaldo has the highest rating for his shooting skills. So he's got a rating of 93. Then you have Lionel Messi, then you have Harry Kane, then you have Sergio Aguero, and you have Quagliarella. So these are the top 5 players with highest shooting skills. Now similarly, I'd want to see which player has the maximum defending skills. So player defending. So this time from the original FIFA data frame, I'll be extracting the short name, the defending column, which would tell me his defending skills, the rating for his defending skills. I have his nationality, and I also have the club for which this person plays for. Player defending. And now I would want to sort this by his defending skills. So obviously player defending dot sort values by is equal to defending, and this has to be in descending order. Then I'll hit on run. So you see that you have Chiellini, who plays for Juventus, and he's from Italy. He's got the maximum defending skills. Then you have Van Dijk. Van Dijk plays for Liverpool, and his nationality is Netherlands. Then you have Koulibaly, then you have Gordon, and you have Hummels over here. So Hummels plays for Dortmund. And then finally, what I'd want to do is I'd want to analyze the list of players who play for Real Madrid. So Madrid is one of the topmost football clubs across the world, and I'd want to see what makes this club so special. I want to analyze the, some of the features of different players over there. And that would be the final analysis for today. So what we'll do is, from the original data frame, which is FIFA, I will set the club value to be equal to Real Madrid. So from the original data frame, we are extracting only those records where the value is equal to Real Madrid, and that I'll go ahead and store in this object called as Real Madrid again. Now I would want to see who is the highest paid player in Real Madrid. So Real Madrid dot sort values, and I would want to sort it with respect to the wage in euro column. And when I hit on run, you would see that Eden Hazard is the highest paid player in Real Madrid currently. Then you have Luka Modric. So Luka Modric is the second highest paid. Then you have Toni Kroos, Sergio Ramos, and Karim Benzema. So Eden Hazard plays for Belgium, Luka Modric plays for Croatia, Toni Kroos plays for Germany, Sergio Ramos plays for Spain, and Benzema plays for France. And now we have looked at who are the highest paid players in Real Madrid. Now let's also see who has the best shooting skills in Real Madrid currently. So Real Madrid dot sort values, and I would have to sort it with respect to the shooting column. Ascending is equal to false because again I'd have to sort it in a descending order. And as you see, Gareth Bale has the best shooting skills currently in Real Madrid. Then you have Jimmy Rodriguez, who is the second best shooter, followed by Eden Hazard. Then you have Karim Benzema. Then you have Luka Jovic. Finally, I want to see who are the best defenders in Real Madrid. So Real Madrid dot sort values, by is equal to defending, and I'll hit on run. And here, as you see, so it seems that Sergio Ramos is the best defender in Real Madrid currently. Then you have Casemiro. After that, you have Varane. Then you have Carvajal, and finally you have Militao. So these are the top 5 defenders currently who are playing for Real Madrid. So as I've told you, we'll be working with these 2 libraries. We will not actually require Seaborn. So Seaborn is also another visualization library, which we will not require today. So I'll just delete it from this command. So we would need Pandas. The alias for Pandas is PD. We would need Pyplot, which is a submodule in Matplotlib. And I'm giving this an alias of PLT. Again, let's just wait for these libraries to load. So that is done. What I'll do is I'll actually remove the results from over here so that it will be much more interactive, so that you actually know what is happening over here. Now, let me start off by running this again. And now, if you'd have to load any CSV file, so CSV file is something which has the extension of .csv, and these are normally your Excel files. So if you have a CSV file, this is how you load it. So you write down pd.read_csv, and read_csv is a method in the Pandas library. And we have a CSV file called as character stats, which has all of the statistics of all of your Marvel superheroes and DC superheroes. And this I go ahead and store in this object called as Marvel. Now, I'll go ahead and have a glance at the first few records of this Marvel data frame. So I need to write down marvel.head, and by default, this head method gives you first 5 records which are present. Now you see, this is our Marvel data frame, and this comprises of all of these columns. So you have the name of the superhero over here. So you have 3D Man, A-Bomb, Ape Sapien, Abensure, Abomination. Then you have the alignment, whether the superhero is good, or so basically we are saying if he's a superhero or a supervillain. So that is what the alignment tells you, whether he's good, bad. You also have another category called as neutral. So I guess there are very few neutral characters which are there in this particular data frame. Then you have the intelligence over here. So as you see, 3D Man has an intelligence of 50, A-Bomb has an intelligence of 38, Abensure, Abomination. So all of these superheroes are alphabetically listed. Then you have the strength of these superheroes. Similarly, you have the speed, durability, power, combat, and total. So these are some columns which are present over here. Now, then we will go ahead and see how many records and how many columns are actually present over here. So for that, we have the shape method. So we will write down marvel.shape and I hit on run. And you would see that this has 611 records and 9 columns. So this 611 records tells you that there are 611 superheroes or supervillains present in this particular data frame. Now, going ahead, I'd want to see how many of these characters listed in this data frame. So how many of them are good, how many of them are bad, and how many of them are neutral. So that information will be coming from this column called as alignment. So that is what this alignment column tells us. And this is a categorical column. So all of the other columns are numerical. So as you see, numerical columns would basically mean you have numbers. Categorical column, as the name states, you have categories over here. So if you have to do some sort of analysis on the categorical column, if you'd have to check the frequency of the categories, then we have a method called as value counts. And as you see over here, so first I given the name of the data frame, which is Marvel. Then, so we have this parenthesis. Inside the parenthesis, I given the name of the column, which is alignment. Then I use the value counts method and I hit on run. And you would see that, so out of the 611 characters which are present, 432 of them are good, so we'll consider them to be superheroes. 165 of them are bad, so we'll consider them to be villains, and 11 of them are neutral. So this is some interesting information which we have out of this. And this is a data frame which comprises of both your Marvel superheroes as well as your DC superheroes. So now that we have had a look at the different categories which are present over here, what I'd want to do is I would want to extract all of these good characters from this entire data frame. So out of these 611 characters, I'd want to extract all of the good characters. So let me explain this command properly to you folks. So what I'm doing over here is, so first when I given the name of the data frame, inside this I given the column name. So let me write down alignment over here, and when I set the alignment to be equal to good, what this actually does is this gives me a bunch of true and false values. So wherever the value is true, this would mean that the record over there is equal to good. Wherever we have a false, this would mean that the record over there is bad. So here, as you see, so you have 0, 1, 2, 3, 4. You have these index values over here, and if we go up, so we had true, 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 and false. You had trues for all of these because you have good over here. You have a false for this because you have a bad over here. So this is how we give the condition. Now, out of these true and false values, I would want to extract only those records where the value is true. So what I'll write down is, I'll give in Marvel over here. I'll cut this out and I will paste it inside the Marvel data frame. Now when I hit on run, and if you look at this particular data frame over here, so you would see that I have only extracted the superheroes out of the entire data frame. So this is something interesting which we've done. Now, so again, good.head over here will give me only so what I'm doing is the same command over here, I'm storing it in a new object called as good. Then I go ahead and have a glance at the first 5 records. So again, here you'd have to understand that this is alphabetical. So when we say alphabetical, again, if you have any superhero who has a number, who has his name starting with a number, so that's why you have 3D man at the top. And now I'd want to see which of these superheroes has the maximum speed. So speed over here is a numerical column, and if I'd have to sort my data frame with respect to a numerical column, I have this method called as sort values. So I will write down good dot sort values, and I would want to sort this data frame with the help of the speed column, and I will set ascending is equal to false because I'd want this data frame such that that particular superhero whose speed is the maximum, his record is at the top place and it goes in a descending order. And I'd want to have, so let's actually remove head over here. Let's have a look at the complete list of this data set. So here, as you see, Flash 3. So Flash obviously has the maximum speed. Then you have Jack of Hearts with a speed of 100. You have Impulse with a speed of 100. You have Stardust with a speed of 100. You have Quicksilver with a speed of 100. So seems like there are a lot of superheroes who have a speed of 100. Let's actually see how many of these superheroes have exactly a speed of 100. So what I'll do is I'll again insert a cell above this. Now from this data frame, from the sub data frame good, I have this speed column and I want the speed to be equal to 100. And this I will store in an object called as max speed good. I'll actually have to again store this in a data frame. So let me cut this out over here, paste it over here. Now I will go ahead and insert a cell above this and I'll have max speed good. So it seems like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it seems like we have 12 superheroes who have a speed of 100. So this is quite interesting over here, isn't it? So if you so again, this is, you'd have to keep in mind that this is with respect to alphabetical. So you have Black Bolt, Flash 1, 2, 3, and 4. So again, so you have different versions of Flash over here on the basis of the comic books. So you have, again, Flash is obviously the fastest superhero. His speed is 100. Then you have Crypto, Nova, Quicksilver, Stardust, and obviously Superman. So Superman can fly. So obviously we are assuming that if Flash is the fastest person on land, then Superman must be the fastest person in air. So that could be a reason why Flash and Superman have the same speed level over here. So this is quite an interesting analysis. Now, let's say if I'd similarly, let's say if I'd want to find out all of those superheroes whose speed is the lowest. So you have, as you see over here, there are a lot of superheroes whose speed is only 1. So what I'll do is I'll change this to equal to 1 and I will change this to min speed. So min speed good. So here, wherever the speed value in this good data frame is equal to 1, I'll be extracting all of those records and I'll store that in min speed good. Then again, I will have min speed good over here. So here, as you see, all of these superheroes do not really seem to be, that strong. So all of these values are quite low over here. Their intelligence, strength, speed, durability, and power, they are extremely low. So White Queen, Wizkid, Wandra, so all of these, I'm pretty sure that you wouldn't even have heard of all of these superheroes. So these must be just random characters in the Marvel DC universe who have extremely low stats with respect to this. So similarly, what I'd want to do is I'd want to see who is the most powerful superhero. So we have a tab called as power. So again, good dot sort values. So I'll delete min speed good and over here I'll also delete this. So now from this data frame good, I'd want to this time, so initially we had sorted this with respect to speed. Now I'd want to sort this with respect to power. So as you see, good dot sort value, still here it's the same. It says that when it comes to buy, I am sorting this data frame with the help of this power column, and I'll set ascending is equal to false because I don't want the superhero who has the maximum power to be at the top. So again, let's actually have a glance at only the first 5 records. So here, as you see, we've got these records over here. So you have Zatanna, Thor, Beyonder, Beta Ray Bill, who have a power of 100. So that's quite interesting. And I'm personally a big fan of Thor. So if you've seen Avengers Endgame, then you have fat Thor in Avengers Endgame. So even though he was fat, he was extremely strong. So I personally love Thor's character in Marvel's Endgame. What do you guys think about that? So now, similarly, what I'd want to do is I'd want to extract all of those superheroes who have a power of 100. So here, good. Again, I need to give in the name of the column, which is power, and I will set the power value to be equal to 100. Then again, I'd have to extract this. So again, this will become good. I'll cut this out. I'll paste this in the good data frame, and I will store in, let's say, I'd have to store this in good. Let's just say actually good max powerful. I'm just giving random name over here. I'll insert another cell over here. So let me just good max powerful. And when I hit on run, so seems like we have a lot of superheroes. So as you see over here, we have a lot of superheroes. Let's actually see. Let's actually get the count of this. So again, I'll insert a cell about this over here. Let me see the shape of this. So Control C, Control V, dot shape. And when I hit on run, so you would see we have 33 superheroes who have a power of 100. And that is amazing, isn't it? So you have all of these superheroes, and this is right now listed in alphabetical order. So let's see how many of these superheroes, are actually famous, are actually there in the Marvel or DC universe, or quite famous. You've got Doctor Strange over here, who obviously is extremely powerful. And then, seems like we also have Goku. So if some of you watch anime, so seems like, I don't know if Goku comes under why Goku has been listed over here, but seems like we also have Goku over here. Then obviously we have Iron Man with a power of 100. Then we have Martian Manhunter, we have Marvel Girl, we have Nova, Silver Surfer. Something interesting over here. So if you see, we do not have Superman. So this is quite interesting, isn't it? So let's actually go up and see what is Superman's power. So this is something we had done above. Where was that? Sort values, speed. Okay, seems like we've lost that. So anyhow, so as we were looking over here, so seems like Superman does not have a power of 100. So that is something interesting to find out over here. So we have done analysis till till the power of all of these superheroes. Now what I want to do is, so till now what we've done is data manipulation. Let's actually do a bit of data visualization. So when it comes to data visualization, again we will be needing Matplotlib, and Matplotlib again has a submodule called as Pyplot, for which we have given this alias of PLT. Now I will insert a cell above this, and what I'd want is, I would want to make a simple bar plot for the top 5 superheroes with maximum power. So here we have this particular over here, max power. I'll actually get this again. So here we have this particular record. So as you see, we have the top 5 superheroes with maximum power. Now, what I'd want to do is, if I'd want to make a bar plot of this list, so not actually power. So you see this total column over here. So I'd want to look at the top 5 list of those who have the maximum total value. right? So here, as you see, Martian Manhunter seems to be best when it compares to everything, right? So Martian Manhunter, only when it comes to speed and combat, it is less than 100. For in all other aspects, he's got an absolute 100 over here. And we were talking about Superman. So Superman, it seems that he does not have a power of 100. He only has a power of 94. So this is quite interesting. So seems like Thor is much more powerful than Superman, which is quite an interesting take, isn't it? Then you have Stardust, Thor, and Supergirl over here, and these are the total values. Now, so these total values basically indicate the most powerful superheroes in the DC. And when I say powerful, that would mean with respect to all aspects, with respect to intelligence, strength, speed, total power, and combat. So obviously, if you add all of these, this is what you will get over here. So now what I'm doing is I'd want to have a look or make a simple bar plot for all of these top 5 superheroes across DC and Marvel franchises. And to make a bar plot, first we would need to set the dimensions, and I am using plt.figure, and inside this I have a parameter called as fig size, and I set the figure size to be equal to 8,5. So these are just the dimensions of the image which I'd want to create. Going ahead, if I'd want to create a bar plot, I would have to use plt.bar, and in plt.bar you have these 3 different parameters over here. The first parameter which I give, normally when you're creating a bar plot, the first parameter needs to be a categorical entry, and that is what we are doing over here. So you have good max power. So this is from good max power. First, on the x-axis, I would want to list out the names of the superheroes, and on the y-axis, I would want to list out the total values. So first, I will extract all of the names over here. So as you see, good max power name. So obviously 0 to 5, because I only want the top 5 superheroes with the most total value. This is what I'm giving as the first parameter. Then in the second parameter, I will take in the total value. So this time from the good max power data frame, I am extracting the total column. Again, 0 to 5, because I do want the top 5 columns. And I'll give a color to this bar plot, which is basically green. So if I give in color is equal to G, that would basically mean that the bar plot which I've created is of green color. Then plt.show, and this is the result which you get. So as you see, these bars are, there's not much of a difference, but these are slightly decreasing. So Martian Manhunter, Superman, Stardust, Thor, and Supergirl. So this is a bit of visualization which we have done. And we have done this basic analysis for all of the superheroes. Now let's actually do the same sort of analysis for villains as well. So this time from our original data frame, which was Marvel, I am extracting all of the records where alignment is bad. So as you see over here, Marvel alignment is equal to bad, and I'm storing this in this object called as bad, and I click on run over here. Then I have a look at the top 5 records. So you have all of these villains over here, or super villains: Ammo, Amazo, Airwalker, Abraxas, Abomination. Now I'd want to see who has the maximum speed among these super villains. So again, it will be bad.sort values. And this time by it will be speed ascending is equal to false. So similar stuff what we've done. And as you see over here, so you see that a lot of these super villains also have a speed of 100. So you have Zoom, Airwalker, you have Amazo, you also have General Zod over here. So then you have Superboy Prime. So all of these super villains have a speed of 100, which is quite interesting. Then similarly, I want to see who is the most intelligent among these supervillains. So this time I will sort it by intelligence. I'll click run. And as you see over here, you have Mr. I'm not sure how do you spell this, but this, so Mr. MXYZPTLK seems to have an intelligence of 113, which is amazing.
Then you have Lex Luthor, the villain in the Superman series. Then you have Leader, you have Brainiac, and then you have Doctor Doom with an intelligence of 100. So this is something interesting over here. Then I'd want to see who is the most, badass of all of these supervillains. So again, I would want to look at the total column over here. So bad.sort values, by is equal to total, and ascending is equal to false. So it seems that Superboy Prime seems to be the most powerful among all of these supervillains. Then you have General Zod, then you have Amazo, then you have Dormammu. Dormammu again was the villain in Doctor Strange comic series. So if you've seen the movie Doctor Strange, then you would know about Dormammu from that movie. So it was also amazing how in the end, Doctor Strange was able to put Dormammu in a time hole. So if you've seen Doctor Strange, you will find that quite interesting. So you will see that, how Doctor Strange, who is equally intelligent as Dormammu, was able to outwit Dormammu over here. Then going ahead, what I'd want to do is, similarly, I would want to make a bar plot out of this. So I would want to make a bar plot for these top 5 supervillains over here. So again, plt.figure, fig size, dimensions 8,5. So if you want me to change this, I will maybe change this to, I don't know, let's keep it 10,5. I don't know, 10,5 seems fine. plt.bar. So how to give different colors in the bar. So I'll show you how it's done. So plt.bar, here the first parameter will be the name of the supervillain over here. So that is why I'm giving the name column. Again, I would need only the top 5 records. Next is the total column. Then over here inside color, I'll give in a list of colors. Since I have 5 bars, so I have 5 supervillains for which I'd have to create this bar plot. So inside this parenthesis, I'll give in 5 colors. Let's say the first color is red. Next color I'll give in green. Then I'll give in blue. Then I'll go ahead and give in, let's say, orange. And then final color, let's say I'll give in pink over here. And I have plt.show. Why do we have an error over here? Bad max bar. Okay, let me also run this first. Now let me run this, and as you see, I have different colors for each of these different bars over here. So again, this will come sequentially. So the first bar has the red color, second bar has the green color, similarly followed by blue, orange, and pink. So this was about the supervillains. Now, what I'd want to do is I'd want to make a distribution of speed for all of the superheroes. So I'd want to see what is the range of the speed for all of the superheroes. So since speed is a numerical column, what I'm doing over here is, again, setting the dimensions over here, plt.figure, figure size is 5 and 7. Then I will go ahead and use plt.hist. So plt.hist, which I'll be using to make a histogram. And here you'd have to understand the difference between a histogram and a bar plot. A bar plot is used to visualize something with respect to categorical columns, and a histogram is used to visualize something with respect to numerical columns. And as you see over here, since we have names over here, since we have categories, that is why we've made a bar plot. Now, on the other hand, if I just want a distribution of speed, so speed is only a numerical column, that is why I'm making a histogram. So I'll write down plt.hist. So from all of the superheroes, I am only making a histogram for all the superheroes. Then I'll set the title for this as distribution of speed. I'll set the X label to be equal to speed, and then I'll just print it out. So this is something interesting over here. Let me increase the width. Let me make it 10 actually. That would be interesting. Let me decrease the height. 10,5 would be better, I believe. Right. So as you see over here, most of those superheroes, their speed would be somewhere between, so you have 140 superheroes whose speed would be somewhere between 0 to 10. And there are very, very few superheroes. There would be around 20 odd superheroes whose speed is between 90 and 100. You have two peaks over here. So there are 140 superheroes for a speed of 0 to 10. And there are around 85, or you can say somewhere between 85 superheroes whose speed is between 20 and 30. So this is how the speed of superheroes varies. Then similarly, if I'd want to have a look at the combat for all of these superheroes, again, I'd have to do the same thing. It'll be plt.figure. I'll set the figure size. I will make it 10,5 actually, because it'll be better to visualize. plt.hist. So now this is actually the combat for super villains, because I'm using bad over here. So let me change the comment over here. Let me change this to be equal to super villains, and title as distribution of combat, and here X label as combat. And here you see, again, there are also we have very few superheroes, very few supervillains in general. So out of those very few supervillains, there would be around maybe at max 10 supervillains whose combat value lies somewhere between 90 and 100. And there are around 40 supervillains whose combat is between 0 to 10. And again, you have a peak over here. So there are around 30 odd villains whose combat rating is between 50 and 60. What if I need only some selected columns as an output, not all columns? Sure, I will show how to do that. So let's say from the original data frame, which is Marvel. Now I'll write down Marvel. From the Marvel data frame, if I'd want only the name column and the total column, so this is how I'll do. First, I'll give in this column, the name of this column, then I'll give in the name of this column. Then maybe I'll store it in a new object and I'll call it as Marvel total. I'd have to give in 2 braces over here. Let me cut this out. Let me paste it inside this. Now, let me print out the head of this. So it will be Marvel total.head. And as you see over here, I have extracted only 2 columns from the entire data frame. So you just need to give in the name of the data frame, and inside the parenthesis, you need to give in 2 braces over here. And inside those 2 braces, you need to give in the columns that you'd want to extract. So this was all about the exploratory data analysis for the Marvel and DC superheroes.
Now, let me quickly jump onto this. So we would require like these 2 libraries, which we have learned about. So we have learned about Pandas, we have learned about Numpy. Now I have quickly loaded these 2 libraries. Now I have this data frame called as battles. So this is a CSV file which comprises of different battles which have happened in the Game of Thrones series. So to load this file, I'll just write down pd.read_csv. So this read_csv method helps us to load a CSV file. So this is how I'm loading this file, and I am storing it in this object called as battle. I have successfully stored it. Now I'll have a glance at the first 5 records which are present in this battles data frame. So we have our, this is the first of 2 data sets of the Game of Thrones. So here in this data frame, we have all of these columns over here. So this name which you see is the name of the battle. So we have around maybe 40 odd different battles which have occurred through the 7 books. So you have Battle of the Golden Tooth, you have Battle at the Mama's Ford, you have Battle of River Run, you have Battle of the Green Folk, and so on. This column tells us in which year the battle occurred in. So Game of Thrones was mostly based throughout the 298, 299 and 300 AC years. Then you have the this column which would tell you who is the attacker king. So here for this battle, which is Battle of Golden Tooth, the attacker king was Joffrey and Tommen Baratheon, and the defender king was Robb Stark. So here attacker 1 basically tells you who is the primary attacker. So primary attackers are Lannisters over here. I mean, we already know that the Lannisters have started most of these wars, so this is not really, not really new information. Then we have this major death column. This major death column tells us if any major death has occurred in this war. So let's say if someone such as maybe Jaime Lannister has died or Robb Stark has died. So if there's any major death involved in this battle, then we'll have the value 1. On the other hand, if there's no major death, then we'll have 0. Similarly, we have this major capture column. So if the value is 0, it would mean no major captures have occurred in this battle. Similarly, if we have the value 1, that would mean some major captures, someone really powerful has been captured. Then we have attacker size over here. Attacker size would tell you the number of people who have fought on the attacker side. Then you have who's the commander who is leading the army of the attacking side. Similarly, you have this column which would tell you who is the commander who is leading the defender side. Then you have the different regions in which all of these battles occurred. So let's say if we take this particular battle, which is Battle of the Golden Tooth. So this battle has occurred in Westerlands. So this is some basic information about our data frame. So before we do EDA, it's actually important to understand what is the data about. Now, if I want to know the number of rows and number of columns which are present in this data frame, I'll just have battle.shape. And you would see that we have this value 3825, which would basically mean there are 38 records present in this data frame and 25 columns present in this data frame. Now, some of these columns are not very intuitive. So let's say I have attacker 1 over here. Now, instead of attacker 1, I'd want this to be more intuitive. So I'd want to rename this column from attacker 1 to primary attacker. So for that purpose, I have this method called as rename. I'll use this rename method. I'm using this rename method on top of this battle object. And inside this, I have this parameter called as columns, which would help me to rename this column. So for this columns, I'll pass in a dictionary. Key would be the column which I'd want to rename. Value is to which particular value would I want to rename this column. So I am renaming this column attacker 1 to primary attacker. And when I set in place is equal to true, this would mean that the change directly happens in the data frame itself. Now, once I make that change, I'll just go ahead and have a glance at the change data frame. So you would see that initially the name of the column over here was attacker 1. But after using this particular method, we have changed the name of the column from attacker 1 to primary attacker. Similarly, we have the defender 1 column over here. Defender 1 means who is the primary defender. So here I'll use the same method, which is battle.rename. So rename is the method, and I'm using this method on top of the battle object, and I'll have this parameter columns, and you would see that I'm passing in this key value pair. Key is this particular column, value is to which value I'd want to change this name to. So I am renaming defender 1 to primary defender, and when I set in place is equal to true, the changes automatically are saved in this data frame. Then I'll have a glance at this modified data frame. So you would see that I have changed the name over here. So this was some basic pre-processing for this data frame. Now, if I'd want to know how many times a king has attacked, so I have this attacker king column. So let's say if I'd want to know the number of times Robb Stark has attacked someone, the number of times Joffrey and Tommen Baratheon have attacked someone, then I can use the value counts method, which would give me the frequency of a categorical column. So this is a categorical column, as you see. So all I'll do is I'll have battle, and inside this I'll give in the name of the column, which is attacker king. And when I use the value counts method on top of this column, this will give me the frequency of values. So here it would seem that Joffrey and Tommen Baratheon have attacked have attacked 14 times. So seems like Joffrey and Tommen are mostly the starters of all of these wars which have happened in Game of Thrones. And over here, when we see Stannis Baratheon, so Stannis Baratheon has only attacked 5 times. Then similarly, we have Robb Stark over here. So Robb Stark has started an attack 10 times. Then we have the Greyjoys. So the Greyjoys have started the attack 7 times. So this is a simple information which you can find out about Attacker King. And if I'd want to know how many battles have occurred in different locations, so we have the location column. Now, let's say if I'd want to know how many battles have occurred at Golden Tooth, how many battles have occurred at River Run, then I'll just use value counts again for this particular column. And you would see that Winterfell and River Run have the most number of battles. So at Winterfell, 3 battles have occurred. Similarly, at River Run, 3 battles have occurred. But from over here to here, you would see that only 1 battle has occurred at these different locations. And we have, let's say, we have Storm's End over here. Storm's End again has only 2 battles which have occurred. So that was understanding about those categorical columns. Now that is done, what we'll do is we'll do some basic visualization to understand this data frame better. So to do visualization, we have already imported the Seaborn and Matplotlib earlier. So these are the 2 important libraries for visualization. I'll go ahead and load these 2 up. Now that these 2 are loaded, I'd want to understand, how many, so over here we had looked at the frequency of Attacker King. So now I'd want to know so here what I'm doing is, let's say if a king has attacked, then I'd want to know what is the size of his army. So that is why I'll have Attacker King mapped onto the x-axis, attacker size mapped onto the y-axis, and I am creating this bar plot on top of the battle data frame, obviously. So here this SNS.set, I'm just setting the figure size over here because there are a lot of things which are present in this visualization. So here we have 4 attackers. We have Joffrey and Tommen Baratheon, then we've got Robb Stark, then we've got the Greyjoys, and then we've got Stannis Baratheon. So here, it seems that whenever Stannis Baratheon attacks, he has a huge army size. So if you look at Stannis Baratheon's army size to other Baratheons, or to even Robb Stark, or to even Greyjoy, so if we look at this, so Stannis Baratheon, he would have a size of around 30,000 in general. Similarly, if we look at Greyjoys would have the army, the size of their army would be somewhere maybe close to around 1,000 or 2,000, not more than that. Similarly, Joffrey and Tommen Baratheon, their army size would be around close to 10,000. So this is an interesting observation. So, it seems that Stannis Baratheon had a huge army along with him when compared to other attackers. Now, similarly, if I'd want to know the army size of the defender, so this time, what I'm doing is I am mapping the Defender King onto the x-axis, and I'm mapping the defender size onto the y-axis. Now, when I run this, so these are all of the defenders. So this time we see that whenever, so out of all of these kings, whenever Renly Baratheon was attacked, he had the maximum army size. So maybe in some battle, Renly Baratheon would have been attacked, and in that particular battle, he had an army size of 20,000. Then followed by Joffrey and Tommen Baratheon over here. So it seems that whenever Joffrey and Tommen Baratheon are attacked, their army size is around 8,000 to 9,000. Then we've got Stannis Baratheon. Now compare this to this over here. So whenever Stannis Baratheon is attacking, it seems that he'll have a larger army. But on the contrary, whenever it's Stannis Baratheon who is being attacked, in that particular point, it seems that he'll have a very small army. So this is very interesting, isn't it? So that was about attacker size, and defender size. And now if I want to know what are the different battle types that these attackers have engaged in. So this time I'll be using this method called as count plot, and I am mapping the attacker king column onto the x-axis, and hue basically determines the color of these bars. So the color of these bars is being determined by the battle type. Now when I hit on run, so you would see that again we have the same attackers who are Joffrey, Tommen Baratheon, Robb Stark. So we've got the Greyjoys, then we've got only Stannis Baratheon. So it would seem that when it comes to Joffrey and Tommen Baratheon, they mostly engage in a pitched battle, and it's they have ambushed someone very few times, right? So Joffrey and Tommen Baratheon, they have been in a pitched battle 6 times, but they have only ambushed someone 3 times. But when you talk about Robb Stark, so it seems that Robb Stark mostly ambushes his enemies or ambushes, against someone else. So Robb Stark has ambushed the opponent 5 times. And then you have the Greyjoys. So it seems that it's only the Greyjoys who have engaged in this raising type of battle. Then you have Stannis Baratheon. So here, if you look at this, you have no orange color bar, which would mean that Stannis Baratheon has never ambushed anyone. So either Stannis Baratheon was part of a pitched battle or he was part of a siege battle. So quite interesting observations over here. Now there is another data set. So till now we were looking at the battles data set. Now we have another data set called as character deaths, which would tell me about the different deaths which have occurred over here. So I have this character death CSV file. I am storing it in this new object called as death, and then I'll have a glance at the first few records. So these are the names of all of the characters who have died in the series. So, and this is in alphabetical order over here. So you have Adam Marbrand, who was whose allegiance is Lannister. You've got Adric Humble, who belongs to the Greyjoy clan. Then you have the death year over here. So death year, obviously, it has occurred either at the year 298, 299, or 300. Then you have the Book of Death. So in which book has this character died? So when you have 3.0, this would mean that this character has died in the 3rd book. When you have 5.0, this would mean that this character has died in the 5th book. Then you have the death chapter, which would mean, so in the 5th book, Adric Humble has died in the 20th chapter. Similarly, Aegon Frey has died in the 3rd book in the 51st chapter. So interesting observation again. Then you have the gender over here. So if the gender value is 1, that would mean this guy is male, and if the gender value is 0, that would mean this character is female. And then you have nobility, which would tell you if this person is is actually noble or not. Then you got then you basically have all of these names of different books over here. So this is the 1st book, this is the 2nd book, and so on, which will tell you if this person has appeared in this particular book or not. So that is pretty much it about this. Now what we'll do is we will look at the shape of this. So we have 9, 17, and 13, which would mean that there are 917 records which are present in this data frame and 13 columns present. So overall, we have 1917 deaths. Now, if I want to do a gender comparison with respect to the number of deaths over here, so I will just pass in this gender column and I'll use the value counts method. And here you would see that out of these 917 characters who have died, 760 of them are male characters. So 760 male characters have died, and it's only 157 female characters who have died. Similarly, if I'd want to know how many people who have died belong to nobility and how many of them do not belong to nobility. So this is sort of even. So out of all of the people who have died, 487 are not nobility, and 430 of them do belong to nobility. Then similarly, what I'm going to do is, so this was with respect to the character categorical columns. Now, if I want to understand about the death year, which basically means in which year, how many number of deaths have occurred, I'll use count plot over here, and inside count plot, I am passing in the death year column. So you have this death year. This is the column which I'm passing over here. And when I hit on run, you would see that. So you have all of these years. So these books basically depict this particular decade or this particular time zone from 297 AC to 300 AC. So it would seem that most number of deaths have occurred in the year 100 and in the year 299. So you have close to 160 deaths. So that's huge, isn't it? So you have close to 160 deaths which have occurred in the year 299 AC. Similarly, in the year 300 AC, you have around 100 deaths occurring. Then in the year 298 AC, you have around 42 deaths occurring. So it seemed that there was a lot of peace in year 297. There were maybe a lot of battles did not occur in that year, or maybe people were just more, more peaceful. So maybe you would have around only 5 to 6 deaths occurring in this year. So interesting plot again over here. So after this, now I'd want to know, out of these characters who have died, to which allegiance do these people belong to? Allegiance is basically to which clan have they, do they fight from? So again, for this, I'm using a count plot. Let me zoom this for you guys so that the text over here is clear. This is too much of zoom, so let me reduce this a bit. So if we look at this, so this is none. So you basically, so basically these are people who have died, but the allegiance is not stated. So it would seem that most of the deaths belong to the Night's Watch. So you have around maybe 110 or 115 deaths from the Night's Watch side. Then you have some allegiance over here who have around close to 100 deaths. Then you have the Greyjoys. So the Greyjoys seem to have around 50 deaths. Then we have the, let's say, House of Stark. The House of Stark has around maybe 30 odd deaths over here. But if you compare the other houses, so let's say if you talk about House of Baratheon, seems like very few people have died from the House of Baratheon. And similarly, if you look at the House Tyrell or maybe even House Martell, very few deaths have occurred from their side. All of this is the exploratory data analysis which I have done with respect to the different columns which are present in this data frame. When it came to confirmed cases, Tamil Nadu was at the second place. But when it comes to deaths, you see that Delhi is at the second place. So this again is an interesting analogy over here. And also if you look at this, Uttar Pradesh was nowhere. So Uttar Pradesh, when it came to confirmed cases, it was not present in the top 5 states. But when you talk about the number of deaths, it seems that Uttar Pradesh is at the 5th place. So this is again interesting. So you see that even though the number of cases is not, the number of cases in UP are not as much as the other 4 states, but it seems that there are more number of deaths in UP when compared to other states with those number of cases. So you can call it per capita death of the number of cases. So that seems to be high in UP. So interesting analogy over here. And now that was the number of confirmed cases, number of death cases. Now we'll do a similar sort of visualization for all of those cases which have been cured. So on top of the today dataset, again I'll be using sort values method, and I'll be sorting the dataset with the cured column. I'll set ascending is equal to false. Let me see this. So here, as you see, the number of deaths are maximum in Maharashtra, the number of cured cases are maximum in Maharashtra, and also the number of confirmed cases are maximum in Maharashtra. Again, quite interesting.
So then we've got Tamil Nadu, Delhi, Gujarat, which were also there in the top 4. So the top 4 don't really change. Maharashtra, Tamil Nadu, Delhi and Gujarat are always there. Then we've got Telangana over here suddenly. So it seems that even though the number of deaths and number of confirmed cases are not so much, but the number of cured cases are a lot. So it seems that maybe the Telangana government is doing something better than maybe these 4 states over here to maybe cure all of those patients who've been contracted with the COVID-19 disease. So once we have this, I will extract the top 5 rows again. So max cured cases, I'll have 0 to 5. I'll store this in top states cured. And again, I'll use SNS dot bar plot, and I'll be making a bar plot where state is mapped onto the x-axis and cured column is mapped onto the y-axis, and the data which I'm using is top states cured. And again, the color of the bars is being determined by the state column. As you see, Maharashtra at pole position again with number of cured cases, closely followed by Tamil Nadu and Delhi. This time you see the number of cured cases in Tamil Nadu and Delhi. They are almost similar. Then you have Gujarat over here. Again, there is a very stark contrast. So in Delhi, the number of cured cases are almost equal to 1 lakh over here. But in Gujarat, the number of cured cases are 30,000. So this falls down. The number of cured cases falls down very steeply over here. Then you got Telangana, which was not there in the first 2 graphs. You got a new entrant over here. Now, we'll go ahead with the rest of the part which we'd have to do. So now that we've analyzed all of this, let me go ahead and just analyze some statistics with respect to the state of Maharashtra. So this time from the entire data frame, I am selecting only those records where the state is equal to Maharashtra. So df.state is equal to Maharashtra, and I'm storing this in an object called as Maha. Now let me print this out. So as you see, starting from 9th of March. So starting from 9th of March till 17th of July, these are all of the entries which we've got with respect to Maharashtra. So as you see, on 9th of March, there were only 2 confirmed cases in Maharashtra. But as of 17th of July, Maharashtra is the state which has maximum number of confirmed cases. So the cases have exploded. They are exploding exponentially in Maharashtra. So initially, if you looked at the earlier data set, you would have seen that the first case was found out in Kerala. In Kerala, the first case was found out in maybe 30th of January. So you have almost 2 months over here. So between those 2 months, Maharashtra did not have a case. Their cases started in March. But from March to July, the cases have peaked. But Kerala has managed to stop those cases. So when you compare Maharashtra with Kerala, it somehow happens that Kerala has managed to, if not flatten or maybe at least dumb down the curve a bit. So interesting observation over here to note. Now we looked at this. So what we're going to do is we are going to make a line plot. So earlier we had made bar plots. Now we are going to make a line plot. So I'll use the SNS.lineplot method over here. I will map the confirmed column onto the y-axis and the date column onto the x-axis, which means that I'd want to know the number of confirmed cases with respect to dates, and the data which I'm using is this Maharashtra dataset which I've just created, and the color of this line would be equal to green. So this attribute which you see, color is equal to G. So I'm setting the color to be equal to green, and I'll just use plt.show to plot the line. And this is what we get. So the date, as you see, this starts over here. This is 22nd of March, and this is 22nd of July. So from 22nd of March till maybe if you take this particular date, 1st of June, or maybe we can even take 22nd of June, right? So if we take this, so from 22nd of March till 1st of June, the number of cases are, they're not increasing exponentially. But from this point of time, you see that there is an exponential increase. This part which you see over here. So it seems that from maybe the date between this. So let's say this is around, maybe call it 10th of June. So somewhere around 10th of June, the cases started exploding in Maharashtra. So something might have happened around 10th of June in Maharashtra, which has led to this. So this is about the number of confirmed cases with respect to date. Now we'll do a similar analysis where we'll try to find the number of deaths in Maharashtra with respect to date. So this time I am making a line plot over here. Let me just zoom this again. And this time a line plot where we have date on the x-axis and deaths on the y-axis. Let me run this. And the color of the line is R, which is red. So here, as you see, till this is, we've got 22nd of March till you've got 1st of June over here. And this is 22nd of June. So maybe you can call it somewhere around 17th of June. So here, this is sort of a curve shape, a bell curve, but here what you see is this is just a straight line over here. So something might have happened around 17th of June, which has led to a lot of deaths. So as you see, somewhere around 17th to 18th. So maybe the 16th, 17th, 18th June in Maharashtra, this had a lot of deaths over here. Also, if you see from maybe 17th of June till here, the deaths again, so this line, so this what you see, the slope is not so steep. Here it's just a straight line. So you've got a lot of deaths. So from, this would be around 4,500. So from 4,500 to around maybe 5,500. That's almost 1,000 deaths in just a span of 2 or 3 days. Then from 6,000 to 11,000 again, this again has increased exponentially over here. So this was an interesting analysis of the number of confirmed cases and number of deaths in Maharashtra. Now similarly, we are going to do that with respect to the state of Kerala. So this time from the entire data set, we will be extracting only those records where the state is equal to Kerala. And I'll store the object in Kerala. Let me print this out. So as you see, the first case in Kerala was on 30th of January. But from 30th of January till 17th of July, the number of cases is 10,275. This is very interesting, isn't it? So the first case in Maharashtra was 2nd of March. So from 9th of March actually. So from 9th of March till 17th of July, this is an insane amount of cases. But when you compare that with the number of cases in Kerala, from 30th of January till 17th of July, the number of cases are only 10,275. So it seems that Kerala has somehow managed to, if not flatten, at least maybe dumb down, at least, make sure that the growth is not as fast as in other states. So I have two interesting analogies. One, we have Maharashtra, where we have maximum number of cases. Then we have Kerala, which seems to have, somehow, or maybe we need to give proper credit over there to the folks to the citizens of Kerala who've taken proper measures to ensure that the disease does not spread. Now we're going to do a similar analysis of the number of confirmed cases over here. So I'm going to use SNS.lineplot, where I'll be mapping date column onto the x-axis, the number of confirmed cases onto the y-axis. The color is green again. So here from, this is February. So it seems that from February of 2020 till June of 2020, the number of cases is less than 2,000 till June of 2020. Right? So, but from June of 2020 till
July. So in just a span of, in just a span of 1 month or maybe 2 months, again, the cases have increased to 8,000. So in 4 months, so from February till June, in these 4 months, the number of cases were only 2,000. But from June to July, in a span of the last 2 months, the number of confirmed cases have increased from 2,000 to 10,000. So that's 4 times increase in the last 2 months when you compare it to the last 4 months. So it again seems that, Kerala again has to maybe impose another lockdown to ensure that this does not spread. Kerala has managed till at least the month of June so that, the cases does not spread, but, the cases somehow seems to increase because maybe folks from other states are coming into Kerala and proper checks have to be done. So this was about the number of confirmed cases. Now we will also have a similar line plot with respect to the number of deaths. So we've got date onto the x-axis and we've got number of deaths onto the y-axis. And again, the data is for the Kerala dataset, which we have just created. So this is sort of a bizarre line over here till the month of maybe April. So till the starting of April, you did not have any deaths. And this sort of maybe you had like 2 or 3 deaths over here. Again, maybe 2 or 3 deaths in a span of 2 months. But from, as you see, June till July. So again, till June, the number of deaths were below 5. But starting from or below 10, you can say. But from starting from June till July, the number of deaths increased from 10 to more than 35. I'll just zoom this over here so that you can analyze this properly. So this was an analysis about Kerala. So now we've analyzed this. So we'll just analyze one more state over here. So we have analyzed the state of Maharashtra. We have analyzed the state of Kerala. Now we are going to analyze the state of Jammu and Kashmir. So here df.state, I am extracting all of those records where the state is equal to Jammu and Kashmir, and I am storing this in the object called as JK. Now, as you see over here, in Jammu and Kashmir, it seems that the first confirmed case was on 9th of March, and as of 17th July, the number of cases are 12,156. So from 9th of March till 13th of March, you just had one confirmed case. And on 17th of July, you had 12,000 cases in Jammu and Kashmir. Now we will go ahead and make a line plot for this. So we will map the date column onto the x-axis. We will have the number of confirmed cases onto the y-axis, and we'll set the color of the line to be equal to green. And the data on which I'm making the line plot is obviously this JNK dataset, which I've just created over here. And as you see, from 22nd of March till, we can maybe either take this particular point over here till from 22nd March till 1st of June, the cases are not much. It's, from 0 to 4,000. But from 1st of June till 22nd of July. So in just last maybe couple of months, so in couple of months time, the cases have increased from 4,000 to 12,000. So as you see, from March to June, in 3 months, the number of cases were 4,000. But the next 2 months, the cases have doubled. So this again is interesting over here. First 3 months, it was only 4,000 cases. Last 2 months, it is 8,000 cases over here. Now we'll also see the number of deaths in Jammu and Kashmir over here. So line plot, date goes onto the x-axis, deaths go onto the y-axis over here. So again, maybe we can take this particular point over here, which would be around, let's say 15th of June. Till 15th of June, we can say there were 50 deaths, exactly 50 deaths if I'm not wrong. But from 15th of June till 17th of July, we've got 150 cases more. So again, the first 3 months, only 50 deaths, but the last 2 months itself, there were 150 more deaths in Jammu and Kashmir.
So it's time that most of the states, so it seems that the last 2 months have been very critical in India. Even so Maharashtra, we already know they are already increasing exponentially, but even if you look at states such as Kerala and Jammu and Kashmir, it seems that till the month of June they were able to properly contain the spread of COVID-19. But from the month of mid-June or maybe starting of July, even the states which had properly controlled, seems like even in those states the virus is spreading rapidly. So maybe the government needs to take a quick decision and ensure that there is a lockdown again throughout India to ensure that this does not spread again. So government has to take in also the economic factors as well. So that would depend on that would again lead to a lot of economic loss. So that is something which the government has to think. So now that we have done this, what we'll do is we will go ahead and look at the number of tests done by these states. So till now we have looked at the number of confirmed cases, number of deaths, and number of cured cases. Now we'll see the number of tests being conducted by different states. So I have another data set over here called as state-wise testing details.csv, and I'll go ahead and store this in this object called as tests. So I have all of these different states over here, starting alphabetically from Andaman and Nicobar Islands, going till West Bengal, and these are the number of samples, or these are the number of tests done by the different states. So on 17th of March, Andaman and Nicobar had conducted 1,403 tests, out of which 12 were found out to be positive. Similarly, as of 16th of July, West Bengal has conducted 663,000 tests, and out of them 36,000 cases came out to be positive over here. Now again, from this entire data, I'd want to see only the dates of 15th July, which is 4 days back. Today is 19th of July. I'd want to test the dates of 15th of July. So wherever the date is 15th of July, I'll extract that and I'll store it in this object called as test latest. Now we've got all of these different states, starting from Andaman Nicobar, going till West Bengal again, and the date is 15th of July. And as you see, you have the total number of samples, which is basically the total number of tests conducted by all of these different states over here. Now, what I'll do is, again, I'll go ahead and sort this data set with respect to the number of tests conducted by these states. So, by total samples is number of tests conducted by the state, and I'll set ascending to be equal to false because I want the maximum number of tests done to be at the top, and I'll store this in an object called as max test state, and I'll just print it out. I'll click on run. And as you guys see over here, so Tamil Nadu has conducted the most number of tests. So even though the maximum number of cases were in Maharashtra, so in Maharashtra we had 280,000 cases. In Maharashtra we have 280,000 cases, but the total number of tests done are 14 lakhs over here. But as you see, so it seems that this is interesting if you guys see this properly. So if Maharashtra does more number of tests, it is very likely that there are more, there would be more positive cases in Maharashtra. Now, if you look at this, similarly in Tamil Nadu, there have been 17 lakh tests. Out of the 17 lakh tests, 1,50,000 were found out to be positive over here. Then we've got Uttar Pradesh. Uttar Pradesh had conducted 12,77,000 tests, out of which 41,000 came to be positive. Then we have Andhra Pradesh, which has again conducted 12,17,000 tests, out of which 35,000 came positive. So we've got, then we have Rajasthan, then we have Karnataka. So in Rajasthan, there have been 11 lakh tests, out of which 26,000 came to be positive. Then again, so if you look at this over here, so this again for Karnataka is really interesting. So Karnataka has done 90,000 tests, out of which 47,000 came out to be positive, which is almost half of it. So again, it seems that Karnataka needs to amp up the number of tests, which, to ensure. So again, it seems that there might be cases where people are not reporting. So it seems that out of the 90,000, almost half or more than half people have tested positive. It might also be that there would be more cases in Karnataka actually. Now that we've done this, again, I'll go ahead and make a bar plot for this. So this time I'll be mapping state onto the x-axis, the total samples onto the y-axis, and this would go from 0 to 5. I would want the first 5 records over here, and I'll set the color of the bars to be equal to state, and I'll go ahead and print this out. Now, as you see over here, the maximum number of tests have been done by Tamil Nadu, closely followed by Maharashtra. Then we've got UP, AP, and Rajasthan. So this was all about the basic visualization and basic analysis on top of this data set. Going ahead, we'll build a linear regression algorithm to predict the future number of cases in Maharashtra. So here you'd have to understand this is a very, very basic algorithm. So this is just a prototype which we'll be sort of building. Right, so someone has pointed that it's 9 lakh tests. So sorry, I had read it wrong. It's not 90,000. It's actually 9 lakh tests. So sorry for that. So we are done with the analysis part. Now it's time to go ahead and build the linear regression algorithm on top of our data set. So this time from sklearn.model selection, we are importing train test split. So this would help us to divide our data into training and testing set. Now, once we do that, we will be building the linear regression algorithm on top of the Maharashtra dataset, which I have just created earlier. And on this Maharashtra dataset, we have this date column, which you see. So I'd have to convert this date column into ordinal. Ordinal is basically numbers, because if I have to build a linear regression algorithm, then the linear regression algorithm can't be used on top of date columns. It would require a numerical entity. So that is why I would have to convert this date column to ordinal column. So what I'm going to do is Maha date, which is this particular column, and I'm going to convert all of the values in this column to ordinal. And I will store it in this, I'll store it back to the same column over here, and then I'll have a glance at the first 5 records. Now, if you look at this, you see that the dates over here, so this is 9th of March till 13th of March, those dates have been converted to ordinal numbers. So that date has been changed to this particular number over here, which is 737493. Similarly, the next date has been changed to the ordinal number 737494. And this goes on. Now, after doing this, we will have to create a dependent variable and independent variable. And since we want to predict the number of confirmed cases, the confirmed column would be our dependent variable and the date column would be our independent variable. So the date column will store in this X object, the confirmed column will store in the Y object. I'll click on this. Now, once this is done, I'd have to split the data set into training and testing set. So I'll just use this particular method over here, train test split, which I just imported from sklearn. And in this, I'll pass X and Y, which are my dependent and independent values. And I'll set the test size to be equal to 0.3, which would mean that 30% of the records would go into the test set and 70% of the records would go into the training set. And this would give us 4 objects: X train, X test, Y train, and Y test. X train is the training set of the independent values. X test is the testing set of the independent values. Y train is the training set of the dependent values. Y test is the testing set of the dependent values. Now again, I'll click on run. Then finally, we would have to implement the linear regression algorithm. So I'll be importing linear regression from sklearn.linear model, and then we will go ahead and create an object out of this. So linear regression, I'll create an object. I'll store it in this object called as LR. Now, what happens is this X train and Y train, which you see, those are actually present in the form of they're actually in the form of series object. Let me just print out X train over here and show it how it looks like. So this, what you see, is actually a series object, or maybe even a Pandas data frame, where you have index values. Similarly, I'll have a Y train over here. And as you see, along with the values over here, again, I have the index values. But I don't want these index values when I'm fitting this linear regression model. So I'd have to use np.array method and convert these into single dimension. So that is why I'll use np.array, I'll pass x train, and I'll reshape it to -1 and 1, which means instead of having 2 dimensions where I have index along with the values, I want only the values. And similarly, I'll do the same thing for y train as well. So I have successfully fit the model. Now let me look at the the tail of this, which is basically so here's 737623. So let me go back, 737623. So that would be maybe let's just go back over here. So maybe that would be 17th of July over here. Now let's just go ahead and so 623 would be 17th of July if we add 7 more to it. So 17th of July plus 7 would be 24th of July. So let's say if we want to know the number of cases on 24th of July, I would have to use lr.predict. Now you would have to note that we have converted the date column into ordinal values. So here, when I'm passing 737630, so this 737630 would actually indicate the date of 24th July over here. So 23 is 17th of July. When I give in 30th, this would mean this is 14th of July. And when I click on run, this will give me the number of confirmed cases as of 24th of July. And it tells us that there will be 188,409 cases. But we already know this is incorrect because on 17th July itself, we had 284,000 cases. But this model is telling us that on 24th of July, we'll have 188,000 cases. So as you guys see, we would need to build a much better model, which would give us the correct guess or maybe even the correct estimate of the number of cases which we will have maybe in the next few weeks or next few months. So this what I built is a very basic prototype of linear regression which has given us a random number. Now all of the folks who are new to machine learning or new to data science need to know that when we build these algorithms, it's not necessary that whatever result you get is actually correct. And to be honest, whatever result you get, 90% of the times or more than 90% of the times, the result which you get is incorrect. So that is why data is very important and reiterating or rebuilding of these models is also very important. So this is something which you'd have to work on as a machine learning engineer or as a data scientist.
This brings us to the end of this Python tutorial. Thank you very much and have a great learning ahead.
I want to introduce you to Great Learning Academy, a free initiative by Great Learning. You can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion. Check out the link in the description of the video below. If you haven't yet subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you do not miss out on any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I'll respond to your comments.